Hello, everybody, and welcome to the 6th annual UniCon hosted here by your friends, the herd at Scythe. I am Bryson Bort. I am the founder and CEO of Scythe, and I'm joined by my good friend, Mark Brown.
Hello, everybody. Yep, I run sales and product here, and I'm very excited about today's sessions, and we'll get it kicked off in a few minutes. But Bryson's going to go through and talk a little bit about the strategy and history of UniCon.
Yeah, so I came up with the idea for UniCon back in 2020. I hope most of you have kind of blocked 2020 out of your minds because you're going, oh God, we don't need that again, right? Remember March, I had just finished a keynote with Chris Krebs, who was then the director of the Cybersecurity Infrastructure Security Agency. And we had predicted the coming scourge of ransomware as a national security threat. As you might have noticed, for all of you who do this for a living, yeah, that came true. Ransomware became the problem that we all predicted it was going to be. What we didn't predict was the entire world was going to shut down with the pandemic. And so at Scythe, we sat and looked at that and go, all right, all the conferences, all of this sharing of knowledge of community coming together and working through these problems, how do we help with that? And wouldn't you know that April 9th, today, is National Unicorn Day. Yes, that is a real thing that we did not make up. And so we pushed the team and we debuted the first UniCon in April 9th, 2020. And from there, it had such a great reception that we kept it going each year. Even now that we actually get to come together at all of these physical events, we still are keeping this tradition going because we have had such a positive reaction from the community. So let's talk about what we're trying to do. Look, we're a vendor. We sell something. I think everybody gets that. But I hope everyone has seen that the culture that we try to push here is more than just us. It's trying to bring together lots of different folks from around the community to share what's working and what's not working from theirs. So what I hope we deliver for you today is different practitioners covering different disciplines, all talking about that kind of guidance that you can take and do something with. We don't want you to be PowerPointed to death with this high-level stuff. I'm sure enough of you are tired of going to talks and you're hearing the same 101 on artificial intelligence. I just heard one recently from somebody who's actually very respected, and they gave this 30-minute talk, and it was very basic on like, hey, AI is a problem. You should think about AI and have controls for AI. Well, great. I mean, unless you've been living under a rock, we know that. What can we do with that? So I want today's conference and all of the great speakers who have donated their time to sharing their knowledge, that's the standard that we want to bring. And if we're not meeting that, call us out and bring that back. If we are meeting it and you like what we're doing, please continue to give us that feedback. And you know what? We're doing these regularly. So we did one last September and started to bring it to a biannual. If we get enough of that kind of response, we'll do the same thing. And guess what? Those of you at home, if you have something interesting to share, please reach out. We would be happy to feature those kinds of things as long as it's meeting that standard of, again, helping the community on solving what is an intractable problem. Cybersecurity. How do we solve this? We have to continue to take bites of the elephant because no one has figured out how to eat the whole elephant all at once. Some additional pieces on that. So on Twitter, which is always a wonderful place for lots of different things. Matt Johansson put out a comment. He said, if ODAs are going to get cheap, detections are going to become more important. So I think a lot of you have seen in the news, right? We already have Mythos from Anthropic coming out, and this now is right in a closed session, but the signs of it are going to be that we're going to be able to, the world is going to change because artificial intelligence is going to enhance vulnerability research to the exploitation to that being deployed against us in the wild. So that's the fear of AI that everyone has been worrying about. And so as a result, Matt's comment is, well, that means detection has become even more important, right? If it's even easier to exploit any defensive control that you have, then it's going to be more of a problem for the rest of us because those things you're spending and putting in place aren't going to work. Well, the reality is that was already the problem. That was already a challenge. Your controls will fail. It's the reason that breaches are inevitable. I can tell you as somebody who has done offensive security for 2 decades, nothing stops us if a determined adversary. And there's nothing funnier than breaking into an enterprise through a defensive tool set. I'm not going to pick on any particular vendor, but just using an example, right? Popping a customer enterprise by compromising CrowdStrike, that's a thing. Yes, it's a defensive tool. However, it's code. Code is vulnerable and inherently vulnerable. And then following up on Matt's comment about how detection is going to become more important, John Hultquist, who leads threat intelligence at Google, says people are missing this. But the other factor that is going to come into play is that defeating detections is going to become cheap as well. And I thought about that, right? Because it's really quippy, right? AI is going to make detections more important, but isn't AI also going to be the thing that defeats detections? And this gets back into something that we've seen commercially for a long time, which is how far do we go in terms of testing defense evasion, right? We have these controls. We know these controls are going to be defeated. What do we do as defenders? Because we can't say, well, those controls don't have any meaning. They do. But then what? And so as I thought about that, I was like, well, all right, is he first, is you're just being quippy, but it hit me that this actually goes back to a philosophy that I've been pushing for a long time. When you look at detections, there's essentially two levels of detections you're going to be building in your environment. It starts with hosts, because at the end of the day, an attacker is doing something on your computers. And so the starting point for your visibility is going to be, what do I see on a host? Well, guess what? That's where those defensive controls rely. That's where your logging, all of that starts. Any good adversary is going to be able to defeat your host defenses and your host detections all day long. It's inevitable. So host detections were weak before. They didn't get weaker. It's just going to be a little bit easier for that to be defeated. But here's the thing. Hosts are only one of them. The other part is network traffic. And no 0 day, no O day on the planet can defeat the fact that an attacker has to go to the wire, like everything goes to the wire. Network traffic isn't exploitable. Network traffic, I have to go to ones and zeros like anything else. I have to follow the communication protocol that I'm going to that wire on, which means I can't defeat it. All I can do is blend into it. And so proper detections are now going to be ever more important, that you're properly marrying host level visibility with network visibility. Because what you're going to find is, as they continue to defeat you on the hosts, and supposedly that's going to become easier with artificial intelligence, you're going to notice that gap, because you're going to find network traffic that doesn't correlate, that correlates to a black hole. Guess what? You've now got a detection that can inform a proper response. So you want to worry about AI. AI is not changing the game. The same things and the same approaches for detection engineering will work. The challenge is going to be, how do we properly build good detections, and how do we continue to validate those detections? Because that is the only thing that is going to be guaranteed in the cybersecurity world, no matter what a user does, what a security team does, or whatever preventative controls that you put in place.
Yeah, I think you've teed it up nicely, Bryson. So we've got our keynote speaker here, Carolyn. Let me get her to the stage. Hey, Carolyn.
Good
How are you
morning.
this morning?
I'm doing great. It's so good to see you, Mark and Bryson.
Great. Well, we
I just saw you a couple weeks ago in San Francisco.
I know it is better getting to see people in real life, but this is not bad.
Well, amazing. So I'm going to pop off the stage and let you get your presentation going. So thank you for joining us this morning.
Sounds great. All right. Okay, good. My slides are up. Thank you so much. So, hey, folks, my name is Caroline Wong. I feel so honored to get to speak today at UniCon 2026. I want to tell you actually about a book I wrote recently. Um, this book came out in March. It is April, so it's sort of like brand new, hot off the presses. I initially submitted a proposal to Wiley to write this book in October of 2024. And then I wrote the book from January 2025 to about September 2025. And then recently at the RSA conference in San Francisco, when the book was published, I was walking around meeting with folks, talking to folks like Bryson, and I said, it is so weird, but I finished writing the book 6 months ago and it's already out of date. That's actually how fast things are changing. Um, and so today, I'm literally going to be talking about stuff that happened like in the last 10 days. Um, we're going to look at some things that are changing so much faster than I expected. Not just in theory, but actually in practice. We'll walk through a few real world incidents, um, and then we'll kind of step back and reframe the problem because, in my opinion, what's changing isn't just the technology; it's actually the trust model. Um, it's no longer only about securing our code, our apps, our networks. It's about securing all the different components that our code depends on. Um, and finally, we'll talk about sort of what this means for how we lead as humans, how we make decisions, and how we stay in control of systems that are actually moving faster than we are. So as we go through this, I encourage you to consider holding a question in your mind, not only like what's happening right now in cybersecurity and AI, but what does this change mean for me? Um, so I want to tell you about something that um, I'll be so curious actually to know how many folks are familiar with Project Glasswing and how many folks may not have seen it yet. So, a group of big tech companies, Amazon, Google, Microsoft, Cisco, and some others, they recently came together to launch this thing called Project Glasswing. And so, the reason they did this is because of what they were observing in a new AI model, specifically a model called Claude Mythos Preview. And so what they found is this: AI has now reached a point where it can rival and in some cases surpass human skilled experts when it comes to finding and exploiting software vulnerabilities. So this particular model has already identified thousands of high severity vulnerabilities. This includes in major OSs, in web browsers, in widely used software. Some of these vulnerabilities have been sitting in code for decades. So they had survived years of human review, lots and lots of automated tests, but they were still missed until now. So, in one case, there was a 27-year-old vulnerability found in a security focused operating system. In another one, there was a 16-year-old flaw in a widely used video processing library that's been executed millions of times without detection. And it kind of just goes on and on. And the part that's super crazy is that it did this, much of this, autonomously without a human guiding each and every single step. So when we think about what this means, historically it's been relatively slow and manual to find and exploit vulnerabilities. It really required deep human expertise from kind of a relatively small group of very highly skilled people. And that constraint is actually getting a little bit fuzzy now. The cost of what it means to find vulnerabilities is changing, the speed is increasing. And so there's this potential for the scale and the frequency of attacks to increase dramatically. Certainly in the short term. I do actually think that AI, kind of on the flip side, has the same ability while it's finding and exploiting vulnerabilities super quick and at massive scale. I also do believe it has the chance to kind of fix those same vulnerabilities at massive scale. So as AI is being used to find and exploit, we must of course also be using it to defend. And we've got to do this at scale. And so yeah, that's pretty wild. Literally, when I wrote the book, Project Glasswing hadn't been announced yet. When the book was published, it hadn't been announced yet. But that just kind of goes to show like how quickly things are changing. And so if AI is accelerating how vulnerabilities are found, then I think it's important for us to ask the question, what does that look like in systems where risk is introduced through the things that we trust. So just this past couple of weeks, in the span of like 48 hours, we saw three very different breaches with a common theme. So we had a leak of Claude code, source code, via a misconfigured NPM package, exposing like 500,000 lines and an unreleased roadmap. We had a compromise at Mercer through a vulnerable light LLM dependency. We had a hijack of Axios, one of the most widely used NPM packages, with something like 100 million weekly downloads, reportedly tied to North Korean state actors. So, we're literally decades past thinking about security in terms of the perimeter. At this point, our technology is made of OS components, third-party tools, APIs, and increasingly AI models and data pipelines, which means that any of our systems actually extend far beyond just our organizations and our risk. And so in my book, when I sort of like get a chance to talk to folks about the book, I'll say to folks like, okay, if we're going to read two chapters, the two chapters that are really important to read are number one, the supply chain chapter, and number two, the deepfake chapter. And today we're going to be talking about supply chain, because once you trust something and integrate it into your environment, it becomes part of your system. And if it's compromised, then you are compromised. And so the other important shift is, where does risk actually live? So it's not just in production environments, it's upstream, it's in build systems, package registries, model pipelines, data sources. And one of the weirdest things is these attacks don't look like attacks. They don't necessarily trigger alerts. They don't necessarily break the system. They're actually following trusted paths. They look like normal operations. So I want to just kind of double click on each of these, so we can take a look at what's been happening very recently. So just days ago, a security researcher flagged something that was a little weird in the NPM ecosystem. A package had been published that appeared to contain internal code tied to an AI development environment, referred to as Claude code. And at first, it didn't look like an attack. It looked like a normal package. But when researchers started digging into it, they realized it wasn't just a small snippet or test artifact. It was actually quite extensive. Large portions of source code, internal implementation details, references that pointed to unreleased features and roadmap direction. And then from there, the information, of course, spread very quickly. Other researchers began analyzing the package, sharing findings, piecing together what had been exposed. And within hours, it became clear this was not intentional. This was a misconfigured or an accidental publish event. So one of the things that's super interesting about this is that it wasn't a breach in the traditional sense. No one broke in. There was no exploit chain. The system actually did exactly what it was designed to do. A package was published, NPM distributed it, and anyone could access it. That was it. But the impact was significant because we're looking at potential exposure of intellectual property, insight into how the system's built, and perhaps, most importantly and interestingly, visibility into where the system is going. So, like most supply chain incidents, once something is published and pulled, you can't assume it's fully contained because there might be copies out there, artifacts might be cached, the knowledge is already out there. And so if you haven't read my book yet, I do encourage you to consider getting it, reading it. I talk a lot about supply chain attacks and how they exploit trust, not in code only, but in the systems that we rely on to build and distribute code. And this was sort of exactly an example of that because NPM was trusted, the pipeline was trusted, the process was trusted. All of those things worked, but the trust model failed. And that's actually why these incidents can be so hard to proactively detect and why they're so easy to miss. It's because there's no alert, no anomaly, no clear signal that something's wrong. It just looks like business as usual. Let's go ahead and talk about another one. So in this case, we're looking at a different version of the same problem. So this time, nothing was accidentally published. Nothing was exposed directly. Instead, this issue started with a dependency. So a company called Mercer was building an AI-driven platform, like everyone, and they weren't building things from scratch, like everyone. They were using existing tools to connect to AI models. One of these tools was Light LLM. So Light LLM can be thought of kind of like a translator or a middle layer. So instead of an application talking directly to an AI model, it goes through Light LLM. And Light LLM does stuff like send requests to the model, manage API keys, log interactions, route between different AI providers. So it's super convenient, it's super useful, it sits right in the middle of everything. And that also means that it sees everything. It sees all the prompts, it sees all the outputs, it potentially sees any sensitive data that might go flowing through the system. So here's where things could go wrong. Somewhere in that dependency, something was compromised or vulnerable, and then attackers were able to take advantage of it. But they didn't do it by breaking into Mercer directly. They didn't need to phish an employee. They didn't need to exploit a server. They actually just came in through something that Mercor trusted, which is a dependency. And once that dependency was part of the system, it created a pathway. And then from there, the attackers were able to access systems and data. They later claimed to have taken a large amount of information, including things like source code databases and internal materials. Now, whether every detail of that claim is verified, we're not actually sure right now. What is clear, however, is the pattern. This company did not make a mistake in their application code. They made a very normal decision. They decided to use a widely adopted tool in order to move faster. And then that tool became the entry point. And so this is, again, sort of a topic that I talk about a lot in the book, which is supply chain risk. So many of our organizations are saying, I trust this, I will run this, I will let it interact with my data. And with AI systems, this becomes even more critical because these are not passive tools. They're deeply integrated. They sit between your application and the model. They might be handling sensitive inputs and outputs. They often have access to keys and logs and workflows. So when something goes wrong, it's not contained. It actually spreads. There is a third recent thing that I want to talk about. This one is actually the most subtle of the three. So it started with a library that many developers use every day, which is Axios. And so if you've built anything in JavaScript, you've probably used it. It's a simple tool. It helps applications make HTTP requests, call an API, send data, get a response. That's it. But here's what's important. It's everywhere. There's millions of applications that depend on it. There's tens of millions of downloads every week, and it's not just popular, it's foundational. So if we imagine what happens if something like this gets compromised, in this case, reports came out that attackers were able to interfere with a widely used NPM package and attempt to inject malicious code, not into one company, into the package itself. Now, when we think about how this works, like most developers don't inspect every line of code in their dependencies. They install packages, they update them, they trust them. So if a package is compromised upstream, that code doesn't stay in one place. It gets pulled into thousands of environments automatically and silently and at scale. And that's what makes this one different from the first two things that we talked about. So in the first one, something was exposed. In the second one, something was inherited. And in this third one, something is distributed. So the attack no longer needs to target you. You just download it. If an attacker can compromise a popular dependency, they don't just get one target, they get all of them. And this is the economics of supply chain attacks. Whew. All right, I have to take a breath because that's like so much. And we're going to shift into kind of a different part of the talk now, where I want to talk about something which is more fundamental. I want to talk about accountability because I think that one of the things that I'm not really sure what's going to happen when it comes to AI is that as we're automating more decisions, responsibility is sort of getting distributed or maybe disappearing, except actually not. While AI allows us to make decisions much faster and at greater scale than ever before, accountability does not scale. So, what do I mean by that? In traditional systems, decisions were slow and visible. So a person would review something, a team would approve something, there was a process that would be followed. You could point to who made a decision and why. But in AI-driven systems, decisions are happening continuously. Thousands of small decisions are happening automatically, often without a direct human review. And that's creating a gap, an accountability gap, because the system is making decisions, but the organization is still accountable for the outcomes. So what I don't know what's going to happen is when decisions happen faster than we can actually observe them, we start to rely on the system itself as a source of truth. It's possible to make the incorrect assumption that if the system worked, it must be correct. If it didn't alert, it's probably safe. If it's automated, it must be controlled. And that is an illusion. So the system is operating, but ownership gets really fuzzy. Who owns the risk of a dependency? Who owns the decision to trust a package? Who owns the exposure when something goes wrong upstream? In the three incidents we just talked through, no one explicitly made a bad decision. There was no moment when somebody was like, let's introduce risk today. Instead, there were just a series of very normal decisions. Publish the package, use the dependency, update the library. Each of those things is reasonable, but collectively they created exposure. And so when something goes wrong, there's a very interesting question about who becomes accountable. Is it the developer who published the package? Is it the team that used the dependency? Is it the organization who integrated the tool? And maybe the answer is all of them, because accountability doesn't go away when decisions get distributed across systems. It just becomes more important. And so, in my opinion, AI does not remove responsibility, but it does amplify the consequences of how we assign it. This means we have to be a lot more intentional about who owns decisions, who owns risk, and who is responsible for outcomes, especially in systems where there's no single decision point that exists anymore. So, I think that, organizations really need to be able to answer questions like, who owns this decision? Who owns the risk? Who owns the outcome? If those questions aren't being asked, then there is a lack of accountability. There may be automation without ownership. And these systems are just going to keep making decisions, whether we're paying attention or not, which is weird. The second kind of shift I want to talk about is delegation, because AI is not only changing how we build systems, it's changing how we make decisions. So we're delegating more than ever before. We're delegating detection to models, we're delegating analysis to algorithms, we're delegating decisions to automated workflows, and increasingly, we're delegating judgment to systems that we didn't build. And so at a high level, it sort of makes sense because these systems, they're faster than humans. They can process more data. They can scale in ways that humans can't. So we just delegate. But how often are the humans delegating to the machines in ways where we don't fully understand what we're delegating to? That creates a different type of risk. So when a team is using a dependency like we talked about light LLM, they're not just adding a piece of code. They're actually delegating how requests are handled, how models are accessed, how data flows through the systems, and sometimes how decisions are made. But what if teams don't fully understand what the tool is doing internally, what it has access to, or what assumptions it makes? I don't consider that to be a failure of the team. It's just a reflection of how complex these systems have become. And the more we delegate without understanding, we're actually losing our ability to govern. So it's really hard to set meaningful controls. It's really hard to evaluate trade-offs. It's hard to define what safe even looks like if we're in a situation where we're trusting behavior that we can't explain. So that, I think, is what we've been seeing in some of these recent incidents. These are teams making, what look like reasonable decisions. Let's use a package to move faster. Let's integrate a tool so that we can simplify our architecture. Let's rely on a dependency that others trust. But these decisions are made kind of without full visibility of what's getting introduced to the system. So when something goes wrong, it feels like it's unexpected, but this is actually just a natural outcome of delegated trust without sufficient understanding. So I really think that delegation is not the problem. Delegation without understanding is, because when we delegate, we're still responsible for those outcomes. We can't outsource accountability. So the question that I think we need to ask ourselves is not, can we use this tool? It's, do we fully understand what we're trusting this tool to do? Do we deeply understand the decisions it's making, the data it can access, the failure modes that are being introduced? And then if the answer is not like a resounding yes, then we just don't have control. We've got exposure. And so we've got to be moving fast. We've got to be leveraging AI. We've got to be building on dependencies. But if we don't understand what's being delegated, then we can't govern it. And if we can't govern it, then I think it's very hard to properly secure it. Let's talk about shift number 3, governance. It's really interesting because I did not think that GRC was going to become sexy again. Was GRC ever sexy? I don't know, but all of a sudden data classification matters in a way that, like, I don't know if it ever did because of AI. So thank you, AI, for making data classification sexy again. Our systems have changed, but our governance models haven't yet. Traditionally, governance has been designed as a checkpoint. You build something, you review it, you approve it, and then you just move forward. It's linear, it's structured, and it assumes that systems are relatively stable. But of course, in AI-driven environments, the model is different because nothing is static anymore. Dependencies are updating continuously, models are evolving, data changes, systems integrate and reconfigure in real time. So decisions are not happening in a single moment. They're happening continuously. And what that means is that the risk is also changing continuously. So if we think back to the few events that we talked about in the beginning of today's talk, there was no single point where governance failed. There was no missed approval or skipped step. Instead, what happened was the systems changed and the governance couldn't keep up. A package was published, a dependency was introduced, a library was updated. Those are all perfectly normal events, but there was no mechanism to continuously evaluate what changed. What risk did that introduce? Does this still align with our policies and our risk tolerance? And that's the governance gap. So governance has for a long time operated sort of like a gate, but the system is operating like a stream. And you can't secure a stream with a gate. And so in the book, I do spend a lot of time talking about how governance has to become embedded. It has to shift from something that we do at the beginning or at the end to something that's happening throughout the life cycle. It needs to be continuous. It can't just be periodic. It has to be integrated. It can't be separate. It needs to be adaptive. It cannot be static. Because when it comes to AI systems, the governance question we need to ask isn't, was this thing safe when we deployed it? The question becomes, is this still safe right now? And that's a harder question for most organizations to answer. If you don't have real-time visibility into dependency changes, real-time visibility into model behavior shifts, data integrity, or system interactions. So we have to figure out a way to make governance continuous. Um, Up until this point, we kind of talked about um, incidents, we talked about systems, we talked about risk. And now I want to talk about something different, which is what we humans can do that AI cannot. And the first thing that humans can do that AI cannot is we can judge. Humans exercise judgment. AI is extremely good at recognizing patterns. It's It's really good at processing massive amounts of data, detecting anomalies. It can surface signals that we would never be able to find by ourselves, but it does all of that based on what it has learned before. It operates within patterns. Judgment is a different thing. Judgment is what we use, even when a situation doesn't match a pattern. Judgment is something that we use when something feels off, even if we can't actually explain why. Judgment is what happens when the data says one thing, but the context suggests something else. That's not only pattern recognition, that's interpretation, that's experience, and that's human. This is where AI systems are falling short. AI systems don't understand ambiguity and nuance the way that humans do. They don't question assumptions. They don't step back and ask, does this make sense in the bigger picture? They simply generate outputs based on probability. That's it. There's no meaning. Now, when we think about the incidents that we just walked through, in every one of these cases, the system was behaving normally. A package is published, a dependency is working, an update is installed. Everything was following expected patterns. So from a system perspective, nothing's wrong. But from a human perspective, there were signals because it feels like too much access. The dependency sits in a critical path. The exposure has broader implications. These are judgment calls, and they don't come from the system. They come from people who understand context and impact and risk beyond the immediate signal. So as AI systems become more capable, in my opinion, the value of human judgment increases, not decreases, because the system is going to optimize for what it can measure. But some human has to interpret what actually matters. We have to decide, is this acceptable? Is this risky? Is this aligned with what we're trying to protect? And those are not technical probabilistic questions. Those are judgment calls. So AI can tell us what's happening, but it cannot tell us what it means. What it means requires human judgment. And so I think that is and will continue to be distinct and unique. The second human advantage is context, because data by itself can't tell you what matters, it just tells you what happened. AI systems are super good at generating signals. They can say something changed, something's an anomaly, something doesn't match a pattern, but they don't inherently understand why that might matter. That's context. Context is what connects a signal to business impact, system importance, timing, and consequences. So if an AI system says, this package was updated, that's a signal. But if it's important or if it's not important, that depends. It depends on things like, well, is it a core dependency or a minor one? Does that sit in a critical path or is it an isolated service? Does it touch sensitive data or does it not? Without context, you can't answer those questions. And without those answers, you can't make a decision. Now, when we think about the incidents that we reviewed a moment ago, in each case, there were signals. A package was published, a dependency was introduced, a library was updated. Individually, those are all normal events. Those things happen every day. But the impact wasn't determined by the event itself. It was determined by the context. Because the package contained internal code, the dependency sat in the middle of the AI control plane. That library was used by millions of systems. That's what made them high risk. It wasn't the action, it was the context around the action. And that's where humans still have a clear advantage because we understand relationships. We understand what's critical. We understand what matters to the business. AI systems can surface signals, but they don't inherently understand priorities. They don't know what revenue depends on. They don't understand what systems are mission critical. They don't understand what trade-offs are involved and what trade-offs leadership is willing to make. The thing about context is that it changes as a business evolves, as systems grow, and as priorities shift, which means that it has to be continuously interpreted. So security is not just about detecting signals, it's about understanding which of those signals matter. And that only happens when you connect technical events to business context. So AI can tell us what's changed, but it takes human context to determine if that matters. Last line. The final shift that I want to talk about today is trust, because everything we've talked about today ultimately comes back to this. All of the incidents we talked about, all the risk, all the complexity, these weren't technology failures. These were trust failures, because trust in these cases was assumed and not designed. For a long time, trust in cybersecurity was implicit. We trusted our internal systems. We trusted our developers. We trusted our vendors. We trusted our dependencies. If something was inside our environments, we just assumed it was safe. If something was widely used, we just assumed it was reliable. And if something worked, we assumed it was trustworthy. But that's not true anymore, because modern systems are built on layers of things that we didn't create. Open source packages, third-party tools, AI models, data pipelines. Every one of those layers introduces a trust decision. Now, the problem is most of those trust decisions are not explicit. They may not be documented. They may not be evaluated. They may not be continuously validated. They might just be assumed. We might assume that a package is safe. We might assume a dependency is secure. We might assume that a model is going to behave as expected until something proves otherwise. And by then, maybe it's too late. That's exactly what we're seeing in these incidents. A package was trusted, a dependency was trusted, a library was trusted, and in each case, that trust created access. It created exposure. You do know what they say about assuming. It created exposure, it created risk, because trust in modern systems is not neutral. Trust is permission. It's a decision to allow something to run in your environment, access your data, influence your system behavior. So when we say we trust something, what we're really saying is we are accepting the risk it introduces. And that's why trust has to be designed. Trust needs to be intentional, measurable, continuously evaluated, not assumed. Trust is no longer a default state. It's actually an engineering decision. We have to build trust into our systems using visibility, verification, controls, and continuous monitoring. Because in a world where everything is increasingly connected, every trust decision becomes a part of the attack surface. So if we're not actively designing trust into our systems, then we're inheriting it. And inherited trust is where risk lives. So it's April 2026. It's a crazy time. These next like 2 to 5 years are going to be totally nuts. It's actually like simultaneously terrifying and exciting, in my opinion. AI is changing cybersecurity faster than I expected. It's accelerating attacks, it's transforming defenses, it's redefining how we think about risk, resilience, and responsibility. And what I've found is that we're just trying to make sense of this shift. Not only just about what's happening, but about why it matters and what we need to be doing about it. And the more and more I dig into AI's role in cybersecurity, I keep seeing this pattern. There's this gap between hype and reality. So you've got boards of directors and executives asking, how can AI make our defenses smarter? And on the other hand, we've got actually not that many people who fully understand the new dependencies, the new attack surfaces, the new kinds of risk that these AI systems are introducing. And in the middle, defenders are just getting flooded with noise. There's new tools, there's new claims, there's new buzzwords. I'm just trying to figure out what's real and what actually matters. So I encourage all of us to strive to connect what we're seeing happening at a technical level to what it means in practice. Because AI is for sure reshaping every part of cybersecurity, how attackers operate, how defenders respond, how systems are built, and how trust is established. And ultimately, how organizations are building resilience. This is not a story about fear. This is a story about agency. Because as AI becomes embedded in every layer of technology, we humans still have a role to play in how the systems are designed, in how they're governed, in how trust is established, and in how it's verified, in how decisions are made when things are uncertain. And I think that, by being here and by sharing information and by learning from each other, we are helping ourselves to be better able to navigate what's changing, better able to ask the right questions, better able to lead through this super weird, unpredictable phase. Because in the end, understanding AI isn't just about keeping up, it's about something that's much more important, which is about staying human when everything around us seems to be getting smarter. That's what I've got for today. And I just so appreciate being invited to be here and getting a chance to talk about some of the things that I've been thinking about. I hope everyone has a phenomenal rest of UniCon 2026.
Thank you, Carolyn. Some of the things, I hope you saw the feedback from the audience. I mean, talk about a breath of fresh air. Love the kinds of categories of how you're explaining things. Again, good to see you again, by the way. Hi, I guess I should have
Great
let
to see you too. Hey, Bryson.
So some things that I wanted to pull out there is where you were starting to end there, and you were talking about both it's a terrifying and exciting time. And it reminds me of everyone keeps going back to this, which is the Chinese aphorism. It's the curse, right? May you live in interesting times. And it's said as a curse to somebody because business succeeds on stability. People can plan, plans can happen as we expect them to. We can make investments in things. And artificial intelligence represents a potential disruption in the way everything has always worked in humankind. The terrifying part is how do you secure that? The exciting part on that is cybersecurity as an unsolved space was already the greatest job security you could get. Well, guess what? AI just made more of it, right? And as we were going in the chat, part of what I was trying to push was an understanding of where enterprises are with respect to artificial intelligence adoption, right? They are behind what is everybody's talking about and what individual contributors are doing and what you might be seeing in social media or on GitHub. That doesn't mean large companies are at that pace because they can't be, right? You talked about GRC isn't sexy. Well, that's GRC. We need GRC because not only do we need to be sure that these things work, right? Is it productive? Does it work? Is it secure? And where am I trying to go with it? That's still behind. And so I love that you brought up GRC because I think a lot of folks don't realize GRC is the existential foundation of everything. Business leaders aren't going to make a decision without GRC being check because that is a fireable offense. That is a 100% probability of 100% impact, right? We talk about risk all the time. Your risk management's easy. It's 100% if it's GRC. And so the challenge to the practitioners is, I think, two-part from your talk. One, recognizing there's a difference between what we're doing over here on the edge of innovation and artificial intelligence security and where the corporate overlords are and the way that large corporations have to slowly adopt and work through and why. And then the second part is recognizing the psychology and the mentality of that corporate leadership. Because when you understand that GRC is the baseline, that's where you have to meet them first, and then recognizing who's willing to go above GRC, because security is a process we do on top of that, not in place of.
Absolutely. Totally agree.
Actually, I think this is a funny one. So Carter puts here, so what career do we move to now? Any thoughts from you, Carolyn?
Who knows, Carter? So, when I was 16 years old, my Chinese immigrant father said to me, Caroline, what do you want to study in college? And I said, I really want to study dance because I love dance, or maybe psychology. And my Chinese immigrant dad was like, you're gonna study engineering and you're gonna attend the best school you can get accepted to. And so I went to UC Berkeley. I studied computer science and electrical engineering. And in 2005, the world was my oyster. Today, a person can graduate with a degree in computer science and electrical engineering and have no job prospects at all. And that's wild to me. It's wild. Things are happening. One of the things that I literally asked everyone that I met at RSA if they had a solution to the following problem, and nobody can figure it out, which is that, and Bryson, I want to know if you can figure this out, because I can't figure it out. If AI today is replacing entry-level engineers, then in 5 and 10 and 20 years, how do we grow senior engineers? You know, I spoke to a person who's been running a 500-person software development shop for 10 years, and they've built more than 100 applications. And he told me their entry-level engineers are not allowed to use AI for the first 2 years that they work there. And I think that's radical, and I think it's brilliant. And I honestly wonder how they're going to be able to compete. And so it's just fascinating. I think like there's no way that any of us can predict what's going to happen. I think that the more we learn, the more we empower ourselves. I also know for sure that I've spent the last 20 years working in cybersecurity, a job that didn't exist before the internet. And so there are going to be jobs that don't exist yet that are going to get created because of AI. I don't know what they are. I don't know that you know what they are. But if we're learning and learning and learning and learning and paying really close attention, we'll find out.
So yeah, there's a lot to unpack there. To answer the question from Carter initially, critical thinking will never be out of vogue. And when we look at artificial intelligence in operation, it is still going to be human design, and there's still going to be a necessary human in the loop for operation. Now, the question there is the design clearly still requires critical thinking. The human in the loop for operation, where does that start turning us into a yes/no button pusher, which is, you know, I don't know, the equivalent of being a warehouse worker, but in IT. And so whatever the changes are, I'm 48 years old. I've lived almost half a century. I have seen a lot. Is that if you're smart and you can think, there will always be a role. You can always adjust, right? I look at the same thing when I give advice to founders, right? What makes a good founder? It ain't being smart. Look at me. Being good looking might be one. I got that. But it's agility. It's the ability to go, you know what? That didn't work. How do I change? That didn't work. How do I change? Being able to understand the pattern, being able to recognize the pattern, being able to adopt and break the mold of what you think is orthodox to continue to change. That will never be out of vogue. And you don't need to be a founder to apply that mindset to what you are doing. It's how cybersecurity works best. The second part is to something that Carolyn said too, which is, I love when I get the question, how long have you been in cybersecurity? I've been in it long enough, like she said, where we didn't call it that, right? There were no degrees in cybersecurity. There was no cybersecurity. Like, it wasn't even a word. We didn't talk about that. That's not what we did. It's kind of a relatively new thing. And so recognizing that, the same kind of changes are going to come into this. I gave a keynote at the IC Squared World Congress in 2022, and they asked me to talk on artificial intelligence. And I had this slide, and the slide had a little black rectangle. And everyone's looking at it like, okay. And then the rectangle became a little black box, and they're all going still like, and I'm just sitting there and slowly advancing the animation, and I'm not saying anything. And everyone's kind of like, what's his point? And eventually you saw this little rectangle become a box with a little half circle. And then finally you saw the nominal representation of a human. And my point on this was that generalized artificial intelligence is going to be incremental until there's a sudden moment where it becomes enough of a human in its reasoning and its execution that's going to be the great shift that all of a sudden echoes throughout humankind forever forward. Society will be changed. Everyone that's here, you are ahead of the curve. Being aware of this conversation, participating in this conversation is going to be what helps you drive it. And buying Carolyn's book is even more going to set you up for it. You can send me the $20 in the mail.
I got you. Really appreciate it. This has been so much fun. And thank you so much for bringing together this environment where we can share what we know and learn from each other, because I couldn't agree more. Adaptability and continuous learning is really where it's at.
Hey, Carolyn, by the way, we do have people wondering how they can get your book. So,
Oh my gosh, it's available on Amazon or like wherever you buy books. Like it's everywhere now, and I'm hoping that one of these days we'll do an audio version, but it's also available on Kindle.
awesome. That's fantastic.
You know
Thank you,
what?
Mark.
We're just going to post your, you have an Amazon book page.
I guess I do.
You do. It probably should be updated. I'm going to just note the
It's like
title in
so
there
out of
is
date. That's
an
totally
older
fine. I'll
title.
go update. You know
I
what?
may
Whatever
have
it is.
actually run into your CEO Monday at San Francisco, previous CEO. So here we go. I'm putting it up in chat.
Thanks again, Carolyn. That was amazing. And we will definitely have, for the audience, or they've been wondering, we will have all of these recordings on the Scythe YouTube channel as well. But if you ever have questions, you can certainly ping us directly. So thank you again, Caroline. Awesome. All right, let's get the next speaker up. We've got Michael Haag to join us. Hey, Michael, you are muted. Nope, not yet.
This is why we work in security. We're not good at IT and these kinds of pieces. And I'm still going to throw it out there. I believe that there is $1 billion founder idea on just solving the "Are you on mute?" problem.
It really is.
Any of you can take that. I don't need credit for it. Just go solve the world's problems, please.
Yep.
Well, Michael, we can hear you but can't see you now, so we traded off.
How about now? I can see you.
We do not see you. You are a black box. You are proving my World Congress.
Yeah,
Oh, there we
go.
go.
Oh,
Okay.
there we go.
I turned it off and on.
There we go.
Or you're running Linux. I can't tell.
Maybe. No, there's a Mac.
Well, fantastic.
There you go.
I'll turn you over to Bryson and we'll get your session going, and I'll jump off the stage here.
Cool. I will share my screen.
Yeah, feel free, my friend. Welcome. And Michael is joining us from one of my favorite companies, the Red Canary, if you all still go by that. That's how I will always remember you, having worked with Keith for a very long time and being close friends with Adam Mashinchi.
It has been a long time. I haven't been at Red Canary for about 5 years.
Oh, well, that's even weirder then. So as he drinks out of the Red Canary.
I know. As I was like, well, I guess I'm promoting them today. That's funny.
The floor is yours, sir.
All right. Awesome. Thank you, Bryson. Thank you all for having me today. Yeah, I'm excited to hang out and share. Hopefully this looks decent on your end. But yeah, my name is Michael Haag. Today we're going to be diving into living off the land and the SaaS control plane abuse. If you have not heard of me, that's okay. There's probably lots of good and bad things out there about me. No, I'm just kidding. Yeah, I'm a principal threat researcher here at Splunk. I'm on the Splunk threat research team. You might, if you follow along on content or whatnot, we run a bunch of repos, security content, which we publish to all of the Splunk customers. It includes detection content for living off the land behaviors, all the way up to cloud, Mac, and Linux, and network. So just a little bit of everything. A lot of my work, most folks know me from, is Atomic Red Team and from just other open source projects. I do maintain Atomic. We also run lull drivers and lull RMM, and another one, bootloaders. And if you head to the little website, michaelhaag.org, there's a bunch of projects that probably are partially dead and partially still really cool. Other cool things recently, I shipped a MCP for LLMs called the Security Detections MCP. That one's really cool. And then there's other stuff on there too. My background, I started out as like a sysadmin, network engineer, and then just kind of worked my way up the chain of to like doing lots of threat hunting, SIM content engineering, to doing threat detection at Red Canary, up to today doing threat research and content engineering here at Splunk. So that's the whole piece. So today we're going to dive into endpoint, living off the land. We'll jump into the cloud and look at, where things have shifted over time from endpoint to cloud and where we are kind of today. And then we'll dive into just like a high level run through of Atomic Red Team and how you can simulate these types of capabilities as well, so that you can see if you can detect. So let's hop in. So first, we're going to dive into living off the land. I feel like living off the land is as old as we've been talking about behaviors on the endpoint is still the most pertinent thing today. Adversaries obviously still abuse things that are native to the operating system. And that's sort of the philosophy of living off the land. Is an adversary doesn't need to bring in malware. They don't need to bring in all this custom stuff typically, because the operating system, whether it's Windows, Mac, or Linux, has a lot of native tools built in that allow for the abuse to do something. So whether it's to download a payload from the internet or whatnot, or move laterally using something that's legitimately signed by Microsoft, or using, like on Mac, you're using OSAScript and you're using it to automate a bunch of stuff and download a bunch of things or build, whatever it may be. Capabilities are there. And so adversaries don't really need to bring anything else in. Maybe they do, which is totally fine. But it's the pieces where we start to see them move after. We start to see a lot of more living off the land behaviors and techniques. CrowdStrike latest report, I think it was like 81%, but I'm pretty sure it's like 82 or 83% of breaches they investigated all included living off the land techniques. So lots of hands-on keyboard and or automated things post initial intrusion or access on the endpoint. It still works. These things aren't going anywhere. Endpoint's still here. We're only getting newer versions of Windows, Mac, Linux. Allow listing is just really hard. Most orgs can't just go, large enterprises can't just go and just block everything and then allow everything. It takes time. There's a lot of work involved. We all see, on the defense side, it's, how can we detect someone using or abusing MS Build? Well, it's native, or even install util. It's native. Developers are using it. You can't just block them from doing their jobs. So there's that balance. I call it prevention appetite. Every org has a prevention appetite, and it just depends on how much prevention they can accept for like their CEO down to their developer. Typically, everyone kind of falls into the middle of like, we could block some things, but we can't block everything. So yeah, and we see over time, adversaries begin to move to RMM tools, remote monitoring management tools. They will still use scripting engines. I was just watching Twitter fly by, and it was like, oh, there's this new LNK and it uses WScript. And it's like, okay, so script hosts are not going anywhere. Any admin utility that's native and signed, all game. And then some of the bigger ones is like BYOVD, bring your own vulnerable driver. That is a big one because it grants the adversary full kernel level access on Windows and being able to do anything. Hence the big spike in what we're seeing with EDR killers and AV killers, things like that, because they want to stop your visibility with that. And so over time, we went from kind of like the main bread and butter of the living off the land binaries and script project here in the center, to starting to see a ecosystem of living off the land projects. We now have, all right, low drivers, low RMM, and then it started to branch out into Linux and Mac, and then it began to just kind of expand. We have hijack libs, different tools adversaries use, red teams might be using, living off the land C2s, webhooks, different things like that. Mr. Docs produces some really awesome ones, like this one's living off the trusted site. Just different things that are trusted natively in an organization, whether it's over network or on endpoint. All of these things kind of come and collectively get shown here on this cool site called lol.farm. So living off the land.farm. But it's a great place to go, and we'll talk a little bit more about it here as well and play with it. So because of the living off the land driver project and the big escalation of what we're seeing with EDR killers, at the time, there was no central place to find malicious or abused drivers in the wild. We had the Microsoft driver block list, which was cool, but nobody really had a place to go to see like what else there really was out there. And so we developed this project loldrivers.io. It's meant to help defenders and researchers go and understand what else is out there. We also correlate and identify ones that still load on Windows. So there's about, I think there's like 1,800-ish, maybe 2,000 drivers in the project today. We outline what they are, give you all those details. But the big one in the YAML files of the project are, do they still load despite HVCI being enabled on Windows now? It's a big differentiator from 2,000 drivers to roughly, I think it's like 300 drivers. So about 300 of them in the project today will still load on a patched up Windows 11 machine. Microsoft doesn't block them. And so LOL drivers, we provide a block list in multiple formats to help you with either detecting or going and blocking. So you can search for them across your fleet. If you have the EDR telemetry, you can identify it that way. Adversaries love drivers. And I think right now what we're seeing is that more and more of them are going to be used and abused here. A recent EDR killer just came out. I think it was called Poison Killer last week, targeting Windows using a WHQL, a very heavily signed Microsoft driver that is now being used and abused to kill EDRs. So it's very, very popular. But very recently, which I think is really cool and I want to highlight, is that starting this month on our Patch Tuesday, Microsoft is now going to be killing off cross-signed drivers. And so when I saw this, I was like, this is very, very exciting, because not only do we get to see a lot of these malicious drivers and whatnot get kind of like killed off with natively in the OS, it means a lot of LOL drivers becomes almost obsolete. Unfortunately, okay, so total drivers in the project, about 1,900. Most all of them are cross-signed. So about 81% of them are cross-signed. 20-ish% you're still looking at, they still load despite HVCI. The deep down piece on Microsoft blog was that what they will do is they move your machine to like an eval mode. And as it sits in eval mode, if it identifies drivers being audited because they're cross-signed, they will keep you in eval mode basically for a long time, until forever, until you remediate that driver. So you need to be able to inventory, you need to be able to identify and patch that driver. And if you don't, you're just going to sit there thinking that you have this cool feature enabled and blocking. Reality is most orgs, large enterprises with so much software, we won't see a lot of this move to enforcement, which is unfortunate. But it also does not resolve the rest of the living off the land landscape. There will always be binaries on the disk that Microsoft uses and all other software applications out there use too. CertUtil, MSHTA, Run DLL32, and RMMs. So a lot of the things in the ecosystem for living off the land will always exist. Whether drivers get reduced, we'll still see living off the land always out there. And so it's kind of the beauty of living off the land is that the OS pretty much has it. All I have to do is show up and start running things and persist and last a long time. So with like LOLBAs, right, we have native utilities. We've been talking about CertUtil, Run DLL32, things that typically can't be blocked. And this is the biggest component out of living off the land, is being able to understand what is running in your environment. The project's there to help you and take it from like, oh, this could be abused. How is it used in my environment? And it should help you go and inventory, look at process, command line, who's running it, and then hopefully leads you to a place of being able to block those things. You can't block all of them because the OS needs them natively, but there are definitely a large majority of LOLBAs project you can block. Similarly with RMM tools, adversaries love it. We're constantly seeing them call up, hey, open up, AnyDesk and give me your code and I'll help you troubleshoot, your failing machine today, and the rest of them. And so these things are highly used at this point today. So with the RMM project, we wanted to have a central place because there really wasn't one that allows folks to be able to go to, get the list, scan your environment, search the fleet, identify if you're using 1 or 20 RMMs, and if you can, try to block as many as you can. There's obviously other controls in place with like network egress points and whatnot, but so hopefully it helps and get it out there to start reducing that attack surface for living off the land. So kind of on the endpoint, hopefully everyone's a little level set with all the living off the land side. But with the cloud, things got interesting. And I feel like over the years, we knew about cloud, we saw cloud expanding, we saw Azure, we saw AWS, we see all these things happening. And then it's like, oh yeah, defenders need to catch up and keep pace too. It's a really, really tricky spot. And the use case we'll use is when Microsoft got compromised by Midnight Blizzard. And so adversaries are way ahead on the cloud side because they can hit it through a proxy, they can spam M365, they can hit mailboxes from anywhere around the world. It's no longer just like an on-prem box. I mean, as much as they can hit it from the outside, it's just something that's accessible, has an amazing graph API, things like that, right? It gives them so much capabilities. And then there's like Okta and these single sign-on tenants and these products that grant an org accessible access to their tools, but also accessible access for an adversary. So kind of the biggest piece, right, is that the endpoint is a great starting ground, but it's like heavily guarded at this point today, right? You got your EDR, you got your AV, you got all these other monitoring tools, privilege access management things, and you got all these things stuffed on there, you know, and you're like, all these noises and bells goes off when someone runs PowerShell. Hopefully something rings. So on the cloud, it's a lot different. It's now kind of someone else's environment and infrastructure, and you have to hope that whoever's hosting it for you is doing the monitoring and the security of things. You might lock it down through MFA, but that's kind of like where a lot of it happens, right? You get MFA, you get OAuth, you got some SSO built into it, but there's no like parent-child relationships. There's no longer a command line or a module load. Like it's completely different as far as how the logging is going to come out of this. Typically with cloud breaches, they're all using valid credentials and or a stolen token. There's no need for me to run PowerShell anymore on someone's endpoint to download a payload. It's all just in the cloud, someone else's system. All of these things are leading up to what we've been seeing more. We're seeing a lot of OAuth device, kind of like phishing now, anything to grab that token and then be able to move into that org's environment. Consent, app consent was a big thing for a little bit too. Getting you to approve something to allow me global access to your Microsoft, Azure environment, things like that. It's big access with very limited logging. And we saw this when Midnight Blizzard had got Microsoft, right? And so there was a test tenant, adversary found it, and they were like, yeah, we're going to go for it. And they ended up getting in, had no multi-factor on the account. Turns out it had full access to the internal one, which allowed them, had that legacy OAuth app, had full consent, cross-tenant permission, being able to pivot into the corporate and do whatever they wanted to do. Create more apps. So they created another one as their backdoor. They created some users. They granted consent. They were able to do everything on their own at that point. But it's like, where were the logs, right? And so at the time, if anyone remembers, this was back in 2024, Microsoft was like, oh yeah, we don't enable those by default. And you got to pay for like E5 if you really want those logs. And it was like, everyone was like, wait a minute, like, this is happening and you're not going to help us. And if you remember, I think it was like CISA, they had to go to like Congress and explain all this. And eventually they opened it up. You still have to like get those logs. So there's a whole piece to it still that is very important. This just kind of shows the complexity of getting data out of a cloud environment is not the same as just popping an EDR on Windows and grabbing app logs or grabbing, full process telemetry and things like that. It's just so different for an organization to have to deal with at this level. Thankfully, as time has progressed since 2024, we've been getting a lot more data from Microsoft, and you also get better graph API access to query things and understand things better, what's being authorized. They have all these pop-up boxes left and right, and the UI alone is so complex that I don't think adversaries can figure it out anymore. But there's a lot more to it now. And so at Splunk, we wrote a blog. Mauricio and I, we worked kind of like side by side on this cool blog related to the group. And we wrote a bunch of content related to these particular failures and events. And so if you haven't like gone through the rounds of trying to identify or even scope out your cloud infrastructure, like what could you do? So big thing is trying to get those service principal logs into somewhere where you can identify, that type of behavior occurring. Audit the applications that you're allowing in Azure or in Intra. You want to know what's in there, whether you're going to turn them all off or not, but just being able to understand what's been consented across your fleet and the permission sets they have. One of their backdoors was we added an account or we added a token or whatnot to another already full privileged user or access to it. So they had full access again, whether you took out the first, they still had access to another app. So just different things like that. Get these logs, try to review permissions. That's probably one of the hardest things to do with cloud is where do I go to find these things, right? So hopefully it inspires folks to go after. And we're also not just seeing heavy nation states, performing lateral movements between cloud platforms. We're also seeing like groups like Lapsus or Scattered Spider over time, doing kind of like a very off endpoint access where it starts with like SIM swapping, SMS phishing, MFA fatigue bombing. Saw that really heavy with Okta over the last few years, to like a Lapsus type group, which is, I guess they're all like renamed now, but there's all this stuff. But cloud native extortionists, right? They lock it up, they take everything they can. They live straight off of the cloud. There's no need for them to ever touch endpoints. Scattered Spider is probably a little bit different because they actually did go down to endpoint and started running things. But a lot of their activity, they did a lot of Okta impersonation. So they'd spin up a fake looking Okta portal and get you to log into it, take your token and then run with it. But there's no need for them to truly get on the endpoint because your cloud access through Okta has everything they will need to get access to and extort you and gather all that data. So big time. So kind of the true cloud living off the land like playbook that we see consistently over time. We're seeing more and more of consent phishing. So please consent me this access to gain into your environment, or you need to authorize this thing. You're like, oh yeah, sure. Whether it's email or text, they now have full access, or they gain a token to get into the environment to do what they need to do based on your permission set. We still see a lot of password spraying with cloud. It's kind of tricky to detect because again, it's not just hitting Active Directory. You know what logs to look for. There's event IDs. It all makes sense. It's not really like that. Looking for obviously accounts without MFA, and in Microsoft's kind of sense, looking for legacy, anything that's going to be just resident for a long period of time. And yeah, I haven't seen this in a while, but like golden SAML or token forging and things like that. It's been a bit since SolarWinds, but that kind of stuff is still there, but it's most likely going to be heavily more detected today, taking tokens and whatnot. Lots of backdoor creation. Like I mentioned with Midnight Blizzard, their idea is that we'll just keep adding things into different apps that have been consented over time. I just persist. How do you detect that? How do you monitor every single app, say a large enterprise? How are you going to go through and track all that, things being added over time and in the middle of the day when everyone else is working? It's a lot. And then, yeah, even just living off trusted services. Those are very popular for adversaries, whether it's using like webhooks and whatnot. We see projects spin up all the time on GitHub where they're now posting to like GitHub pages and comments or issues, and they're iterating on how their C2 responds to it, things like that. It's all very popular living off trusted sites. So now we talked about our endpoint problems. We talked about our cloud problems. I'm going to switch over to our simulation with Atomic Red Team. Cool thing with Atomic Red Team is that this is something if you have not heard of Atomic Red Team, you can spin this up today, hopefully on your corporate device with admin credentials hitting your corporate Active Directory. All right, that's the warning. Nobody do that, please. And I mean, it's a good way to get people moving. But Atomic Red Team is a pretty large library today. Like I said, it covers Windows, Mac, Linux, and we added cloud over the years. So there's Azure, AWS, GCP, and 365. There's a bunch of tooling in there to get you set up and testing across endpoint and cloud. And everything is mapped to MITRE ATT&CK, so you can hit your tactics and technique IDs, pick them and choose them however you like. This helps you in identifying if you have coverage for something across your cloud or endpoint environment. These are very point tests. They're atomic, so it's meant to just be run one. You can get crafty and chain them, do like a chain reaction. You could chain them up and you could run a bunch at once and then generate a lot of noise and then go and see what you have coverage for, or if there is any coverage or visibility across the board. This is a great way to test your intro environment, making sure there is visibility into those types of behaviors happening. If you were to password spray your environment, you may or may not see anything. Let's find out why and then dig in. So a lot of folks use this. A lot of organizations adopt it, and they might integrate it with other tooling that they have and help them with like purple teaming and whatnot to get them ready for a full-on pen test. And then quick blurb, we run a little show called Atomics on Friday. You can hit it up on YouTube and LinkedIn. It's Atomics on Friday. But we will walk through a bunch of like testing and demos and things like that. And so, we can go back. So on the right up here, it's as simple as installing install module, invoke atomic. The invoke atomic red team is a test harness that is written in PowerShell. So once you install that, you can just start passing technique IDs or numbers, names, and then just start shipping things down the range and go and see what you see. See if you can see anything. So simulating a very simple living off the land based attack. If you take two types of tests here, these are T1218s, compiled HTML file and MSHTA. We see a lot of MSHTA today still. If you look at Red Canary's latest threat report, if you just Google all the things about ClickFix, they're still using MSHTA. It's such an easy technique for adversaries to abuse. And we have like 10 or so tests in Atomic Red Team for you to just run. And they're all variations of how MSHTA can be abused. Similar with our CHM file on the left over here, this test uses HTML help hh.exe, which will then download or spawn or do different things. Not so much used anymore these days. Those two particular atomics, these are really good entry ways to blocking these and helping you to reduce that attack surface even more. You can't block things running out of run and whatnot. You can't stop certain things here and there, but these two particular binaries typically can be blocked in an organization. Similarly for cloud, there is a little bit of a setup on Atomic Red Team to attack your cloud environment, mainly just getting keys and creds. Start with no privilege and start with low, then medium and high privilege, and just kind of see the difference of the behaviors you will get in the logging. So we do have a password spraying atomic. There's some app hijacking using service principals and app registrations. You can go through some cloud account creations and then role assignments just to kind of change things around, move things around in the cloud and see what it looks like in your logs. You'll notice pretty quickly, there may or may not be much logging there from Microsoft, not your fault. It's just the way the data shows up and the way it flows. So it may not be perfect, but that's kind of how you have to identify, right? We need to know what we can see. So talked a lot about different things at a high level. What you need to see is on the endpoint, whether you have an EDR or you're using Sysmon. We talked about lull drivers, service create events, someone adding new drivers to a box or adding new services, things like that. You want to be able to track these things, use the tools, use these projects to help you in identifying, do some inventory across the fleet, see what you can start blocking if you want to stop these attacks, or at least set up the monitoring and alerting so you can detect it over time. RMM is such a great project in the sense that, hey, we only use Screen Connect or we only use BombGuard. Why would we allow the other 300 RMMs that are known out there? That's a really good way to just start blocking something out the gate. And then with the cloud, start identifying the logs you're going to need. Maybe just start with Atomic Red Team and just hit the environment and just see what you can see. If you can't see anything and there's no events flowing, whether into your on-prem SIEM or Cloud SIEM or Microsoft Sentinel, maybe it's worth going and identifying how we can be better at that and then write content for it. You can use Splunk security content for that. Lots of content out there across all the different platforms, Sigma and whatnot. All of that can help you build up your capabilities to identifying the behaviors occurring in your environment. So that was me. Monday's coming up. I think it's coming up. It's Thursday, it's Friday somewhere. Kind of the biggest thing, right, is that, map your exposure, look your cloud identity hygiene, whether it's Okta, where these things are coming from, where's the access points. If it's a giant single sign-on with everyone has access to all these cool apps, adversaries love that stuff. They're going to go for it. And you probably won't even know it because it was Bob who logged into Bob's account from a random location and is accessing all his apps, just doing Salesforce. Check out Atomics, simulate before someone else comes and does it for you live. Unfortunately, you don't get reports from adversaries about how good your infrastructure is or how bad it is. So you kind of have to do it yourself these days. And then logging, get data, get as much data as you can. Unfortunately, it costs money for a lot of these products, but if you can get the data flowing somewhere and or being able to add logic to detect things happening, it will really help you reduce that exposure. And I highly, highly challenge everyone out there listening that you can block RMMs, you can block LOBAs. And if you're not, look into it, identify which LOBAs are actually running in your environment. If there's like 10, why would you let the rest run? Just something to think about with that attack surface reduction. And yeah, go build something. I love sharing projects. I have a lot of projects. So I highly recommend, if you're digging into cloud stuff or endpoint stuff, there's a lot of projects today out there. Blog it too. People love reading blogs about all these types of behaviors and techniques and how they can detect things better. It helps the industry as a whole so that we can all be better in preventing adversaries and stealing our stuff. So yeah, thank you so much. Thank you all for having me. Thank you, Bryson, Mark, everybody. I really appreciate it.
Thank you. And so some of the comments are, folks are still learning about living off the land.
Cool.
And I think folks don't realize that because most of living off the land doesn't get the news headlines, right? Latest hack, XYZ. And it's like we bang on SolarWinds, we bang on Kaseya, and we focus on the latest vulnerability that attracts all the attention. When the reality, and I loved when you also made the comment about consent phishing, is the stupid tricks still work. They will always work for lots of different reasons, right? At the end of the day, it's users using computers. People are still going to people. You will never be able to solve the people part of the equation. And that's why we need to address, okay, if somebody clicking on a fish burns your enterprise to the ground, that is a knock on the security team, not on the user. And that's why the work that you're doing is so fantastic, because what do they do after they break in? They use the things you've already given them. Why would I spend the time to code something and spend all this time creating the next Stuxnet when I can just run a PowerShell command and own Active Directory and I have everything? I don't need to do anything special. Hackers are lazy. They will do the minimal amount of effort that is required to accomplish the mission. And when I say hackers, by the way, folks, I'm not talking about the picture of the 400-pound guy sitting in his mom's basement. Hackers are a professional occupation, primarily led by military and intelligence organizations. On the consent phishing, my favorite, because everyone, gets do MFA. You'll solve all your problems. I will tell you as an offensive guy, MFA has never stopped me once. So when Michael made the comments about consent phishing, you know how you get through MFA? You just keep doing it. Click, no, click, no, click. No. You know what? Yes. The pop-up went away. I can continue my job.
Happens all the time.
Works all of the time. Do you have any more little anecdotes like that?
Probably not off the top of my head.
So living off the land works. Why does living off the land work, right? I put a pop quiz in there and I said, why drivers, right? You had the part about drivers. So we got, and I'm going to give credit to Noah. Noah pointed out, he's like, well, drivers have direct access to hardware. Awesome, right? Generally going to be below what your EDR is able to look at and work at. But what's the other part why drivers?
They grant an adversary full privilege on the endpoint. And typically what happens with drivers is that AV will not inspect a driver heavily because it will blue screen the box. And
that's
so
the tricky part, right? So keep going, sorry.
No, that was it. Yeah, it's basically just why a lot of orgs won't block them or AV will stop them because it will blue screen the machine. You don't want you don't want the CrowdStrike instance to be on your hands at a large organization.
And so drivers are an example of, again, if I get it wrong, I'm going to cause a blue screen. I'm going to cause a screen default. So what does that mean in reality? We're talking about an enterprise user trying to do their job. I work in finance. I'm trying to make payroll. I work in HR. I'm trying to fire you. These are apparently normal functions that we need to do. And when it blue screens, that doesn't work. But here's why this is so tricky, right? This gets into, there's really two classes of controls that we can implement. Prevention, what can I stop? Detection, what can I see? And everybody says, well, let's have more prevention, right? Let's stop that driver. Let's stop that DLL. Why it's so hard is, as Michael was talking about, the technical intricacy of it, but think about it from the enterprise management side. How do I manage all of those drivers? How do I know what drivers are good and what drivers are bad? And something back to what Carolyn said, right? Attackers don't show up with the evil bit turned on saying, hey, I'm doing an attack. This looks like an attack. They blend in with the fabric of your enterprise, of your tools, of your hardware. That's where drivers and DLLs live. And so the prevention is inherently always going to be a limited capability because it's so hard to maintain and get it right. Because when you get it wrong, well, it's in the name. It prevents, and it's going to prevent good things as well as bad things. And you can't stop too many good things before you get fired or get ripped out.
Yes.
So detection is the key piece here. And so the other piece that I love that you presented, this is why I wanted you to come on, was Atomic Red Team, right? Atomic Red Team is the starting point for, I think, anybody who's starting to get into offensive security when you're looking at Purple Team, as you noted, or controls validation, right? Looking at those preventative and detective controls, what's the limit of what I can stop? And more importantly, how do I start to enhance my visibility for action, which is what detection is doing? Are there any other tips that you'd like to offer in terms of getting folks further along that living off the land? I know you just gave a whole talking like, Bryson, what more do I got? But I know you're really smart and you've got a depth of knowledge that cannot be fully encapsulated in such a short talk.
Honestly, the biggest thing I think is if you aren't testing yourself, get involved with the Atomic Red Team has a Slack group you can join. Test yourself first, see what happens, and then as you see new threats occur, kick off creating your own atomic test and contribute it back. You'll see that it helps not just you, but helps everybody. And that's kind of the big piece with Atomic.
So Atomic Red Team is built by the community. Guess what, folks? You're the community. No one alone can do any of this. And so get involved. And if you see something that's interesting, share it back so that others can benefit from an Atomic Red Team test.
Yes.
If you have a book to sell, I can push that. But for the moment, I think Atomic Red Team is as far as we go. Really appreciate all of your support, and what a fantastic presentation.
Awesome. Thank you, Bryson. Appreciate it. Thank you,
Yeah,
Mark.
Michael, thank you very much. For those of you guys on the stream, we are going to be taking a break, allowing most of you guys, many of you that joined from the East Coast, to grab a lunch. We will be picking back up at 12:55 with Michael Brunetti, and we will see you guys in about 13 minutes or so.
Awesome.
With that,
thank you all.
We'll sign off for a bit. Thank you.
Let's have a good day.
All right, we're back. Hopefully everyone was able to get a little bit of lunch right there for those of you on the East Coast. And we will queue up the next session. Any comments before we get into Michael's Bryson?
Let's get Michael going.
All right, let's add him to the stage. Hey, Mike.
Hi, guys. How are you today?
Good. How are you?
Every day is a holiday. So is that your actual background?
That is my actual background.
I think you win. You win.
Actually
You win the background Raider Awards is back. You win.
Appreciate that. Yeah, we work in this remote world nowadays, and got to have something good to look at when you're looking at yourself in those cameras all day, every day.
Well, fantastic. I'm glad you could join us. We will turn the stage over to you and let you dive in. I will get your slides up and let you get into it.
Thank you. And thanks everyone for attending, and thanks for having me on, guys. I'm going to try to spend a little under an hour here talking about something very near and dear to my heart, trying to help people understand how businesses are affected by ransomware, and talk more about how to be prepared and how to be ready for when this happens. It's not just about backups, right? We're going to talk about how threat actors get in, talk about what happens as an organization is impacted with ransomware and the different types of ransomware, and then how and what you do to get a company back up and running. So I'm Michael Brunetti, the VP of Incident Response here at Mox 5. I've been doing this for a little over 7 years now, and living the world of jumping into environments that have been completely devastated by threat actors, CEOs and owners of businesses that are worried that they don't know if they're going to be able to get their environment back up, and their business, they might lose their business based off of what these threat actors do. We come in, we're here to help. We bring order to the chaos that is ransomware, and bring in the right resources to help out, get environments back up, get their business back running, and secure them so this doesn't happen again. So kind of talking into the meat of what we're looking at here, really want to talk about the cost of incident response is massive. We are seeing day in, day out, more and more companies getting hit. We're talking about AI. It's developing quicker, and they're adapting and changing the way in their tactics. And it's getting hard to keep up with what these threat actor groups are doing. A typical ransomware victim is, if you look at the numbers here, if you are not really prepared, if you haven't run tabletops, if you're not thinking about this at least once a quarter with your security team, you're going to be spending in the millions of dollars for that response. And that's going to be due to a few different factors, right? There's going to be, if you do not have good backups, you might have to pay that ransom to get your data back unlocked from the encryption. And you might have to pay a ransom. That might be a few $100,000 after negotiations. You have the time for privacy counsel, internal people. So you have the lawyer's fees that you have to pay. That might be a few $100,000. You have organizations like Mox 5, where we do the forensics and the restoration alongside your resources. That might be a few $100,000. But the big one that a lot of people don't realize is the time to get up. You have the business loss, the revenue that the business would be generating, you're not able to do during this time. So the large chunk of these multi-million-dollar ransomware costs come to business interruption. And really, our goal as incident responders is to securely get an environment up as fast as humanly possible to reduce that amount of business loss. Because a lot of the times we're working alongside insurance carriers to do an insurance claim. And that's the biggest part of the claim, is going to be the business loss portion of that, and try to reclaim some of that revenues that was lost based off of the infrastructure and services that are down. So you see on the left side, the response cost almost $3 million for a manufacturing firm of 2,500 employees. This is an organization that doesn't have the most mature cyber controls. They have legacy systems, or they have misconfigured, or they don't know all the assets within their environment, and they don't have proper coverage of maybe quality tools within their environments. They have gaps. Versus someone who's a well-prepared peer, we're seeing on average almost a 5x, 6x reduction in the total cost if you have run tabletops, if you've went through all of these scenarios, doing simulations and all that stuff. So there's a lot of value in preparing for if this will happen to you, and to be able to really reduce the amount of cost that comes into an incident that you guys see. And we'll get into a little bit more details based off of how we can reduce those recovery times, and reduce the business loss based on being prepared. We'll talk through that as we go through the slides here. Kind of giving you a high level overview of the incident management, like what really goes into this. Like I said, we have privacy counsel that really comes in, who's guiding you on the legal side of things, when you should be notified, who you should be notifying, all that type of stuff. Guiding you through trying to make sure that you are doing things in a way to have the least amount of risk for class action lawsuits against you, have to pay out for data loss, PII, if you're a highly regulated industry where you have sensitive information like HIPAA or anything like that. You have to get into all of that stuff. So you have the privacy counsel, but where kind of we live is the forensics and the recovery side. The forensics is really painting the picture of what happened, right? Doing the investigation, gathering all the facts, and building the timeline of how the threat actor got in, what did they leverage to get in, and building the story of how they deployed their malware, how did it get around your controls, all that good stuff. So fact-based, these accounts got compromised, they got access to these machines, building that narrative of exactly what happened so you know what to do to protect in the future. That also provides deploying EDR solutions in full management and monitoring. So as we're in there, we're going to be focusing on getting visibility. So if we see the threat actor start moving within the environment, even after, it's a little bit, doesn't happen too often. Once they exfiltrate their data and they encrypt your environment, typically they're just waiting for their payday at that point, and they're not really going to do that. But sometimes some threat actor groups are a little more vengeful, as if you do not pay that ransom, they're going to come and wreak more havoc after the fact. So you have to do a really good job of containing the threat actor, locking down the environment, and then monitoring based off of what you see. The recovery side is exactly what you're talking about, and we'll get into the backup side and the things that you can do to help out there. But this is getting your systems decrypted, locked down, and built back up so that your business can function after a threat actor gets in there. And then post, you have the resilience side. And this is really learning from what just happened and making sure that you are properly remediating everything that was found, locking down all the systems that have been impacted, blocking the different malware and hashes that are known to be bad based off of what you just saw, and really looking into kind of those core security controls that you should be implementing within your environment, like MFA, like email security, security awareness training, proper firewalls at the edge, network segmentation, lots of different things. Privilege. I mean, one of the biggest things nowadays is privileged access management, and identity is really becoming the target of a lot of these organizations. As we get single sign-on everywhere, they are leveraging that as much as possible. So major sides that we work on: forensics, recovery, resilience. We'll talk through more of that as we go. Let's start with an actual what happens. What does the timeline look like once the threat actor has gotten in there? We're not really talking about how they got in here yet. We will. But if a threat actor gets in there and your environment is encrypted, what then happens, right? So typically you're going to see as the encryption within the environment is triggered, you're either going to get help desk tickets and people are going to be saying, hey, I can't get to this system, or you have some sort of control that is being implemented within the system that's alerting you saying, hey, these servers are down, you have monitoring, you have something like that. As you kind of investigate a little further, you see that your servers, say you have a VMware infrastructure and a couple hosts and maybe a handful of VMs running on top of them, those are physically down. Like you log into the ESX host and you see that the VMs are no longer running. As you investigate a little further, you're going to see inside those data stores within the VMware hosts, you're going to see that all of the files are encrypted, and at the root of the data stores, you're going to see README files with the threat actor saying, we've encrypted your files, pay us this amount of money, talk to us here on this Onion browser URL, dark web stuff, all that good stuff. And now you know you have an incident, right? So then you reach out to your cyber insurance policy. If you have an incident response plan, you start enacting it and move forward. The things that I really want to kind of focus on here are these major verticals. You have the forensic side, like we talked about. You have containment that you need to be doing right off the bat. So you should have a big red button in your IR plan to stop the spread. You might start getting alerts early on where maybe they only hit one host or one cluster of your VMware infrastructure, and you can stop them from hitting the rest. This could help very completely to reduce the size of the impact. So having good monitoring, having really good visibility into your systems with the monitoring and controls to contain the environment. What we call the big red button is lock down the network, like sever all the links between your sites, shut down inbound, outbound internet access until you can actually contain this threat actor and see what they're doing. Because sometimes they'll push it through GPO and it will just wait for the next system to connect. Sometimes they'll do it at the hypervisor level. Sometimes we'll have double encryption where you'll have it on the OS level and the hypervisor level. They do try to make sure that you have to talk to them to get that decryptor. So forensics and containment kind of kick off right at the beginning. As we're going with that, we're going to start bringing in recovery. We're going to start working on core infrastructure. So your hypervisors need to be rebuilt. They might have changed your root passwords. You may have no longer have any access to your ESXi hosts. vCenter might be down due to them encrypting the virtual appliance that runs on these things. There's a lot of core infrastructure to get back up. DNS, DHCP, Active Directory, your hypervisors, kind of those core things so that you could start getting your applications back up. You want to do critical containment first, then move into core infrastructure recovery. And then once you know that you have the threat actor out of there, if you blocked internet inbound, outbound, then you can start rebuilding your revenue generating tier 1 systems, as we always call it, to start getting the business back up and running. This is where we come in and we try to reduce that timeline as much as possible, figure out as with your business, what are the things that you should be doing that you need to do to be able to bring your revenue back into the business so that data loss timeline can be shrunk down as much as possible. And then once you get through restoring all those systems, you get core infrastructure up, you get your critical systems up, and then all the other systems that your business requires. That's when we start talking about the resilience side and improving to make sure that you are secured for the future so that this doesn't happen again. A lot of the work that we do is through insurance companies, and that improvement side is typically not covered in the claim. I always like to use the analogy: you get into a car accident, say you have a Toyota Camry, you take that and you get into an accident, you take it to insurance, they bring it to a body shop, they fix it, you get the car back, it looks good, but there's some Bondo and body work done. It's not exactly the same car that it was prior to the incident. That's very similar to what happens with a business's infrastructure after a big ransomware incident. There's remnants from the incident. We got to clean that up, but insurance isn't going to pay for replacing your Toyota Camry with a Ferrari. You're not going to get all the security controls just because you got into a cybersecurity incident. So that's where resilience comes in, and we will help you lock down the critical things that we have seen the threat actors do that we know will help you. And we'll talk about that in some slides coming up, to make sure that this doesn't happen to you again. It's just that is a separate contract. That's a different SOW. Insurance is not going to pay for that. So that's the timeline. It's typically that takes anywhere from 2 to 4 weeks for most small to mid-size organizations. Larger organizations can take a month or two to fully get through a full-blown crypto ransomware. We'll talk about some other types with BECs and more just like the exfil type, where they steal a bunch of data and threaten you that way, where you don't have to do the full recovery. But this is really the timeline of an encryption event with ransomware. With that, pre-encryption window is really interesting to start looking at. And these are the things that we really try to identify and make sure that you guys have the controls. Because what we're seeing is the outcome of a threat actor coming in. We see how they get in, what tools they're using and techniques they're using to establish the foothold, move around the environment, get the malware into the environment. So these are all the things that you're going to see and hear from us on a regular basis on what you should be doing to prevent this, right? We want to be as proactive as possible. We want to scream from the mountaintops, do these things, because that will make the threat actor's life way harder to actually impact your environment. So you look here, the average dwell time before encryption is 9 days, and they are doing a lot of different things. But nowadays, these threat actors are leveraging the same tools. They're using credentials that are valid. They look like your admins or they look like your regular end users because of the ways that the techniques that they use. So initial access, VPN credential abuse, that looks fine. It looks like they're a regular user. This is where IP detection and country detection and all that stuff comes into play. Of course, they can use VPNs to spoof that and put them into the right locations and see where your people are logging in from, where your corporate office is, all that stuff. So they use very advanced, not even advanced, that would be about as basic of a technique as you possibly can. MFA fatigue, we talked about that. Some of these other ones, exposed RDP. Hopefully this day and age, you do not have RDP exposed to the outside. You're using proper security controls and edge controls to stop that. But we have all the firewall CVEs and vulnerabilities that we do find certain vendors have more than others, and we see those trends on a regular basis. Once they get in, what do? They try to get command and control, and they try to get persistence. So they're using RMM tools that your IT providers use, so it looks legitimate. Once they're in there, this is where things start. You should have controls and monitoring in place to be able to see this, where they're doing Kerber roasting. They're using tools like Mimikatz to grab the memory cache credentials and taking those sessions and laterally moving across there. They're going to use tools like Bloodhound to find the quickest path to a domain admin to a privileged account. And once they get that, that's when they start lateral moving to your environment. They target your backup environment first, and they're going to try to destroy your backups. They're going to try to delete them. They're going to try to get rid of them so that you have to talk to them to be able to get your data back. The other thing nowadays, like in the last 2 years, we've really seen a shift. Maybe it's even 3 years at this point, a shift from them doing OS level encryption to literally just targeting ESXi, getting access to one host, and running an encryption on the ESXi host to all the data stores that are attached to it, that affects all the VMs that are currently attached to it. It's just easy. And a majority of companies still have their ESXi VMware infrastructure connected to Active Directory. Once they get that privileged account with Active Directory, they're going to laterally move to the ESX infrastructure. They're going to find the group that provides the privilege to the ESXi, either vCenter or the hosts. You'll do PowerShell with ESXi CLI to get access into, reset root passwords, lock you out of your ESXi environment, and then trigger the encryption. It's pretty trivial once they're in and they gain that, use Mimikatz to actually get into those credentials to then be able to get to ESXi. They could be in and out pretty darn quickly with that type of an attack. Once they're into the ESXi host, they're going to pre-stage their code. They'll grab it in many different ways and pull it to make sure that we do not detect it with all the things. And from there, they'll detonate it. They'll put the ransomware note on there. The malware will deploy that, and they're just wait to collect their money from the insurance and the threat actor negotiators. Absolutely crazy. So again, they're there. There are signs. There are things that we can do to protect against this. I kind of talked through a lot of these where, how are they doing this? What are they doing, right? Valid credentials on VPN. They now have access within the environment. Once they're in the environment, they move to AD, unconstrained delegation, look for stale admin accounts, weak SPNs, all that good stuff. They're using the same tools that we use to manage and maintain the environment. So I forgot, I think it was Mike who said it on the last one. If you use ConnectWise, you do not need to allow all of the other tools out there. Lock those down and only have ConnectWise, and make sure you are connected, only allowing that to your domains that are actually your tenant. Try to lock it down as much as humanly possible. From there, the other thing that they will do, and this is the whole Kaseya model, is they're going to just use your actual RMM tool and get access to that to then deploy their malware. So be very careful there. Make sure you're using proper MFA on everything. Least privilege for everything. Do not just allow your RMM tools to do anything and everything. You should have proper privilege escalation for everything, every type of automation that you're building. You need to be thinking about the privilege that you're accessing to these, because if it's easy for your administrators, it's going to be easy for the threat actors. So you want to be very careful there. The biggest thing, if you could get anything out of this entire session, is get your IT department to segregate your ESXi infrastructure and your hypervisors from your Active Directory. Air gap your ESXi and hypervisor infrastructure. If you do this and you put proper MFA, have a Bastion server, a jump box, be able to manage and maintain ESXi, you will probably piss off the threat actors enough to just not care to encrypt you. They might go the data exfiltration route, but they will not be able to take down all of your systems. Very, very important one. Backups is the same thing. Say they get to your ESXi, if your backups are properly immutable, and we'll talk about that here in a little bit even more. Really, like, write once, read many type storage, where you do not have physical access to the underlying storage on the network, so that someone could come in through out-of-band management, encrypt, or format the hard drives that the immutable storage and the backups live on. That's going to be a big thing to actually protect against. So really just make sure those air gaps of your hypervisor and your backups, that's the biggest thing that I can't stress enough. Take that away here, use that, preach that, scream it from the mountaintop. If you do that, most of the attacks that we see will only need to be only, very lightly said, negotiations with the threat actor to not disclose the information that they take, and it won't have to be full business down type scenario. And then the other one is cloud identity abuse. This one's huge right now. They are using lots of sophisticated ways to, or even basic ways to use self-service password resets. They are using standard phishing to get unauthorized applications within Office 365 to then give them full access to at least email mailboxes, to different types of compute resources within the cloud. I mean, the cloud is inherently pretty secure, but again, anything that's convenient for us is convenient for them if they get the right level of access. So you got to be very careful there. So lots of different ways for the threat actor to get in, kind of what they do, how they do it. Hopefully that's enlightening. And hopefully everyone now can also hear us say air gap, air gap, air gap, hypervisor and backups, and immutability on backups. All right. The backup myth. You have backups, you're good, you're immune from ransomware, you don't have to pay the attacker, anything like that. So you have three different scenarios that you can kind of think through when a threat actor gets into their environment and when they target your backups. The first one, your backups survive. Good job. You had proper immutability. But you still have 100 servers to restore from backup. You still have to transfer data from slower storage that is long-term archival storage for a backup system to your production storage infrastructure. Say each of those servers are 500 gigs. You are now at transferring a stupid amount of data from slow storage to fast storage. That's going to take a couple hours per server. Maybe you could run a few concurrent at a time. Sooner or later, you're going to saturate your network between the backup storage and the production storage. So, yay, they survived. You're still down for 10 days, maybe 3 weeks while you're restoring all those systems. Scenario B, worst case scenario, you didn't have it air gap. The threat actors got in there. They got in. They deleted all your backups. And now you're sitting there with an ESXi environment that's fully encrypted. All your snapshots have been deleted. Your Veeam repos are gone because Veeam runs on Windows. Even the immutability of a Veeam data store, if you follow their guidelines, if you do not properly protect the root access of that Linux machine and where those mutable storage lives, they're just going to get access to the Linux side of things and reformat and delete those volumes. So there's lots of different ways that these threat actors get in. They destroy your backups. They know what they're doing, and they know to target these backups. Then worst case, they don't even care. Scenario C, they just took all your data. So if you're a company that stores a lot of really sensitive information or valuable information, or you have IP that is really valuable, if you're a manufacturer that has designs or anything, they steal all that data. They exfiltrate it in very creative ways using backup type tools or cloud storage solutions. So they're uploading it to places that they see that you are transferring a lot of data to, so it doesn't monitor and trigger all the alarms that, hey, there's a very large backup, or they'll just throttle it to make it look like regular traffic. And over the course of a week, they can exfiltrate terabytes of data. So they exfiltrate the data, and then the attacker will sit there and publicly threaten you to disclose all this information or sell it to the highest bidder. If you don't pay that ransom, they'll just sell it, or worst case, they'll just put it on the dark web and here's all, they'll air out all your dirty laundry. So backups are one really, really big piece of incident response. One of the biggest things that I don't even have on this slide that I love to teach people about, right? Scenario A, backup survived. A lot of companies have multiple layers of backups. The best thing that you can use IT budget for to protect against ransomware is storage level snapshots. So if you have a block level snapshot on your SAN, you are able to roll back your storage level snapshots to a previous time without having to transfer any data from one storage device to another. So the very first thing we ask are, did your backups survive and what types of backups do you have? And if you have storage level snapshots, we have gotten environments that have been fully encrypted, fully down, back up in the matter of hours. We literally go in each data store, we will clone the data store to a snapshot of an earlier time, re-register all the VMs that are in that data store and power them up, install EDR solutions, lock down that EDR to as strong as possible. Now we have all your VMs back up and running. We did not have to do one server at a time. We did not have to wait for data to transfer from one device to another. It's literally just pointing it back on the SAN to different blocks within the data volume, and you can get an environment up in the matter of technically minutes if you have all the right controls in place. But it's going to take longer than that. We always say a couple days with storage level snapshots, a couple weeks for backups, depending on the size of the organization. Scale that up based off of how big the environment is. Crazy stuff with backups. Storage level snapshots are gold standard. Immutable backups are next. Having both of those layers of protection are highly recommended, but these threat actors are ruthless. Even if you have the best backups and the best snapshots, it may be irrelevant. You still need to go through threat actor negotiations. You still need to stop them from releasing the data that they exfilled. There's other controls that we'll put in place. We'll talk about with advanced firewalls and stuff like that to make sure that we're monitoring where the data is going, DLP type solutions, next gen firewalls, all of that can help with scenario C. So the other thing that is, I think, probably the biggest topic here is AI is changing what these threat actors can do. The phishing, we used to be able to have security awareness training that was like, look for an email that has bad grammar, or you could tell it wasn't a native English speaking person. That's a red flag. Nowadays, LLMs are producing perfect emails with proper grammar. And then they're using the open source intelligence. So they're scraping the internet. They're gathering an entire profile about your company. They'll see how you write in blogs and things that you do in the public, to then write an actual email that's really like targeted towards your resources, and it makes it really compelling to click on certain things. So it's still going back to the basics of anything that's urgent that they're saying you need to do this immediately. Go talk to your manager, go talk to somebody, and teach the end users to nothing that we do is that urgent, where you can't take a step back, go through proper communication channels, talk human to human to each other to try to stop these people from making the wrong mistake. And that's even more essential for your financial team. Our finance teams are numb to transferring lots of money on a daily basis. And it is normal for them to change accounts, to say, hey, we need to pay this invoice quickly and all that stuff. You need to be building in processes to anytime there's certain changes like this to be looking for these red flags, right? And build the process to have a human to human conversation anytime you're changing payment methods. The fund transfer fraud is very real. It happens all the time. That's one of the biggest ones that they actually successfully get a lot of money from companies based off of that. So AI is actually adding to that. The emails are better. The intelligence is better. The vulnerabilities are quicker for them to react on. You just throw Claude at it and it's going to write new malware. The polymorphic malware is on a different level, right? Hashes don't work anymore. It changes its code, recompiles it, has a new hash every single time it runs. Crazy stuff that AI is enabling the threat actors do. It's also helping us defend, but it's always that game of back and forth of who's going to get in front and who's going to protect versus who's going to attack. So AI is definitely changing this. We are seeing the way threat actors get in be more advanced. They're able to stay in longer through kind of basic containment measures. This is where the big red button, I think, is the most valuable. Just shut it down. Until you know you have it contained, shut down the environment until we feel good about it. You have an expert that deals with this day in, day out before you could turn the lights back on with the infrastructure. So some of the things that we're seeing in 2026, the main groups that we're seeing more, really Akira, really focusing on the VPN side. They're targeting ESXi directly. They're encrypting the hypervisor. The big thing here is they will exfiltrate a lot of data and encrypt you. So you get the double extortion. Even if you have good backups and you can restore, you're going to be still talking to them if you have sensitive information that you do not want to share. Scattered Spider was really big in 2025. They reemerged in 2025. And we had some gnarly cases with them. Some of our largest cases in our history came from Scattered Spider. And this is a little bit different type of attacker. They are more out to wreak havoc than to get a payday. They are the arrests that happened from the Scatter Spider group were 17-year-old kids in the UK and the US. Like, it's just different morality at this point, and what they're trying to do is different. And the big thing here was they did a lot of social engineering. I listened to multiple phone calls of the threat actor talking to the help desk, resetting MFA tokens and resetting a password of privileged accounts to gain access legitimately. And then they did what they did, right? So they live completely off the land using social engineering to get into the environment. So it's almost impossible to detect that type of an attack. So it's very hard to get them out of there. Lots of different things on the way to contain a Scattered Spider case versus like a traditional ransomware, because it's not always obvious what their intentions are. Sometimes it's purely just to wreak havoc. So really interesting. And then Keelan, big one, ransomware as a service. We're seeing them heavily in healthcare. They're using your RMM tools, again, living off the land, using all the stuff that you guys have with very large ransomware demands in that side. So these guys are still continuing. You think after they get attacked by, or they get taken down by the different government agencies, they're going to go away. They continue to adapt, transform, and come back even stronger with different tactics. So it's always important to be doing everything we possibly can to protect these environments by using mature controls and really focusing on the proper security controls, really. So if we kind of take a look at one of the Akira ransomwares that we had for a healthcare organization, they were in there before they really called us. They were in there for 23 days. Came in through ASA, through a service account, no MFA. The blind spots are real. These are the things that we really want people to be watching out for, is the gaps in their services. So VPN access, they get in, they recon AD, they get Kerber, they get a Bloodhound to see which accounts to move to, Kerberos, Kerber roasting to get the actual tokens. They get access to ESXi, but then they focus on exfiltration for a while, right? They could have done encryption right there, but they are sitting there waiting, grabbing as much information as possible, delete their backups, trigger the encryption. So now they have full-blown dual ransom, absolutely devastating for healthcare, hospital systems, small mom and pop offices, like doctors' offices. They can't keep up with the stuff that's happening. So what actually works? Kind of getting in there to help you guys make sure that you know how to stop ransomware, because in the end, if you follow most of these things, the ransomware, I used to use the idea, is it going to be a spark or is it going to be a bang, right? Like, is it going to be a full-blown explosion? Like what we're doing here isn't going to fully stop the threat actors, but it's going to minimize the impact of the threat actors by following some of these things. So from a prevention standpoint, anything that's externally facing, MFA, phishing resistant MFA is really important. ESXi and backup infrastructure fully isolated. Patching your VPNs and your firewalls. PAM solutions in place. Not using domain admins across the board. Use proper server admin service accounts. Use workstation admin service accounts. All that type of stuff. Do not have enterprise admin and schema admin on regular users, separate domain accounts, like all the good credential hygiene type solutions. You need to be doing that, and proper least privilege access is really, really, really important. And then this last one, no shared credentials between backups and domain. So freaking important. And hypervisor. Backups, hypervisor, and your domain. Fully separated, air-gapped management. If you could do network air gapping as well, where you have the management completely separate, or the network completely separated, use Bastion servers with even more hardened, like FIDO token type MFA, much, much, much better. At least you'll be able to get your environment back up and running. Detection, EDR coverage, inventory versus deploy. All of the EDR solutions out there, the modern ones, have discovery tools on them, and they show you where you're missing EDR coverage. It's in their best interest because they get more licenses, but it's also in your best interest that you properly have coverage across all your systems. So use it. The tools are there. Logging your ESXi. So in case something happens, most ESXi environments have the logs go to temporary space. As you reboot that machine, the logs go away. You specifically have to export those logs to a SIM. That will actually then, if you want to be even more mature about it, have monitoring of those logs and build different triggers based off of known vulnerabilities and known attack vectors. Detections tuned for Microsoft authentication, credential dumping, RDP hopping, all that stuff. Anomaly alerting on admin credentials. Start really looking at usage patterns for your teams. And then use Purple Team emulation. Really good stuff to do there. On a recovery standpoint, immutable backups, anything that has immutable write once, read many. Am I a broken record yet? Backup credentials not in AD. I'm going to say it probably 1,000 more times. Practice. If you're going through emergencies, if you've run through it a few times, you're gonna be more effective with it. Do tabletops. Actually define your RTOs based on business functions. Know what your systems are and what needs to run versus what's nice to have. All of that stuff will help you speed up the recovery process. Tabletop exercises to get your team experience. They should know the process of what happens. Test using the big red button over a weekend. Like, learn how to shut down your network quickly and effectively. That could stop the spread very quickly. It could be extremely impactful. Yeah. I know I'm coming up on time, so I'm going to skip over a couple of these and get to my final slide. 3 things for you to do this week. If you've learned anything from me, did I say any of these before? EDR deployment report. Look at the gaps, see what's missing. Check your backup credentials, check your hypervisor credentials. Are they AD joined? If they're not, get rid of the AD join. And are you logging your ESXi and hypervisor logs into a SIM? If you can do these things, you will be much better off. If you do not, you will reduce the impact and all of that. I will leave us there and open it up for any questions. I would love to ask any that you guys have.
So let's, so one of the challenges with preparing for ransomware is what happens after things are already in. So what do we do about pre-existing bad actors like Salt Typhoon that are already in our telecoms?
So that's a great question. Sooner or later, they're going to do something that's going to be impactful enough to get you guys to do a thorough investigation to kind of eradicate them out of your environment. The problem is that dwell time, right? These threat actors get in and they're inside your environment. They're within certain types of code and they're sitting there dormant until they start moving. Right now, we don't have a good way to really identify some of that until they do something that is going to trigger our alerts and our controls. So there's not a great solution for that. And it is, I mean, you got to be careful, and this is where you need to be doing your vulnerability scanning. You got to be doing your patching. You got to be doing everything possible to try to stay one step ahead. But sometimes there's nothing you can do, right? It's out of your control. That's a tough question, by the way.
Yeah, I mean, I have some more tough questions, but we're out
of
time.
Them.
However, folks can reach out to you and get more information on all those great services
Absolutely.
that MOX 5 provides.
Absolutely. I like the tough questions, though. Keep them coming.
Thank you very much, Michael. We appreciate the time. And we will bring on our next speaker, Tyler Casey, who's going to be talking about detection engineering. Hey, Tyler.
Hey, everybody. Hey, Mark. Hey, Bryson.
Hey, Tyler, I can't help but notice that is a really cool t-shirt you're wearing there.
It's a fantastic shirt. It's one of my favorites. It's always a great conversation starter.
And I'm guessing folks at home are probably saying, where do I get great unicorn swag like that? Swag.scythe.io. We have all of the unicorn gear you could want for yourself, for your kids, for your pets, you name it. And keeping in how we give back to the community, it all goes to charity. So if you hear jokes about the chubby unicorns, those are endangered rhinos. So we partnered with a conservation fund to help endangered rhinos. All the proceeds go to there. Check it out. And that's one of the ways you can support us.
Amazing. Well, Tyler, we will turn it over to you and let you jump into your presentation.
Okay, fantastic. Getting right into it. Just 1 second, everybody. Get my screen set up right. Hope everybody is doing great today. Happy Unicorn Day. 2 seconds. All righty. Okay. Yeah. Welcome, everybody. Today, we're going to be talking about detection engineering at scale. Specifically, because that could be a super broad topic, right? Detection engineering itself is a very, very broad topic. And at scale just adds more complexity and more kind of pieces you need to pick up on. So specifically, what I'm going to talk about is a problem that I hear about a lot, and I never really see any kind of practical implementations to fix it. That problem being, how do you know that your detections work? And not just when you write your detections, right? We know that they worked 6 months ago when you wrote them. I mean, how do you know that they work right now today? So with all that being said, we're going to dig into regression testing, how to measure false negatives, and detection SLAs, service level agreements, which are going to turn our detections into real measurable commitments about our detection quality. I'll walk through an open source project that we built over here at Scythe towards the end that implements all of this from end to end, right? First, we'll go over some theory and some key terms, and then we'll get into the real action again towards the end. If anybody has any questions or comments or anything like that, please feel free to throw them up at any point in time. Feel free to interrupt. I don't have a ton of slides, so the more kind of interaction we could get, I think the better it'll be, right? Alrighty. So before we get into that, a little bit about me. I am Tyler Casey. I'm the lead detection engineer over at Scythe and the deputy of Scythe Labs. I have about 10 years of experience doing DCO, defensive cyber operations. Currently, I run the blue or the defensive side of our purple team engagements, and I'm responsible for a lot of the threat emulations and the subsequent detections that we put out with our threats or our tests now. Before coming over to Scythe, I was on a CPT, which is a cyber protection team, where I deployed internationally for incident response and targeted threat hunting operations. Okay, so quick baseline before we get into the weeds. What is detection engineering? It's probably a term you guys have heard a lot, maybe don't know, exactly what it is. I find that detection engineering often gets confused with just something is not simple, but gets confused with just writing a query, or it's lumped in with threat hunting or just generalized kind of SOC analyst work. While that experience that you get doing those things is really important and quite invaluable to becoming a detection engineer, detection engineering goes a step beyond that. Detection engineering is more about the iterative approach of planning, creating, deploying, and tuning your detection logic to reliably find attacker behavior. It's not just about finding the adversary now, which is great, and you definitely want to find them now, right? But it's about ensuring that you will continue to find them later. And we'll talk more about that, obviously, as we continue to go. A few things I do want to highlight before we move on. First is that detection engineering is threat informed, right? Your detections need to be grounded in real adversary behavior or emulations, right? You can do that via some adversarial techniques that you glean from some threat intelligence, emulated behaviors on endpoints, or some red team findings or pen test finding or things like that. You don't want your detections to be based in a gut feeling or some log noise, but you want them to be based in specific mapped behavior. And I'm going to say that term probably about 200 times before we're done with this. But if you don't know what technique you're trying to detect, or you don't have it mapped to an adversarial behavior, you're not going to know if your rule actually works or not. You're just going to know if it fired when you first wrote it. Second up, detection engineering is lifecycle managed, right? Every detection should have an owner and a state as it moves through a defined lifecycle. That lifecycle is hypothesis, build, test, deploy, monitor, and then retire or retune that rule. You don't want any orphan rules, which are rules that have sat around for 6+ months untested. Those are probably not firing as you initially intended, right? And you don't want rules that go stale. Those are rules, essentially the same thing that have gone untested for several months. You have some stale rules that haven't fired in a long time. You don't know if they still work. You don't know if it is a false negative is why it isn't firing, or you don't know if something has changed or the rule is different. We'll talk more about how you can fix that here in a little bit. And then third, this is the main point for today, which is going to help inform our lifecycle management and our stale rules and pieces like that, is that your rules, or your detections rather, should be continually validated, right? Detections should be treated like production code, tested, versioned, owned, and measured, right? Is it working or is it not working on a continual basis? This will take you through a shift of we have rules to we have validated lifecycle managed detections. And that's really what detection engineering is and what separates a detection program from a detection engineering practice. Some issues that I've seen, and these are across large organizations, small teams, doesn't really matter. All of these are kind of universal in some of the customers and the clients that we've interacted with. So in the top left, just that you have silent rule failures, right? This is kind of a sneaky one because if it silently fails, how do you know that it's failing, right? This can come from a parser being changed, a log field gets renamed, a data source is moved, anything like that. Any small change can really break detections based off of how you write them. Nobody's going to notice these because it's not generating any false positives or really any alerts at all because it's just silently going to fail. So the absence of the alerts are going to look the same whether the rule is working perfectly or completely broken unless you have some kind of way to check that out, which again, we will get to. In the top right, no feedback loop. So once a rule is shipped, it's out of sight, out of mind, right? You're like, I wrote this rule today, April 9th, it's good, it'll be good forever, right? It's not really a good way to do it. You need to go back in and check and verify that it's going to still fire. On the bottom left, coverage theater, Bryson's favorite term, that MITRE bingo, right? Seeing teams present a MITRE attack heat maps to leadership showing they have 80% coverage, where their coverage means that we have a rule that mentions this technique. That is not coverage, right? Coverage means that your rule is actually going to fire when that technique executes, right? That's a huge difference between a theory and the actual execution itself, and the difference is huge into what is actually in your coverage. And then the bottom right kind of ties into the silent rule failures, but the invisible false negatives, right? This is really the core of detection engineering and what it fixes in detection programs or detective programs. Being able to reduce the false negatives by proving your detections work. Most people don't know their false negative rate or the or the percentage, because it's not what most people are testing for or what they're tuning against, right? They're tuning against their false positives because they're loud, they make noise, and they assume that if there's silence, there's no alerts, there's nothing like that, that everything is fine. And that's a huge problem. If you don't know you're getting false negatives, you don't really know what's happening inside of your environment. And then detection regression testing is when you are going to deploy an adversary behavior mapped to detective rules, and that's going to ensure that they're firing, right? If you don't get a fire during your regression testing, then you know that you're not getting visibility on that rule and that it needs to be fixed, right? A few points on detective regression testing is, first up, you should treat it like unit tests for code, right? Would you ship a production API with no test coverage? No, of course not. Nobody would do that. You would test it and put it through validation, have a unit test to go alongside it. But we ship detections with zero test coverage. I'd say most of the time. If you don't have a detection engineering program or a detection regression testing program, you are doing this, right? And that's okay. I'm going to show you a way to fix it. But the unit test here should verify that your code or that your rule still does what it's supposed to be doing after there's any kind of changes, right? Your rules are going to need to be mapped to an adversarial test to ensure that the functionality and that it still works, right? And that kind of feeds into the secondary point of continuous. It's not a one-time test. A lot of teams validate their rules, obviously, when you write them. When you write a rule, you're going to test to make sure that it works. But maybe you wrote that rule 18 months ago. What's changed since then? Has your schema changed? Has your environment changed? Your sysmon version, log forwarding configurations, your EDR vendor, your SIEM vendor, all kinds of different things can change in 18 months, right? In a year and a half, even day-to-day things can change. You don't know if your rules are working unless you test them. And then going into the test itself, your test should be end-to-end testing. You can't just inject some synthetic log events into your SIEM and call that a regression test. The emulation needs to run the actual technique on a real endpoint, generate actual telemetry, and then be ingested into your SIEM to then see if your rule is being fired or not. The synthetic log injection only tests the query itself, but there's other factors that go into that telemetry getting into your SIEM, right? If your log forwarder is broken, or DNS is down, it's not being routed, or the ETL scripts, the translations are broken, that telemetry is not going to get into your SIEM and your rule is not going to fire. So you really need to test the full pipeline, and if any link in that kind of pipeline chain breaks, your regression test is going to catch it. False negative problem, I already talked about this, but you have your false positives and your false negatives. Your false positives are when you get an alert, but nothing really bad happened. And then a false negative is kind of the inverse of that, where an attack happened and no alert is fired. The problem with this, kind of the duality of this, is that the false positive problem feeds into the false negative issue, because teams are so structured to reduce noise, reduce false positives, that often your rules will become overtuned and then lead to false negatives, because you're tuning out so much activity that your rules just stop firing at all. And again, regression testing is going to help you prove or disprove that your rule is going to fire. And then last slide before we get into the actual action piece of it, right? I know that SLAs can seem just like a term that's in a contract, and how does that apply to cyber, to detection engineering, or pieces like that? A detection SLA will turn your aspiration into a measurable commitment. Saying we have detections is not an SLA, right? Saying our T1070.001 detection fires within 5 minutes of execution, that's an SLA. That's something that you can strive for and attain and measure and make sure that that is happening, right? So there's a few different SLAs that we've identified here. The first one being a detection latency SLA. That's how fast does the detection respond in your SIEM, right? If you're detecting event log clearing, you're going to want that alert within 5 minutes, not 6 hours, right? So I'm going to show in the regression test pipeline we have here in a minute. It has a built-in wait time parameter to help you enforce this mechanism, right? So if you have your wait time on your checks to be 5 minutes, if that doesn't fire within the 5 minutes, you're not meeting this latency SLA. You know that your logs are taking too long to get into your SIEM and too long for your rules to fire. Next up is the detection health SLA. So are all of your rules passing right now, right? The health, excuse me, the detection health SLA is about a cadenced regression run, giving you a health check, right? It's going to let you know, are your rules passing? Are they failing? And you can run this iteratively and continuously to ensure that you're keeping it at 100% or 90% or whatever your threshold is, right? Depending on your organization. Failures from this should be sent immediately to the detection engineering team, not the SOC. It is not the SOC's problem, or excuse me, it's everyone's problem, but it's not the SOC's issue to fix, right? It's on the detection engineering team to go back, update the rules, retune the rules, redeploy them, and run that test again. You really want to know about this proactively for obvious reasons, because if you find out about it reactively after something has happened and a rule didn't fire, then a breach has already occurred. You're already kind of in the thick of it, and are going to have to kind of work at two different angles, where if you run these tests at a normalized kind of cadence, you're going to know as soon as something is broken. And then the last one is your coverage SLA. So what are you committed to detecting at all times? This is where you're going to pick some of your priority one techniques based off of your internal threat model, and then to really make a commitment as a team that you will always have a passing regression test for these. Ideally, you're going to want 100% coverage on your priority one techniques, right? Because they are top priority. Whether or not that's realistic, maybe not, but something to strive for, right? If your coverage drops below that threshold, though, whatever your threshold is, then that should trigger an immediate investigation, an immediate alert that's going to your detection engineering team, and an immediate rule triage to ensure that your priority one, your crown jewels are protected, that detection is working. And then, like I said, the values and percentages on this slide can be and should be adjusted to fit your organization, but get some SLAs written down, right? Get them formalized, get them professionalized. Strive for your detections to meet what your SLAs are. It's going to really help improve your program and shift it from we have rules to the rules that we have are being enforced. They're specific, they're measurable. We have a standard that we want all of our rules to apply to. That's really what you're building towards. All right, so went over kind of the theories, some keywords and things like that. So now we'll look at what this actually looks like in practice. So here at Scythe, we built an open source project called Sigma Regression Testing. It's on GitHub. The link's there. It's public. You can clone it down today. It's going to implement everything we talked about: the Sigma rules, automated conversion, deployment, regression testing, utilizing Atomic Red Team as our kind of source of truth, right? The rules are going to be, the rules right now are converted to Splunk, but all the SIEMs have essentially the same functionality as what I'm going to show. We would just need to modify the Sigma conversion to fit whatever your SIEM is, and that's in the pipeline to be done later on. So let's walk through it. So here's the end-to-end flow of essentially how this pipeline works. So steps 1 and 2, write and validate. That's where the detection engineer and the detection team is going to live, right? That's where all of your detections are going to come from. Everything after that can be automated to run on a cadence of some sort, right? And I'm going to mention this a lot, but in this house, we write our rules in Sigma, okay? The EDRs change, pipelines change, jobs can change even internally or externally, whatever. Write your rules so your rules can change along with you and along with your environment. After you have written your rules, then we're going to map them to an atomic red team test. And the CI, or continuous integration trigger, is really the key here. So when you push changes to the Sigma rules folder, the GitHub Actions is automatically going to run a Sigma check on every rule. If it passes, the Splunk pipeline can automatically fire. That way there's no manual trigger. There's no, did you remember to deploy this? Do we have our most updated version? Anything like that. Once you have the pipeline configured and set up, all of this can be done once you push and validate. So that's steps 1 and 2. Over to 3 is going to be convert. The conversion is utilizing PySigma and the Splunk backend behind the scenes. It's going to take every Sigma rule that you have and output it as a savesearch.conf that Splunk is going to be able to understand and run that rule. That output gets committed back to the repo automatically, so your save searches is done automatically and synced as you update the rules. After the rules have been validated and then everything has been updated. Step 4, deploy. For the deployment, we use a PowerShell script that hits the Splunk REST API. It creates or updates the safe searches for every rule that you have in your safe search configuration file. And then the last piece is the test, which is where you're actually going to prove the validity of your detection and test that regression pipeline by running an atomic red team test against the endpoint and verifying the alert trigger in real time. More detail on that. Excuse me, everybody. Sorry. So kind of walk through how that looks like, in practice, right? So here's a simple rule from the repo. This one detects Windows event log manipulation via PowerShell. We're going to walk through the rule a little bit. So the title is human readable, clear and searchable. The author is there, so you can attribute it to them and kind of track who owns this rule. And then we have some tags in there that are mapped directly to attack, right? So T 1070-001, which provides us a clear taxonomy to refer to and search on. It's also really good for mapping. And then a little bit lower, we have the log source, which is process creation. In this role, it means you're going to need an EDR sysmon or Windows security logs with the process creation auditing enabled. The detection logic is pretty deliberately simple. If the command line argument contains clear event log, remove event log, or clear win event, this rule should fire, right? You can take this rule, manipulate it in your environment, but these command lines should be pretty rare. You shouldn't be seeing too many people do this. Again, this is a Sigma rule. The real value prop in Sigma is that you can write it in this generic repeatable format and then modify it to whatever scene you have in your environment, right? It saves you from having to rewrite the rules multiple times. You can just write them once and then translate them to essentially anything that has a query bar. All right, step 1.5 is mapping that detection to an atomic test. So this is really the key file that makes the whole system work, right? The atomic red team mapping file is where you make the explicit testable claim that if I run this test, I expect this Sigma rule to fire. The atomic test GUID pins an exact attack emulation to this rule. That way you always have a repeatable test you can run to verify that this rule works. The expected rules is a list, so if you have multiple different tests that match a certain atomic red team technique, you can go ahead and add it in the list. It doesn't need its own entry. And then you got a cleanup flag if you need it to clean up any of the endpoints on there. Right now, our repo has rules that are across Windows, Linux, and some Microsoft 365 alerts as well. But it's really great because each one of these is now going to be documented, automated proof that a specific detection will catch a specific attack. If you don't have your detections mapped, you essentially have untested promises that you have running maybe in your production environment. You're trusting rules that haven't been written, or excuse me, you're trusting rules that haven't been verified since they were written, and who knows how long ago they were written. Here, this is where the automation starts to really pay off. So the convert to Splunk.py, again, uses Pi Sigma under the hood to translate the rules. We'll handle all the field mappings and everything like that to take it from that Sigma file to the actual Splunk field names and actual searches. And they'll do that for you. Again, if you utilize a different seam, you just need to change the backend to go from Splunk to Elastic or whatever it is. And then you can run deploy to Splunk.ps1 PowerShell script that's going to authenticate against your Splunk REST API and push all of those saved searches in one pass. Right now we have it manually done just because as we're testing and things like that. But you could add your Splunk password as a GitHub secret or something like that and set up the CI/CD pipeline to automate it. Then the moment a PR is approved and merged, the rules will automatically be converted, pushed over to Splunk. No ticket, no change window, nothing like that. It's just done for you as soon as your rule is approved. And then on the right, we just have a screenshot that kind of shows you what that looks like if you run it manually. So yeah, and then here is just a view inside of Splunk to prove that this deploy step actually works, right? So this is Splunk searches, reports, and alerts page. All of our saved searches that we had in that previous slide were pushed via that deploy script. And every one of these was a Sigma rule, just a Sigma rule in a YAML file that was converted to SPL, the Splunk processing language, and then deployed via that REST API. There's no manual clicks, there's no copy pasting queries, there's no saving it, trying to come up with a description or file name or anything like that. All of that lives inside the rule. And then after that, you have everything staged, everything is in Splunk. It's time to run a test, right? So over on the left, we see the CLI invocation of what we're going to run. Essentially, you just point the script towards your Splunk host, the Windows test targets, which you're going to run the actual test on, the credentials to allow it to send the atomic red team test over to it, the mapping file, and a wait time. The wait time is really important. Like I said, it gives Splunk time to ingest the events after the test fires. Ideally, you would want this to match what your latency SLA is, right? So if your latency SLA is 5 minutes or 10 minutes, you set that wait time to that. And if that rule didn't fire in that amount of time, you know that either the rule is broken or that the latency SLA is not being met by that rule, and then you can kind of expand it from there. Batch mode is a big performance unlock. When we initially made this, you would have to do one test at a time. So having the batch mode to be able to fire all of the tests at once really saves a ton of time. You can automate it to run, in the middle of the night or whatever, so it can do all of its rules. And in the morning, you can go back in and check what fired, what didn't fire, what needs to be looked at. You can also create a different test config file. So in this one, we have that artmapping.yaml. You can break them down to even smaller subsets if there's like some, maybe not deployment ready rules, excuse me, or there's some rules in testing or pieces like that. You can kind of break them down to have them segregated into smaller chunks. And then below the CLI, a few callouts for this. You can filter explicitly by technique or by the expected rule name. So maybe for some reason you just want to test, 1059 process creation or something like that. You could just give it the technique code, the T code, and have it test all of the rules that you have mapped for that T code. And then the output of this comes in two formats: JSON, which then you can feed into your CI/CD pipeline, as well as the HTML output that you see over on the right. So the report that we see shows that we had 20 tests that ran, 10 passed, 10 failed, a 50% pass rate. So we know that those 10 failures are 10 adversarial techniques we currently cannot detect with our rule set. And that's not like a vague concern or maybe or anything like that. This is a proven remediation list that you now have that was generated automatically that you can now go in and try to fix. See where I am on time. I think I'm good still. And then, so go back. So we have our test. We deployed it out to, or we have our rules set in Splunk. We ran our regression test Python script that then deployed our rules, or excuse me, deployed our emulation on that endpoint. So now you have your report, you can see it on there, but I like to trust but verify. if you will. So we have built into the report that you can just click on the on the rule name, on the test name. It'll take you directly into Splunk and pull up that saved search for you, so you can see exactly what happened inside of Splunk. So if there's something you want to dig down in a little bit more, really verify that it's working, or prove to someone that's maybe a little skeptical that your rules work, this is how you would do it. Here we have a Splunk search that's showing the command shell spawn from a non-standard parent location, triggering on some sysmon process creation events. This is real endpoint telemetry from a real environment, not just synthetic data that we injected into Splunk to check a rule, right? And this really kind of shows the distinction that I keep talking about, that rules deployed and rules firing are two very, very different things, right? Your coverage is not determined by having the rules simply in your SIEM. It comes from the rules that are firing, and regression testing can help you verify that. Yeah, and so this is where the detection engineering, where detection engineering becomes a managed practice instead of just a one-time project. And kind of how that works, we have 4 different metrics here that each feed into an SLA of some sort, right? So in the top left, we have our pass rate, headline number, right? It's probably what everybody wants to see. Put it on a dashboard, put it on the TV, so when the leadership walks by, they can see you're at 100% or whatever it is, right? Track it weekly and set a floor of what your minimum is going to be. Maybe, I don't know, 85% or something like that is a reasonable starting threshold to be able to see what your pass rate is, and you can modify it from there. But if you monitor this weekly, or whatever your cadence is, quarterly maybe, if you monitor it and you see that it's declining, you can now prove that something in your environment is drifting, something is changing, something needs to be looked at, something is happening where you're not getting the same results you were getting whenever you last ran the test. Top right, we see a false negative count. This, which went from being totally silent, unseen a few slides ago, is now something that you can verify, because each of the tests are mapped to an attack technique, or each of the detections are mapped to a test, which is going to run on that endpoint to prove, are you getting a hit on this? Yes or no. If you're not getting a hit on this, you know that you have a false negative because it should be firing. So you know that you need to go in, verify that rule, verify the emulation, create a ticket for it, and don't close it until that passes the regression test the next time. Bottom left, time to detect. How long should an adversary action, or how long after an adversary action did your alert fire? If this exceeds your threshold, maybe 5 minutes, 10 minutes, whatever it is, you need to be alerted to it, right? It gives you some of that latency SLA visibility to see how long it's taking before you get an alert, or even before your logs are being ingested. The bottom right, untested coverage. Rules without a regression test are unverified promises, right? You need to track those separately. It's going to drive your priority 1 techniques to 0% untrusted or untested. So things like credential access, lateral movement, defense evasion, whatever you deem a priority, that should be derived from your threat model. Your priority 1s obviously need to be resolved first, because they are supposed to be the most important thing that you have, right? Priority numero uno. So this all takes us into, we don't want our goal to be, we have 400 detections, or we have 2,000 detections, or something like that. You want your goal to be, we have 400 detections with a 85% regression tested pass rate. Our median time to detect is under 2 minutes or something like that. That's a defensible program. That's what taking, what takes this regression testing, taking these metrics and these SLAs that you have formalized, how all of those feed together to really give you the best possible defensive program that you can have. Just having the rules in there without any of these kind of metrics, you're really just hoping that they work, right? It's important that you go back in, that you verify them, that you run this regression testing. So with that, this is really a simple way, kind of breaking all this down just into one slide. If you guys think that this is valuable to you or your organization, I would encourage you to try it out and maybe help this grow, add some more rules to it, things like that. In a nutshell, all you need to do is clone the repo. We have about 140 Sigma rules in there now, and a working CI/CD pipeline if you want to utilize it. You can write your own rule, or maybe you already have a bunch of Sigma rules. You can take those, throw them in the Sigma rules folder, That's going to kick off. That's going to kick off the validation, the conversion, the deployment, all kinds of pieces like that. After that, it's going to be validated. It's going to be converted, and then you can deploy it to Splunk all in real time. So this only takes, once all of the prereqs are set up, really only takes a few seconds once you have that rule in there and that rule is validated. And then the last step is the payoff, right? Run the regression test Python script, watch the atomic rules fire, and then see the telemetry appearing in Splunk. And then you'll get a report that'll tell you either pass or fail, right? Did these rules work? Can you see them? And you can kind of go on from there. But with that, that's all of the prepared slides that I have. Any questions or anything? Got my contact info on there. Got the GitHub link down there at the bottom. Thanks everybody for coming to UniCon.
One of my favorite talks this year. Yeah, this is gold S tier detection engineering.
Ooh,
Great resource. Thank you.
I tell my son that. Thanks, JC. He'll really get a kick out of that.
Yep. So I captured a whole bunch of the comments. I think actually this is a great point here. So I think you guys are still ahead of the curve, honestly. And I think that's one of the things I appreciate about the way you framed this talk is you didn't just say, here's how you do detection engineering. You said, how do we do detection engineering at scale? Right. And you keep seeing this theme coming up throughout the day, which is it isn't just that we've solved a little problem, but how do we solve this problem and then scale it for a large enterprise? Now, think about a large enterprise, right? They're still trying to figure out all the people they got, all the assets they got, all the software they got, all this stuff keeps moving. And then you're trying to build detection engineering to match that. So what are some of the things that you can share about how folks can look a little bit more at the scale part of this problem versus just the technical individual contributor challenge, which you did such a great job of also walking through?
Yeah, for sure. I think definitely a challenge at scale, sure, you kind of hit on it, is having a baseline of your environment. Like what is normal? What do you normally see? What can you expect to see? Oh, it's a dog. Hey, dog. Having those doing it at scale just makes it obviously so much harder because the larger your organization is, the more difficult it's going to be to threat hunt and to write accurate rules on it. You could even take this project and maybe even change the rule mapping per like subnets that you have to help kind of break it down into more like bite-sized chunks of the environment. One other piece too, even outside of just detections in general, you guys are not using a SIEM or some kind of centralized logging, please stop. Please get a SIEM. Please get something in there. Back in the threat hunting days, there was more than once we would go somewhere and they essentially just had an Excel document that they would put all of their logs into and try to hunt off that. That is not going to work. You can't do regression testing like that. You can't find the bad guy like that. So I would say, yeah, don't be intimidated by how large scale the environment is or how large scale your enterprises. Start kind of in chunks and go from there. I think you'll start to see that a lot of the subnets or a lot of the different verticals or silos you have in your organization are more similar than you think.
One of the recurring themes I continue to bring up, and I'm going to credit Wendy Nather going back to 2013, where she coined the concept of the cyber poverty line. There's the haves and the have-nots. And I think a lot of us lose sight of the fact that we sit in a special space to even have these conversations, right? There are very few companies that can really afford cybersecurity.
Yeah.
That's the sad fact of it, because it is hard. It's a hard problem. And they're not in the business of cybersecurity. They're in the business of why they started their organization. And cybersecurity is meant to be the assurance of those business operations. So what is your recommendation for those that are just under the have category with how to approach detection engineering, right? How do I do this on the cheap?
Yeah, I think with that is just using, starting with some open source projects that they have. With that, like Elastic, you can get, I know they have a free tier you can start to put some logs into. Really, it's just getting logs from the endpoint into something. And if you can't do your entire enterprise, because it's expensive, right? Log storage is very expensive. It's very time consuming. You have to stand it all up. But if you can identify some of your crown jewels, your priority ones, like your, maybe it's your domain controller, file server, your CEO's boss, or your CEO's endpoint, your CEO's dog's endpoint, whatever it is, right? If you can identify these That is adorable. You can identify these kind of key crown jewels that you have. You can start bringing those logs into your small team that you have and start hunting on that. Start showing your leadership why it's important, what you're finding, and trying to maybe scale it out further than just those crown jewels. There's a lot of great open source tools out there that people can utilize. This project, not to plug it again, is open source, is available. You can download it and you can run it. You could run it on a test environment. You have it in your house, right? That's how I think a lot of us kind of get started. Very, very small lab environment that you can really kind of put your threat hunting and your detection engineering prowess to test.
I love detection engineering because it solves the so what problem, right? I think, again, going back to offense, one of the things that I first rose to public prominence about a decade ago was taking the offensive side of the industry to task. We aren't doing this to score points, to be cool, to do fun things. We're doing this because we need to fix something. And the continual, hey, you found a problem, here's a report, you found a problem, isn't the point. We have to fix these things. And if you've heard the trend of talking about prevention is limited, detection is where you will be able to make your money, because you will find attack collisions. You will find places where the attacker can be caught, right? The expression that defenders need to be right all the time and attackers only need to be right once is wrong. It's completely wrong. That's only true in the break-in. Once they're in, the attacker needs to always be right, because that's where you are on the defender's turf and they can catch you. So for those of you who have always gone, the attacker always wins, we don't get long weekends and this continues to suck. Guess what? Detection engineering is your way out.
Yes, 100%. Being able to the thing I harp on this all the time with really anyone that'll listen is that being proactive in your defense is so much better than being reactive to it. If you can, obviously, if you're threat hunting all the time, you got breaches all the time, maybe you don't have time to do it. Hopefully your organization is not like that, right? But if you can have some time to really dedicate to proactively setting up some detection engineering, running some regression testing, threat hunting for adversarial behavior and proving or disproving that it's there, you're going to be in a much better position when an incident does happen, not if, when an incident does happen, to be able to react much quicker and save your weekends, get to your son's soccer game, things like that. Being a little proactive really goes quite a bit.
I had to get a screenshot with her in it. I mean, if we're going to encapsulate UniCon, I think it's going to be our little friend Margot here so far. Right?
No, we got to get her one of the unicorn bandanas. I had that on my dog Hemingway, because he'd always sit on my couch. I have him in my office, and so I was like, if you're gonna sit in here while I have meetings, you got to rep the brand. So I had him wear a unicorn bandana.
We do have to do that. Yeah, swag.scythe.io. We do have unicorn swag for charity for your pets as well.
Well, good. Anything else, gents?
Yeah, just thanks everyone for having me on. Thanks everyone for participating in the feedback and pieces like that. Please use the project. Please provide feedback if it doesn't work or something is broken. Obviously, we're going to continue to maintain and work through it. This is the first public presentation that we've had of it. Please let me know. Right, detection engineering and threat hunting are things that I really do love to talk about and I'm very invested in. So please use it. Please reach out to me. Feedback, pull requests, whatever it is. Yeah, let's do it.
Amazing. Thank you, Tyler. We are going to take another short break. We're going to pick back up in 15 minutes at 2:35. And at that point, we're going to get Jason Christopher on to talk about the status of ICS and OT. So enjoy your 10 to 15 minute break, and we'll be back in a little bit. right. We're back.
The dog has already been missed. I'm sorry. She also went back to her bed in the other room. So you're 0 for 2 on dogs, but stay tuned. You may have another surprise visit.
Yeah. Well, good. So I'm eager to get Jason Christopher on and let him dive into the state of OT ICS cybersecurity. And with that, let's get Jason onto the stage. Hey, Jason, how you doing?
Doing well. Now I'm trying to load my slides in. Thank you, Bryson, for a delightful reminder. It would be easier to do if I was computer literate, I think.
That's why we work in security. I love telling this joke. We work in security because we're not good at actually doing this stuff.
Yeah, I just tell other people, like, this is what should be done. I am on this. Okay, here we go. Here we go.
Yeah, I think the other advantage we have is in IT, if it doesn't work, it's immediately obvious. Like, we don't see your slides yet, but in security, it's like, did you see that? The security's there or not there? You don't really know.
Also, at this point, I can just riff for like the 45 minutes while it's processing things. Like, that's fine too.
I mean, in that case, I'll stay on and I'll make it spicy.
I was expecting you to be able to keep it spicy in the background anyway.
You know how much I've been quoting you since S4?
How much?
I think it's actually only 3 times, but it sounded really cool when I asked the question.
It's, I didn't realize, for those who haven't been tracking, there's a great AI album out by Carter Manussi called Controls and Consequences. And I've just been bopping in the background. It's like a techno beat type of discussion. He apparently quoted me in it, and I didn't pick it up the first time I was quoted in it. So the quote goes, for a security framework, just pick one. I don't care. Just pick one. But now I could hear that with, like I said, the bopping of the background too.
All right, Jason, your slides are there. I'll bring them to the stage and I'm going to let you go.
Awesome. Perfect. I can see them and everything. This is fantastic. Well, thank you everyone for joining me. Having this conversation at UniCon, which is always a fantastic event since starting off in the days of the pandemic and being able to have conversations globally with folks. I am Jason Christopher. I'll be talking today about the state of ICS and OT security. A little bit about me, if you do not know me. I actually work within Energy Impact Partners. That is a venture capital group that was created by utilities to be able to look at the different things we can do specifically for the energy transition. And sneakily, the energy transition has a lot to do with digitalization, which happens to have a lot to do with cybersecurity. So there are a lot of different cybersecurity startups and portfolio companies that we have, including Scythe. So it's always awesome for me to be able to work with not just our CISOs across the utility space and energy sector, but also really awesome companies and people like Bryson. And with that, we can't see that beautiful animation there, but that's okay. I'll describe it momentarily. Meanwhile, what we're talking through today is OT security. And we can't see on the left-hand side, as I'm going to have a cloud with zeros and ones raining down from the heavens that talk about the traditional things you think of in information technology, confidentiality, integrity, availability. We're going to talk through those discussion points with our leaders about, hey, this is what it looks like to be able to secure our data. And maybe the most important data that we're talking about is customer data or employee data or intellectual property. But when we get to that OT side, that operational technology down there at the bottom, we don't care about confidentiality, integrity, availability in the same way. We're talking in terms of safety and reliability, where an incident could lead to something potentially catastrophic. And so when we think about those zeros and ones, the zeros and ones are opening up a lever, turning a valve, having a switch breaker turn on or off based off of whatever operational environment I'm in. And so understanding that really sets the stage for these systems are a little bit different, if anything, in the impact and the priorities that we give them when talking through everything. And so when we talk through the survey that we do within the SANS Institute, which is where I also work outside of my duties at Energy Impact Partners, one of the things that we've been doing since 2017 has been a state of OT and ICS security specifically. I've now been the author of this survey for the past 3 or 4 years. It's been an awesome experience to be able to really drive the conversation beyond like the checklist mentality that we'd have. And last year, we really just threw out everything. And what I mean by that is we're asking very similar questions for the previous maybe 6 or so years. And we wanted to be able to escalate the conversation on these threats are changing. We know the threats are changing. We've now seen it in real time. How do we then move us into a better state? Now, if you're from the OT side of things, you're from operations, the way that we typically think about things is the past, the present, and the future. We talk about real-time operations. We talk about future time as part of our discussion points. And that is exactly how the survey was broken up. We talked first about the past, what happened over the past year, the growing threats, the evolving regulations, any impact to the ICS programs based off of those. Interestingly, we'll talk about this momentarily, but both threats and regulations have their own sort of drivers in ICS security. And it's not always a one-to-one overlap, but there are some interesting trends that have come out of that. We'll then talk about the sort of present. What are people doing today? What are the vulnerabilities that people are trying to manage? How are they managing them? It's going to be different again than the IT stuff because I don't have a patch Tuesday at a power plant. I'm not bringing the entire plant offline to be able to take care of some of the mundane cyber hygiene things that we want to talk about in the IT environment. And then the future. I would love to say that we are prepared for future threats, but I think we know where the answers are going to lie. That said, we did ask that question, and there is a percentage of folks that say that they do feel very prepared for these future threats, including the geopolitical ones that we've been seeing pop up over the past few months. Understanding what they do would be a differentiator, right? Understanding what the best of class does. And so we drill into that a little bit more as well. The survey itself hits globally. So we do try to get as many folks as possible to be able to answer the survey. We are about to unlock the 2026 survey in a couple of months here. And so for folks who are aware and sort of get excited about answering a lot of questions, I will make sure it's a minimum set of questions. If I give you a deluge of 80 questions, no one will ever answer the survey. So we try to hit a sweet spot. The least amount of questions you can ask is about 5. The most that you'll have to answer is maybe about 20 to 25, depending on the things that have happened to you. And so with that, we have a lot of headlines. We've seen these headlines over the past year. I just want to level set when we talk about OT in particular. The latest one happening just yesterday or 2 days ago, where we saw the CISA alert for Iranian affiliated cyber actors based off geopolitical conflicts. This has been a big shift for the C-suite, the CISOs in particular, when talking about their programs. If you talked about their programs 10 years ago, it was about the NIST cybersecurity framework. It was identifying, protect, detect, respond, recover. Now there's this geopolitical element that frankly has been more of a hotbed over the past year, if not specifically the past quarter, that a lot of CISOs are saying, oh, I need to do a lot more on that threat discussion that I was having previously. It's not just saying where we're doing from a ransomware perspective. It's now what do I do about a wiper that doesn't care about getting any money back? And just wants to be able to create a little bit of chaos. And so we know, therefore, that these threats are increasing. And we're asking folks, well, based off those headlines, like who had an incident? Very first question that you'll answer sort of in any of these ICS surveys. And it doesn't line up with the headlines, which should make sense, right? That the headlines are going to give you the folks that have been able to be in the news for otherwise bad reasons. But we'll also sort of see here that about 22%, which isn't like the world's on fire, but it's still like 1 in 5. That's not great. And when you look at then like what happened is the next question. If you say, hey, yeah, I got that. Well, say, okay, well, how did that take place? Well, you can see here, there's quite a bit of discussion about this sort of unauthorized access users, insider misuse or errors, ransomware being, again, sort of the top 3. And the unauthorized access for 1 in 5 folks to then have 50% of the incidents be part of that conversation really starts driving the conversation on, hey, what does this mean from a perimeter perspective, inclusive of user controls? And so when you look at the way that an ICS attack would take place, it looks like there's a whole lot of middle steps there that maybe we're missing, where the attacker gains some sort of entry point, typically in your IT systems, to this very right-hand side stuff of like, well, ICS execution. Well, there's a lot of steps that have to take place in between there. You see a sort of this living off the land techniques that may take place, going through IT networks, understanding your system a little bit better, to then finally being able to pivot into your ICS, and then understanding the equipment that's running there. Because of the way that all these things could take place, the defender is going to have their own capabilities, right? If I'm talking about where they entered, then it's going to be IT-centric controls. When I talk about the ability to jump into the ICS, well, that's going to be our perimeter defenses. Once they're in there, do I have any hardening whatsoever on industrial control systems and operational technology networks? And the answer typically is not so great. So when we look at the ability for what the attacker does versus what it is that the defender can do, we get a couple of what we call gaps and timelines that lead us to when was the first entry point to the actual execution of the attack. And the first one that we looked at was this idea of the compromise to detection gap. That compromise to detection gap, you can see here, we've actually done pretty good in comparison to where we were. What I mean by that, with the respondents that did go through an incident, so that 1 in 5, we have about 50% of them were able to detect in less than 24 hours, which is fantastic. That is something that we were not able to say 5-6 years ago. As a matter of fact, I pulled the 2019 data and about 50% were at that 2 to 7 day mark. So we've moved from 2 to 7 days for detection now into this idea of doing it within a day or so. So detection's been doing, I'd say, objectively much better than where it was. But what happens after that? Well, our next gap is detection to containment gap. And here's where we start seeing this idea of a thicker tail, meaning that you may be in this area where we detect it within 24 hours. Maybe you're able to get into containment within 24 hours after that. Fantastic. But you can see here, I've got a percentage of folks that are now taking a year or so to be able to get containment. It's not uncommon to see these longer tails, especially in industrial control system environments, where maybe you can't contain. Maybe instead you're relying on manual operations. You're unable to contain. You're running in a degraded state because you can't bring this facility offline. It's a 25/7, high reliability, high safety standards. You need to maintain it. So you're maintaining a compromised solution in that case. And then the last sort of gap that we talk about is what we do from containment to actual eradication or remediation. And again, the tail just keeps on going, like not much thicker, right? Now I'm talking about things that are happening in time period of months. It's a much flatter curve than any of these other gaps that we have. But we also now see this spike where people are talking about over a year to potentially get to remediation. So think about that from the stacking perspective. If it's taking me now, in some cases, months to be able to get to containment, and then after that, months to be able to get to remediation or longer than a year, that's where you really start having this understanding on the impact side, especially when we talk about these are molecules that are flowing. This is water, this is power. These are these sort of critical infrastructures that we depend on for modern society. They are much more difficult to remediate when we're talking about these actual impacts. And that gets me into why these things are different. I love this quote. You can tell I love this quote because I've been quoting it since 2009. This came from the Department of Homeland Security and the ICS CERT releasing an incident response plan guidance for ICS-specific incident response. And quote, standard cyber incident remediation actions deployed in IT business systems may result in ineffective and even disastrous results when applied to ICS cyber incidents. So I asked, do you have an ICS-specific incident response plan? And the tail of the tape is not great. It could be worse though. We've been roughly tracking at this like 50-ish% rate, I'd say over the past, let's call it 3 or 4 years, since at least I've been doing the study. So if we're saying that about 50% of folks who went through this survey, who again are willing to answer a SANS ICS survey. So my like bias pool is already pretty high. I would probably wager that in the wild, this is a little bit less than that. So roughly half had to do something with incident response. Now that said, when they do an ICS incident response plan, about half of them are going through this idea of doing maybe even a quarterly based drill. But we see at least 70 to 80% of them are doing this annually, which is awesome. So if you have the incident response plan, 80% of them are doing this annually. I'll dive in a little bit later about some of the pushes for that. Unsurprisingly, it's actually because of regulation. The ones who are doing this annual test, it's because they have to do things like NERC-CIP in their environments that requires them to do something. On the unfortunate side, bulk majority of those are just going to be paper-based tabletops. Last year, Bryson had me up here and we were going back and forth about our opinions on operational drills and technical simulations and how that really makes your like incident response plan so much better. I don't see, again, the numbers of folks where you can do that. Are they doing it? So you're seeing this mix of folks who are doing a little bit of red teaming, purple teaming, but by far tabletops that are paper-based are the ones that the folks are leaning on. And that got us to the drivers. So without me stacking the deck, without me really understanding where the question would lead, I was asking folks about how this was really showing up in their day-to-day. And what came through the data was that both threats and regulations were the major drivers for their ICS OT security programs, more so than any executive saying what they did or did not want to do, any action plan, any guidance, any framework that was out there that wasn't mandatory. The threat drivers and the regulatory drivers were the key ones. And so diving into that a little bit, on the threat side, we did see some interesting data on, are you using threat intelligence? And 2/3 said, yes, we are. Great. What type are you using? We saw some interesting aspects here where a majority of them are leaning on vendor-provided threat intel briefs. Depending on your vendor, those may be good, those may not be. So then we started seeing, again, sort of an uptick on government stuff. Well, in 2025, there was a big push from the federal government to say that this is going to be more state-based. Again, not good or bad, but understanding that some states have got really good threat intelligence and information sharing and other states don't. So if you were relying on that for the previous, let's say 15 years from the federal government side, you may have to find yourself switching into what does it mean from a state discussion. And then the other one that got my attention was information sharing, peer groups. We saw a lot in ICX, sort of ISAC participation. And what was interesting about that was, well, that seems really good until you drill into the data and realize that out of that 70% or so, 21% are providing two-way flow of information, meaning that the other 50% are just solely reliant on what folks are reporting in. Think about that from, again, like this idea of my threat intelligence program perspective. If I am relying on 20% of the population to tell me other things that I should be looking at, and I'm not sharing back the things that I'm seeing, it just makes the general sort of pool a little bit weaker as a response to those. And so we're going through back and forth to see what this can mean, but by and large, 93% of those folks still found value in those peer sharing groups, even though the data quality may not be as up to par as we'd expect in other aspects of threat intelligence. So the threat side was a driver, and there are sort of, again, 2/3 that are looking at threat intelligence themselves to be able to inform their ICS program. And this led to an interesting conversation on the trends themselves. Based off of threat intelligence, we were asking, well, what were the things that you were seeing there? This then expands the discussion point between the 1 in 5 that had an incident to broadly, what are the things that you're seeing? Like if you're looking at the threat intelligence that you're getting, what are the increases that you're seeing across the board? And so you see this from the attack types: ransomware, nation state activity, in particular, typhoon season, supply chain compromise. And then the remote access also linked back to our conversation from the 1 in 5, who talked about having remote access as one of their problem points. But then also on the environments, the targets, where are these attackers going after? Seeing an increase in that ICS and edge IoT discussions, legacy control systems, cloud-based connections were super interesting because in the previous year's survey, we found a lot more cloud connectivity, including folks who are using cloud for even like human machine interfaces, which was slightly scary. So seeing these increases, again, sort of informed the discussion there. And then we asked, well, what do you do? Like you get all this sort of information. What are you doing about it? Unsurprisingly, the number one thing that people are doing is updating detection in their logic or in their rules and alerts. They're changing sort of how they're monitoring different assets. And went all the way down. If you see at the very bottom here, I did put down a population said no changes were made based on threat intel. 9% said that. So I just like to inverse that and say, well, that means 91% of folks are doing something. They're taking a look at the threat intel, and it's a 9 in 10 are saying, oh, I need to do something with my program based off of that. Really just helping to quantify and qualify what things you can do with threat intel. And the importance on these survey points, this is probably for ICS the closest that we get to the idea of benchmarking our programs. When I see something like, hey, 9 in 10 folks that are using threat intelligence, which again, 2/3 of folks are doing something with that threat intelligence. If you're in the sort of bottom quartile there, if you're not doing anything, if you're not using threat intelligence, and I know that my peers are, and 91% of them are doing something with it, that should hopefully drive the conversation with your leaders to be able to say, hey, we're not doing something that is now considered a baseline practice. I consider a super majority of folks doing something with it a baseline practice at this point. And if you find yourself lagging behind that, that's why I like to do this survey. I like to be able to provide those data points. You can say, hey, boss, look over here. We're not doing this thing and everybody else is. So we should probably do something in threat intelligence to be able to inform our security program a little bit better. Regulations are also fun. So unsurprisingly, we've seen an increase in regulations. I gave a talk on this back in 2023 because 2022 was the largest increase in any amount of ICS OT regulations in the history of ICS OT cybersecurity regulations. And so it's not surprising to come back a few years later and see that 77% of folks are saying they have to do something mandatory in cybersecurity. That said, not all compliance is equal. Even when I teach NERCSIP, I teach it from the perspective of your NERCSIP program is not the same as another one's. Just because you both utilities that have to do mandatory enforcement does not mean that managing 1 or 2 sites is the same as 50 sites. And even if you're managing 50 sites, it may not be the same thing as the complexity around those. So understanding that, we really looked into the violation pieces, asking people what were the areas of non-compliance they sat in, and also then what were the drivers that compliance gave them. The green and yellow and red dots in the middle there is whether or not the left-hand side are capabilities or things that people change because of threat. We asked about the investments people made based off threat intelligence. You saw that in the previous slide. We then also asked, well, what was regulation driving you to do? And unsurprisingly, they are largely mapped together. You can see here out of the categories, we'll just go ahead and say that about 70% of the things that threat intelligence was investing in, like the changes to your program because of threat intel, were also changing the things from a regulatory perspective. The areas where there weren't, obviously on the red, process improvement, threat actors don't care how efficient your process is. And document management, evidence collection, obviously also not part of our threat intel discussions. The yellow area was the vulnerability management tools. What I mean by that is that when looking at the drivers that, hey, I use threat intelligence and I'm using that to be able to inform my ICS program, we didn't see vulnerability management tools get like sort of promoted to the front because of the threat intel feeds, because of the threat management program. We did see it a lot here in vulnerability management. So much so that it became like a key takeaway that you're being driven towards that from a regulatory controls perspective, which should make sense, but not from the same perspective as to what threats do. And again, from an ICS perspective, that will make sense when we think about the fact that in industrial control systems, I really don't care that much about 0 days. It's not the same conversation, right? If I land on an operator box and the login password is operator, and now I have access to the entire control system, I didn't need to exploit anything, even though it could be running on a Windows 7 machine that no one's touched in several years. And so that threat detection piece expanded quite a bit. We did ask specifically about how people are using detection internally, just because we saw that increase and that speed at which we're detecting that we weren't doing 5-6 years ago. And also understanding that we now have these OT SOCs that are now on a rise. We did not see that before. That was purely an IT function in the previous years. We also then asked about, well, what is your full visibility across the ICS cyber kill chain? And only 13% of respondents said that they had full visibility. If you're new to the ICS cyber kill chain, my quick debrief on that. This is a white paper that's written by Mike Asante, Rob Lee, maybe 10 years ago, talking through what are the attacker objectives when looking at industrial control systems. And we group it into loss, denial, and manipulation. Loss of view or control of your control system, right? I can't see what's going on from reliability state. I don't have the ability to turn things off or on anymore. Denial, so now actively, persistently losing view, control, or safety, which is obviously an alarming thing. When I arrive on site, I want to make sure I'm leaving with my eyesight, my limbs, my health, my life intact. And then lastly, manipulation, whether or not I can manipulate the view, so I'm not seeing the factual reality out in the field, manipulate the controls, I'm sending something, but an erroneous control goes instead, or the sensors and instruments, or the safety aspect itself. And across that, we start off with that stage 1 of the kill chain, which this is now the IT kill chain, right? This is the exact same Lockheed Martin cyber kill chain that you know and love. But we also added a stage 2 specific to ICS. Now, how the attacks are developed, how you do the fine tuning, how you're enabling the attack, initiating the attack. And that said, when I look at all the different attack types that have happened, things like configure, purely stage 1, right? There's no stage 2 in configure. It's just a worm that's out there doing wormy things. When I think about APT1 and their targeting that they did across the energy sector even, that was, again, mostly on stage 2. They didn't ever show the capabilities to do a stage 2 type of attack. And so when I look at all of those, the only ones that really jump out, and it's not a ICS presentation if I don't say Stuxnet at least once. So there you go. That's your Yahtzee. I said it once. That and the Ukraine scenarios are the ones where we saw true stage 2 development, true stage 2 impacts that led at the end of the day. So that gets me back to only 13% of respondents said they had full visibility across the ICS cyber kill chain. Only 13% of folks would have been able to see the entire kill chain every step through on stage 1 and stage 2, leading to a lot of potential gaps and misses in our program. So what can we focus on? There is typically a pretty castle here where you see that flag just sort of standing there, but we'll talk about the protection is ideal and detection is a must criteria, while also categorizing it as saying that, well, detection without the ability to respond is going to be of very little value to you. And so there are 3 things here that, again, you can't see, but I'll describe them. The first one is talking about vulnerability management, risk-based vulnerability management. That was one of the key themes that came up. Now you'll remember that largely came up because of regulation, but this was a very interesting aspect that folks were driving towards vulnerabilities with ICS OT impact. Not all vulnerabilities are going to be the same. Very few of them are things that we care about in the ICS. As a matter of fact, we'll categorize our vulnerabilities as now, next, and never, with a bulk majority of those things to patch will be in the never category because I will never patch them. I'm instead relying on boundary protections. We think of ICS as an M&M, the candy, not the wrapper from Detroit, hard shell GUI center. And so then we also talked about threat hunting. That was another key thing that came out of all of this. What could threat hunting look like? What could also purple teaming look like? And when we looked across the entire sort of IT and OT landscape from level 5, level 4, where I'm talking more IT, down to the OT guts of things from level 0, 1, where I'm dealing with actual, here's the equipment, here's the things that I'm controlling. Where can we do those things? And the answer is everywhere, kind of. There are caveats. Like I'm not going to take a pen tester that knows nothing about ICS, throw them into a plant and say, good luck, let me know what you find. Because I may not have a plant when I come back, depending on the type of test that they run. So when we looked at that, I know this is an eye chart on the right-hand side, but this is the thing that I am actually most excited for the discussion around. And this led to a lot of unique dialogue in our industry after we released this report, because it's the first time that anybody has done this, where we looked at detection, vulnerability management, threat hunting, and pen testing at every level that we describe across IT and OT, and said, okay, where are you doing these things? I probably should have used different colors than red, because when you see red, it doesn't mean that we should have to do it across all those things, right? I'm not saying that everyone's got to do vulnerability management in level 0, level 1. That's not going to make any sense. Instead, it's saying that there are gaps in that sort of capabilities and the way that we're stacking our program. In particular, the one that jumped out at me was the very bottom, the field and remote sites. That should not be that red. There are similar capabilities that we can do. If we're doing it, for example, in level 2, we likely should be able to do it in a lot of these remote sites. And so seeing those gaps and doing a comparative analysis and asking yourself, okay, I've got a whole lot of detection, but I'm not doing any threat hunting. I'm not doing any vulnerability management. I'm not looking at what an attacker could do in those spaces besides the fact of saying I have detection. Detection is good. Detection at this point is going to be your next must. But if you don't do anything with that detection, what are you doing? If you don't have the ability to respond, recover based off of those, if you're not getting more gritty with some of the ways that you deal with vulnerabilities, and by vulnerability management, we don't mean patching, we mean are there other mitigations in place, then you may be missing the ticket. You may be missing sort of the way that people are looking at threats moving into the forward. So color choice, maybe this year I won't use red because it did drive a lot of ire, but it's important to see the gaps and where we're going to invest in our capabilities. And we've really invested in detection. It's not everywhere though. You can even see in some of these areas, we still have major gaps, even in the basics of detection across the entire ICS and IT leveling. So is there any good news? Is typically what I get left with at the end of the presentation, because I give you a whole lot of, well, these are the things that we're doing. These are the things that we're missing on. What are the things that we can take away as a positive? Well, first and foremost, we do know that defense is obviously doable, but what is also really interesting is that as industrial organizations, we are fantastic at business continuity, disaster recovery. If you're not in industrials, think about what industrial organizations have to do in terms of preparing for wildfires, earthquakes, hurricanes. They are really good at being able to make sure that you have essential services, despite there being a blizzard in the area, and getting you back up and running as quickly as possible. What we started to ask was, okay, well, how are you doing with tying that to cyber? Can we do that? We know what a good culture and good set of capabilities look like here. Can we do that with cybersecurity, cyber resilience as a factor? And these numbers are far more improved than they have been in recent years. So we are seeing that shift where cyber leaders are now being brought into the discussion point that they weren't previously in. And then what type of threat scenarios have you talked about? Unsurprisingly, ransomware is top of the chart. However, supply chain compromise, insider threats, geopolitical escalation was at the top last year. I expect that to be able to be going further as well. And so we're seeing people at least tackling, right, the quote unquote right threat scenarios, looking at the things that may impact their businesses, looking at things that may ultimately, at the end of the day, cause some catastrophic outages. So we know that we've got the good pieces in place for recovery. We may not always be tying it into cybersecurity. We know that we're now looking at scenarios that would be of most interest to our organizations too. And so I count those as some early wins when trying to talk about the culture that we need to be able to have to tie these things better together. And making those right improvements. So we did ask about where people are going to be utilizing technologies in the past 12 months versus what they're going to do in the next 12 to 24. The top winners were asset visibility tools, secure remote access, and I'd lean on modern there too, as well as vulnerability management tools. Again, vulnerability management tools kind of being like the sleeper in a lot of this, because it wasn't highlighted in the threat discussions, but it is highlighted almost everywhere else of like, I need to manage my controls a lot better. I need to be able to understand what's really happening. And then you compare that to those gaps that I showed you before. Vulnerability management is one of the ones where we have some of the largest gaps. So it was heartening to see that over the next year to 2 years, people are going to take that seriously and be able to invest in it appropriately. And then also understanding culture. The way I talk about culture is that it doesn't matter what strategies you have, culture eats strategy for breakfast. And so you look at this from a perspective of, do you have a strong culture? Are you improving? And I'm really happy to say that we're mostly in the blue here. When I look at the data from 5 years ago, we started seeing that there were almost half folks that didn't have any IT OT strategy in place. So culture wasn't even like a thing that you could talk about. Making sure that when you have an incident, the first time that you're introducing yourself to Bob, the engineer at the plant, shouldn't be during the incident. You likely should have had several touch points and be able to know that person before there's something that you're responding to. And so again, seeing this from the improvement perspective has been extremely awesome and very valuable to be able to say that it's not just technology, it's the people that are really going to matter and drive us home going into the future as well. And then I asked the doozy, how prepared is your organization to respond to future threats targeting ICS OT environments? And you can see I've highlighted them right there. 14% said that they were fully prepared. I don't know many people who said that they were fully prepared for anything, let alone future ICS OT threats. What's interesting here is, again, there's probably a little bit of bias for sure. I'd say that this probably also draws itself into maybe a few different camps. The funnest one for me would be the ones who's like truly believes that they are fully prepared, but has nothing in place. They're not seeing any alerts. Like, I've never seen an ICS incident, so I'm definitely prepared. That could be one person who answered this. But when going through the data, I definitely started looking at maturity markers, meaning at this point, we've answered various different questions across threat intelligence, what regulatory standards you're using, how you're measuring your incidents, were you involving your executives? Do you have top-down buy-in? How is your culture? And so I was able to sort of pilfer out the folks that yeah, maybe they're just really like confident, not accurately so, but confident, to the ones that were doing some really cool stuff. That's the audience I then want to drill into, because if I could tell you what those people are doing, maybe that's something we should all be looking at. And so there were 3 major takeaways that they had. The first was to invest in complete ICS cyber kill chain visibility. So again, that was the 13% that said that they were. So this shouldn't surprise anybody, but what may surprise you is the order of magnitude of which they felt fully prepared. They were 3.7 times more likely to have invested in complete visibility across the ICS cyber kill chain. Again, smaller sample size, but a huge differentiator. Like that one stood top and above anything else that was like a differentiator in what it was you were doing. I think that some of that is corollary. I'm not sure if it's causation. What I mean by that is that if you invested in full transparency across IT and OT, you're going to know more about your system. You're going to have a better capability to talk about incident response. There's probably a whole lot of other things that are happening because of that visibility, or because you've got now new information points and data points you didn't have before. So don't use it as like, oh, as soon as I get ICS visibility across the entire thing, I'm good. I'm going to be in that top quartile. Maybe not. It really depends on what you do with it. And that's where we saw the differentiator, because they were also, to the second point, proactive with information sharing. Remember, I said that 20% of the folks that were doing something in threat intel were doing two-way information sharing. The others were not. That 20%, again, was a really key indicator to, did they feel fully prepared? Because they're not just consuming the threat information, they're providing it. So they're sort of top of their game. They got something else that they're able to provide. You probably have a team that's built out for that. You've got workflows of like, oh yeah, we should be reporting that to our peer group or to the ISAC based off the information that we're seeing. That's extremely mature. So again, not like all of a sudden, if you start sharing information with your peers, will you be bumped into this class? But sort of think of like, what is the sort of corollary DNA you need in your program that allows you to do all of that? And then lastly, and this has been interesting for me, I always find it fun when I have a talking point that I've used for years, and then I need to readjust my talking point. And for years, a lot of us are saying, if only the C-suite got it, if only we could do more executive tabletops, then things will finally change. Nah, that was not the takeaway. Because I asked, in your tabletops, who do you have involved in your operational drills and the things that you do for purple teaming? Who's involved in all of these aspects? And a lot of people said executives. That was actually not the differentiator. What was the differentiator were your field techs involved, your operators, your engineers. Bob, who may, again, charge his iPhone off of a workstation in the control center because he doesn't think anything bad's going to happen, right? He just wants to get power to his phone. Giving them more of the expertise to understand the risks involved, putting them through a tabletop, or maybe that was the way that things first got infected, led to almost single-handedly, for sure, if there's one person, I'd be like, that's the person we're bringing into all our cybersecurity tabletops. It's the field techs. It's going to be the operators. Because that led to them being 66% more likely to then get involved and therefore be, again, prepared for future cyber threats to ICS. So these are the big three takeaways. These were the ones that I was like, wow, if I were to look at those mature programs on top of, hey, I answered this question, not I just answered this question, I feel really confident. These are the three that you'd want to be able to start looking at. And if you're not in that sort of category, this is where I'd start pushing you towards, just based off of last year's survey data. Now, this year's survey is going to be a little bit different. Again, try to make sure that we're on top of all the different threats. Obviously, geopolitical things are going to be top of mind, and really cyber resilience. How are we keeping the lights on despite a cyber incident happening? If you're interested in that, the survey information will come out in the next couple of months. But with that, Bryson, I am happy to do any live Q&A that you want to be able to do before Alex comes up, or move forward from there.
I see Alex smiling in the waiting room there. I hope he has. I know I'm actually going to predict he has more AI in his building of his presentation than anybody does today. Alex, nod if that's true. Yep, that's true. I've seen his stuff. It is Hollywood level. Pixar is knocking. If Southern Company can't keep him, he's going to be the Toy Story 6. We did have a question on the survey, because I mean the key to surveys is always going to be the data collected.
Yep.
How are large, small were the organizations that responded to the survey?
Yeah.
I assume SANS doesn't have a list of all the orgs that are in the ICS and OT arena.
Yes. So actually that was in the first slide. I probably breezed through it to get to the conclusionary remarks. It's a typical bell curve. So it's actually it's more towards the small and mediums than it is even the large. In last year's survey, it's never a flat piece there. So there's a lot of smalls and mediums that answer the survey, but the full, when you get the report, you look at the first page, it's got all the demographic information in there.
Okay. So one of the questions, right? Number 3 there on where you see improvement is engaging field operators.
Yeah.
That sounds great on paper. How do I do it?
And unfortunately, it's a culture conversation, right? Like, I don't know any organization's been able to do it right out the gate without at least identifying one person they can talk to about it and then building it out from there. And if you don't have that one person, it's gonna be a three-year journey minimum. Because again, they don't even believe that cybersecurity is a problem. So you've got to start from the very brass tacks of how do I give you awareness and start challenging your assumptions and beliefs about cybersecurity before I then invite you to a tabletop. Because what will happen, and Alex knows I've told this story before, but what will happen is you'll just start having somebody who fights the scenario the entire time, right? If you bring them into a tabletop and they don't believe in cyber like it's Santa Claus, they're just going to be arguing with you and you'll get nowhere. So you have to find that champion. If you don't have that champion, you're starting from like, move beyond posters, get them involved, start doing toolbox talks, safety moments, turn it into security moment in meetings, meet them where they are. It's a tough cultural thing then.
And that is going to be another trend that you're going to see whenever we're talking about the executive level. So for those of you interested in this kind of thing, I do a regular series called Unicorn Dispatch Live. I just bring in interesting folks from around the industry to talk about different aspects. And you're going to see a recurring theme with the CISOs where most of the conversation is not going to be technical.
No.
Most of the conversation is going to be this executive level of how do I influence what I'm trying to do? And I'm using that word intentionally. Here's some facts. One, most CISOs aren't actually true C-suite operators. They are like second-tier citizens.
It's a little C, not a big C.
Yeah, it's a little C. It's a good way to phrase it. Little C versus big C. They tend to report to another C. Two, they don't report directly to the board as a result. And so much of their job is actually working with the culture and the communication and building peer relationships to help security actually provide the service that they're being asked to do. So I share that because a lot of folks don't realize what a CISO's job really is supposed to be. And it isn't technical. It's creating the proper shit umbrella for the rest of us to do the jobs that we're trying to do.
1000%. The last executive roundtable I did, which I'm supposed to be all tech-based, right? Like it's all like my day job is all technology trends. It turned into a change management, culture management 101 discussion because that was the number one pain point. And I think to your point, that's going to be the trend for, I think, forevermore, because you have to convince people that they want to do this thing versus just like shove security on them.
Well, fantastic, guys. I do want to kind of cut this one off.
You get a mark instead of a hook.
Yes, you got me hooking you guys. So I want to get Alex on and really continue the discussions around OT. I think this is a good follow-on session. Jason, thank you very much. Really, really informative session. And we will turn it over to Alex. I know he's got his slides ready.
Awesome.
And, we'll all jump off and let him get into it.
Awesome. Thank you all.
Wow.
Alex, are you like piloting from like a fighter jet there with that headset?
No, just trying to do active noise canceling in return to office world, Got other people around my cube, so I gotta try to keep noise down and try to keep my noise down as well.
If you were being really cool, I mean, considering you work at an actual asset owner, you could have said it was all the noise from the industrial control systems, but instead you went with a weenie office environment excuse.
Well, and I will say that this deck may disappoint from an AI imagery perspective because I actually pulled direct information from the threat intel platform that we are using that drove kind of my S4 talk. So we've got a little bit more data driven analysis here for everybody today.
Okay, so if you have complaints about the graphics, call Rob Lee.
Yes. All right. So we'll go ahead and get started. So good afternoon, everyone. I'm Alex Waitkus. I'm a principal cyber architect for Southern Company. And today I'm going to talk about something that kind of keeps me up at night. And really, if you're a cyber defender for OT, it should keep you up too, right? We've spent years building walls between IT and OT. We've used Purdue, we've used, IEC 62443, we've built DMZs, firewalls, jump servers, all designed to create separation. But the adversaries we're tracking, they don't respect walls, and they find access through approved mechanisms by, stealing identity, credential theft, adversary in the middle, etc. And they treat IT and OT environments almost as one continuous attack surface. And when they cross from one to the other, most of our detection architectures go blind. And really, we're going to talk about that blind spot today, the cross-zone kill chain, and how we can use a framework that I presented on S4 called OT Insight, which, really is operational technology, intelligence-driven security, investigation, and guided hardening through tactic emulation. This framework is built on multi-source cyber threat intel to find, map, and close any of the blind spots that we may have in our various environments. So really, we kind of start with the problem. And there are three things that work against us. The first one being detection seams. So enterprise security tools and OT security tools really operate in isolation. We might have a integrated SOC or distributed SOC model, but a lot of times the security operations center really only sees half of the picture. And your OT teams see, that other half. And when an attacker moves from IT to OT, they really kind of pass through that seam where neither side has full context. Second, we've got dual kill chains, right? We'll call out the enterprise attack and attack for ICS, and they really kind of move through both of those. And we need to be able to identify and stop at different parts of various kill chains to limit their access or prohibit their access. And then we have visibility gaps. Jason Christopher just talked about, the current OT cyber capabilities out there and what we're doing from a detection piece. And, we're making a lot of headway in the detect piece, which is really the most important part. But even there's still a lot of visibility gaps and blind spots. And we need to really understand how to collect the data to be able to close those gaps. But some of that really kind of starts with that threat-informed perspective. So before we get into the kill chain analysis, I kind of wanted to show what's powering the work, right? So this is our threat intel platform that we're building through this OT Insight framework. And yeah, it's a little bit Python-based, Streamlit dashboards and things like that. But what we're really trying to do is we're trying to pull out the things that we need to understand how the adversaries work in our environment. I've said it before, I've said it again. If we're using threat intel or we're throwing away threat intel based on the color of box in the report, we're doing it wrong. We need to assume that the adversary has the capabilities to attack any of the color boxes that we may have in our environment or you may have in your environment. So we really need to stop thinking about indicators of compromise, vendor CVEs. While those are important to us, they're not relevant to all of us. So as we start, extracting threat intel and pulling out the tactics and looking at what the adversary is actually doing in these environments, we can start understanding how to apply threat intel to our environment, even if an adversary is not targeting the color boxes that we have, in that report that we receive. So what we're looking at is we're kind of filtering out based on a couple of adversaries. We're not, taking in all CTI for this example. We're just looking at two, and we're mapping the TTPs, and then 78 of them are really kind of the critical TTPs, and 17 across 17 MITRE tactics that are observed, and then the two different kill chains, both enterprise and attack for ICS, analyzed in parallel. So the bar on the left shows the most active TTPs by usage count. Remote access is the number one technique, right? And you have remote access into your enterprise environment. You may have different or same remote access into your OT environment, but you really need to start understanding what are the things that the adversary is going to use against you, and then how can you build out detections to identify when there may be credential misuse or session hopping, things like that. So now we're kind of looking at what the landscapes looks like broken down by the phase of the kill chain. And this part, kind of looks at coverage by tactic and the life cycle over the different phases. And I kind of zoomed in on the key up in the top right, so we kind of see, you kind of have your pre-attack, your staging, your initial compromise, your foothold, internal operations, and then mission execution. And what jumps out immediately is the highest density is at the command and control collection piece, and then the impact piece. And these are really the end game stages. And those are where the adversaries are the deepest in our environments, both on the enterprise side and the OT side. And this is where we have the least detection coverages historically. And what does that mean, right? The adversary has the most options at the point where we have the fewest eyes watching. And that's the cross zone problem, kind of almost in just one chart. And now let's look at how kind of the attacks flow, right? This is a Sankey diagram from our tip looking at the enterprise attack progression annotated kind of with the Purdue models. And really here we're kind of going, you can call out level 5 on the internet side, or you can call out, starting on the enterprise. So let's assume compromise and we'll start at level 4, our enterprise network. And then we're really going to kind of go through that OT DMZ or 3.5 and then really get into that initial OT network before we even start going down into the physical process. And what we're seeing here is we're seeing execution and persistence happens at level 3.5 and level 4. And then as we start crossing more zones, we start seeing events, defense evasion, credential access, discovery, all of that kind of going from this level 3 to level 4 piece, or excuse me, level 4 to level 3. And this lateral movement and pivoting, it also involves some collection. So they're understanding how to move through our environment from the corporate network to OT, and then they're collecting information about our OT environment, because a lot of times in these DMZs, we may keep things like config files or gold copies of configurations, documentations on how we configure different things, work practices, etc. And really, as you start moving through these choke points, these are the tactics that span the most Purdue levels at once. And if you're going to invest in detection, this is really the best place to start, right? From your enterprise environment to your OT environment. It's going to allow you to really kind of bring that big bang for your buck to try to understand what's going on. And it gives you the widest coverage. And each transition here is really a detection opportunity. And as soon as you have that detection opportunity, you also have that protection opportunity. And sometimes, we'd love to say we'd like to prevent everything. But we're going to get to a point where prevention is no longer the first thing on our mind. We need to think detect first. When we detect, we can action. And we can understand how our architecture and our capabilities from a defensive perspective can respond to the adversary through kind of studying threat intel and even analyzing our cyber capabilities in lab and production type environments. All right. And now we're going to get into the OT side, right? So we're going to kind of go all the way down to the physical process. When we get into the ICS attack kill chain, the attacks kind of go into two different sections. The flow kind of starts at level 3, the control center or the engineering workstation through discovery, lateral movement, and then you kind of go down to that level 1. Collection at level 1 and 2 really has that command and control chain back up to level 3. And then you go back to the enterprise side, that level 3 will have command and control back to the DMZ and or the corporate network, depending on your access policies. And then you really kind of get into the unique stages of the kill chain here, right? Inhibit response function and impair process control. These are the two things that really are the biggest issues that we have to prepare for. These are the bad days. Anytime we inhibit our ability to respond or a device's ability to respond to a physical process or a physical stimulus, we can potentially lead to loss of life, harm to life. We can lose load. We can stop manufacturing. We can do all of those things, and that's really kind of the hard part of this is how do you properly defend in OT environments where this active defense piece doesn't always work. And then, we really need to also look at the ability to manipulate the physical process. So not just disable safety, but also manipulate that physical process, opening breakers, modifying relay settings, changing transformer parameters. And if you're not detecting really at that level 1 and 0, you really don't see this piece until something breaks. So you've got to start looking at where in this kill chain we may have some opportunities to kind of really detect and understand how the adversary might work. So much like my S4 presentation, I'm going to kind of call out two different threat actors, and I'm not going to talk from a threat brief perspective, right? We're going to take what they've done. We're going to apply the OT Insight methodology, which I think if you just, look at S4 and my name, you'll see a presentation on S-bombs, which we don't want to talk about that much anymore, because I don't think the world's ready for those yet. And the other one's on operationalizing, or a case study on multi-source threat intel. And what we really did there is we broke down a couple of different threat actors, and we looked at multiple campaigns, not multiple threat reports, right? Not like a threat report from vendor A, vendor B, and vendor C, different campaigns. And we may consolidate a threat reports from multiple vendors, but really that multiple campaign is how we start looking at prioritizing the tactics that they're using. And then we also look at overlap between multiple threat actors. So Sandworm or Electrum in the Dragos taxonomy is a Russian APT, and they're responsible for the Ukraine power grid attacks, which they still are doing. Even during the kinetic war, they're still doing cyber attacks against OT infrastructure in Ukraine and surrounding countries, excuse me. And really, we're looking kind of at that initial access at level 4, and then getting into that OT environment using command line scripting, collection, data exfiltration, defense evasion, file deletion, masquerading, and then kind of moving down using different types of Windows capabilities, whether it's PowerShell or SMB, and then getting back into that level 0 and level 1 where they can do that impact. And each time they cross that kill chain, we are provided with an opportunity to detect. So we can also, look at Volt Typhoon, and we can understand that while their playbooks may be different, there are some tactic overlaps. And we can look at initial access where, Volt Typhoon is looking more at valid accounts. They're not just breaking in, they're authenticating. So how do you know when those credentials are not the user that you expect to see? That's another piece of the puzzle that we need to, really figure out, is how to identify legitimate credentials. So we can, look at MFA and even phish-proof MFA and things like that. But as long as there's low-hanging fruit out there, the adversary is going to find it. And then you get into the lateral movement from level 4 to 3.5, using valid accounts again, and then Windows remote management stuff. And they're all using kind of your own tools against you, living off the land. Sandworm does this too. Iran does this. Everybody uses these living off the land tactics. They're easy to understand if you collect the right sets of data, but you've got to make sure that you're getting the right sets of data to the right people to be able to identify these. So Sandworm may have a little bit more smash and grab. Volt Typhoon maybe a little bit harder to detect, but even there, you can still understand how they move across the kill chain and how you might be able to identify their activity. So now we kind of get to the detection gap. So we've got 5 Purdue levels. We've got 4 boundaries between them. And at each boundary, we've got a specific detection gap that adversaries use to exploit. Kind of from 3 to 5, it's the identity pivot. IT credentials are reused for OT remote access. Does anybody, go and verify that your OT credentials don't match your IT credentials? Or do you use the same domain for enterprise and OT? Right? That's a good opportunity to kind of look at enhancing our capabilities. And then we go kind of down from that level 3.5 to level 3, where you might have VPN, RDP. Again, a lot of this is still credential abuse, remote access abuse, jump servers, and those are really the gateway. As soon as you get to that engineering workstation or that jump server, those are, some of the crown jewels that are the highest value pivot points from that enterprise to your OT environments. And they can also be your least monitored. So doing things like session recording, and doing as much limiting through access control policies and monitoring of command line use and various things can really help here. And then, as we go from level 3 to level 2, the SCADA to almost HMI pivot, traffic crosses this boundary. We may have some protocol translation, identity context starts to get lost, and then the connection that was once authenticated as user A at layer 3 becomes an anonymous protocol down there at layer 2. And then as we go from level 2 to level 1, the question becomes, do we have anything firing here? Is there anything that looks for access? Do we have proof that our, internal network security monitoring system is seeing anything? Are we collecting this data? Do we have serial data that we need to figure out how to see? Or is this at a layer 2 or layer 3 level that we may need, specific OT protocol parsers? And this is where that work with your OT cyber capabilities really comes into play. It's very much a personal decision what OT cyber capability you go with. You really need to understand your OT environment before you make a decision on what OT cyber works best for you. They all don't cover the same protocols. They all can't dissect at the same level to see down to breaker operations from specific types of relays and different vendors. And again, you really can't defend against what you can't see. This is one thing that we harp on here, and one thing that I really like to talk about is if you can't see it, you can't detect it. So we need to think about how we can collect as much information as we can and build out different types of detections that work through various complex data sets. And you'll start to see here, kind of almost as a little bit of a sidebar, this OT cyber capability that you're building can also build operational intelligence, and you can really understand, how this data applies cyber and operationally. And then you're starting to build almost a multi-use system where that cyber brings operational value to it as well. So we worked through a real attack scenario, and this is one where Scythe kind of really came in and helped out a lot with us. And we looked at Black Energy 3. Now, Black Energy 3 was built for systems that I don't have, using protocols that we don't use. So we customized the tactics, or we customized the adversarial actions based on the tactics used in Black Energy 3. And then we found a way to pivot from that enterprise environment to the OT environment. Again, we assumed compromise of our enterprise environment. And then we started prioritizing these TTPs behind, Sandworm's Ukraine attacks. And then we started modeling that kind of pivot from IT to OT in this simulation or emulation. And we targeted, the engineering workstations. We targeted different types of RTUs and or relays to try to really get down to that operational impact and what can we see and how can we work through different things like, process impairment versus process control. And then how can we build detections around those things? And, we're able to see a lot of this traffic, and we're able to potentially detect a lot of things, but we started seeing things like, maybe encryption is bad. If we can't see into the packet, we can't understand what's going on. There may be an encrypted or TLS session to that RTU or to a database on one of your OT systems. And if you're not looking inside that TLS session, you really can't see what's going on. But if you start looking at targeted dissection of encrypted protocols or looking at proxying those encrypted communications through a point where you can actually see what those adversaries are doing or what those even users are doing, you can start really understanding what's normal, what's not normal, and you can build different detections based on what is supposed to happen through vendor provided tools and what might happen if an adversary comes behind you with a tool that was custom built for your environment and not really looking at how that vendor provided tool works, right? So they're not going to work the same. Yes, you could spoof it, but it's going to take a lot of work to get a lot of that spoofing. And then, we bring in that identity piece and we start trying to understand that identity access logging, and that brings us that identity audit trail so we can start tying everything back as we move further up the chain. And then we can use this adversarial emulation to not only verify and validate, but also build and enhance detection capabilities. And it gives us the ability to understand adversary techniques and how to observe them. And that's really kind of what we're getting to, right? Is we want to see that adversary tactic or technique where we need to see it and where it matters the most. So what this cross-zone, kind of detection architecture might look like, if we start at the enterprise and we move in, we might need that EDR on the enterprise side. But even there are different opportunities to operate where that EDR doesn't see or can't see, or there's limitations to that EDR. We have our SIM, our security event logging and aggregation platform, right? We've got our identity provider, SSO, MFA. We've got our next-gen firewalls. And then as we move into that DMZ, we need to do some of that decryption. We need to make sure that we're logging authentication and remote access logs as much as we can. This is where, if you don't have EDR and OT and you kind of have that OT environment where you don't want it directly connecting to the internet and you haven't found a good EDR that works, something like Sysmon can really help here and get command line logging and some enhanced capabilities. And then, at that level 3, even level 2 piece, that's where your OT IDS, something like a Dragos or a Clarity or a Nozomi really works better. You start getting that access logs and even looking at the baseline communications from that engineering workstation and the Windows events that come from that workstation. Because as you start working towards those living off the land techniques, you'll be able to see, how you can correlate, Windows remote management activities that are valid to, maybe a event that's kicked off that doesn't have a precursor event. So, right, you start that multi-level access modeling, and you need to work through those different levels to understand what's valid at what time with what comes before it. So kind of like DNP3, right? You should always see a read, select, operate, right? You really shouldn't see an operate command all by itself. And if you do, that might be worth investigating. Now, there may be opportunities when that actually happens in real life, but that gives you a place to start, right? And then you look at your INSM system, providing that east-west visibility across your control center and even down into your level 2. And you kind of look at that session monitoring of HMI, and that protocol analysis and dissection becomes really important here. Because at this piece, you're either working with a well-known protocol that's easy to see into, or you're looking at a vendor proprietary protocol, which is really hard to understand if you don't have that capability built into your detection capabilities. And then that level 1, level 0. A lot of times your INSM system may stop somewhere between that layer 2 and layer 1 if you go serial, kind of that last mile, which a lot of OT environments still use a lot of serial. But here you can also look at that IED monitoring, syslog collection, and even that boundary telemetry validation. You want to understand what is normal. I got a guy that I work with. His name is Guy, but he loves to say that you can't understand your environment until you understand what's normal. And when you start to build that view of what is normal, you'll start to understand normal communications versus, abnormal. And abnormal doesn't mean bad, right? It just means out of the ordinary. And you can use things like math, and you can do entropy analysis. You can study randomness, something that you do to study encryption. You can also do it to study, normal day-to-day communications from A to B or B to C. And you can start mapping that, and you can do things like cluster analysis. You can do multi-level graphing. I mean, there's so many different things you can do to start baselining your system to really understand what's normal. And even there, your OTIDS may have some baselining communications, but we really need to stop thinking like NERC SIP baseline, A to B on a port. That's not a baseline to me. We need to start thinking about quantity over time and variance in protocol functions. That's really how we start building these baselines that can help us across these various borders. So we take all this in, we throw it into our tip that outputs a simulation that we work to build, and then we tested our assumptions in a lab environment built to look like a couple different environments. And we can see that we can build detections early on in that kill chain where we could potentially stop that OT impact. But as we're building our defensible architecture, right, we need to be able to absorb that adversarial activity in some cases and operate through compromise. I think the Department of Energy is doing a study right now on operating while compromised. Can you have compromised devices in your OT environments and still operate with them if you can trust the telemetry coming from them? That's an interesting topic of conversations. But if you're focused on standard signature-based detections, you might have less success than if you're focusing on custom detections built to look into your environment and understand your normal and starting to look inside your encrypted communications, etc. And you can track this over time. You can also build out, different types of scenarios for leadership on what it would take to close these gaps. And understanding what it would take to close these gaps can also help you quantify the cost to close the gaps and where are the most cost-effective points to close gaps. And then you can also, understand these are the specific tactics that Sandworm used during Black Energy that we currently cannot detect. These are the levels of the Purdue model that they execute at, and here's what we can do to do it. So you can really understand at the different parts of your enterprise to OT environment where your visibility gaps are and how to close them. So, the kill chain, it's a great way to think about how an adversary flows through your environment. And the adversary is always going to evolve, and we're always going to have to try to catch up to that adversary from a protection or a detection standpoint. Studying threat intel, testing your systems, not just in a lab, but also in production, is super important because labs are usually built to be pristine. Production environments have variance, a lot more opportunities for human error in a production environment where a cyber tool or a packet may route a way that you don't see it, or a switch doesn't have a tap installed on a port, or a span is not implemented correctly, and you have that visibility gap. So you have to assess your cyber capabilities in a way where you focus on least opportunities to impact your OT environment. So kind of really have 4 different takeaways, right? We need to map both the enterprise and ICS kill chains to our Purdue levels. And if you're only looking at one, you're only seeing half the attack. We need to deploy detection capabilities at every zone boundary, not just the perimeter, and we need to get our detection capabilities or our opportunities to detect as close to the assets that we need to operate in our OT environments. And then we want to make sure that we're validating our architectures. There's an awesome opportunity that some of us have the opportunity to participate in annually called Liberty Eclipse. It's a Department of Energy live fire, no consequence cyber exercise on an actual electric range. So you can see the physical impact that could be caused through cyber, which is awesome, eye-opening, and really cool to understand and see. It's expensive to put on, and it really only happens one time a year. If you can build out this program to assess your cyber defenses and your posture, it allows you to iterate through architecture and capability enhancements at a lower cost, faster over time, and allows you to close that gap faster based on that threat intel. And don't assume that your detections work. You need to prove it. You really do. You need to prove. You can't just throw your vendor name into MITRE Defend and say, well, this vendor covers these tactics and these parts of the kill chain. Well, great. If they're configured in such a way that the vendor tells you to configure, what if you don't have a signature set to prevent? What if you only have it to detect, right? So you need to understand how your cyber capabilities react in your environment. And then you need to measure your coverage. You need to really understand what it is you can see, what it is you can collect, and how you can operate through different levels as a cyber defender. And again, the defensive part is the hard part, because we're always chasing what the adversary has done. We don't have an opportunity to know. We don't have a magic 8-ball that says, this threat actor is going to do X against us on this date at this time. We have to be kind of prepared 24/7, 365, and really focus on closing this. And this is where, again, I'm going to harp on it one more time. Studying threat intel, taking the relevant data from the threat intel that can be applicable to any of us, not just what's applicable to that green box over there, and then pulling out the tactics, building out, so throwing on your adversarial, mindset, and thinking about how you can use this tactic in your environment, building out some type of scenario to where you can execute that and you can verify and validate your capabilities. There's also this cyber digital twin where you can do some of this in kind of that modeled environment that I think is an interesting topic to think about in the future, and how that can help here as well. It really helps us kind of move away from that shotgun enumeration perspective, where we don't have to mass scan our environment for known holes or unknown holes. We can use that model of our environment in a cyber digital twin to kind of close our focus and understand what paths are really most important to look into. So thank you all for your time. I got my email up there. Feel free to reach out if you have any questions. Bryson, we may have a couple minutes for Q&A if that works, and go from there.
Yeah, you made a comment in here about using real emulation in production operation technology. Mm-hmm. And I think anybody who works in OT would immediately cringe at that comment.
Yeah,
how do you do that?
Yeah, you take a platform, so we're at Scythe UniCon, right? So you take a platform like Scythe, you build your agent to mirror your OT device. It doesn't have to be the exact RTU, right? Because you can't run an agent like Scythe on a closed platform. So you build it to look like it. You have open services. You have running, the same ports that are open, whether it's a database port or an SSH port or a TLS port, you have that open, and that's kind of your crown jewel. And then you have another device somewhere else in the chain that you're pivoting through, and you use that one to attack your mimicked device. They can live in your OT environment, but you're not attacking your OT systems. Does that make sense, Bryson?
It makes sense to me.
And we've had success with that too. So working with our OT business partners and talking through this and showing them that we can do this and not impact their ability to operate is really important too, right? Kind of go back to that barbecue model, right? We can only become friends through barbecue, right? Collaboration, conversation, communication, and honesty, and bringing them to the conversation with us.
That's funny. So at West Point, we have mandatory psychology classes, and the first year is basic psychology, and then the advanced psychology class is on leadership. And the running joke in the class is that everything can be solved with a barbecue, because you bring folks together, and that's how you're able to communicate common vision and have a dialogue.
Mm-hmm. Yep.
So change your culture at your asset owner with brisket.
Yes, or ribs.
Alex, always appreciate your time. Good to catch up again, my friend.
Yep. Thanks a lot.
Thank you very much. All right, folks, we're going to take another small break. We will reconvene at 4:05 p.m. Eastern. And at that point, Christian Nicholson will be on to talk about security ops automation. And with that, let us know if you have any questions. Otherwise, we'll see you guys at 4:05. Hey, Christian.
Hey, Mark, how's it going?
Pretty good. Are you in Japan?
I am. It is bright and early over here.
Cosmo wins the award for the furthest distance as a speaker, which you can't tell at all because we're remote.
Yes. Well, fantastic. I'm glad you were able to join us. Why don't I let you, we'll get your slides up and let you jump into this session. I know this was one of the hotter ones that people wanted to see, just, talking a little bit more about sales, where the, the security ops and automation and what AI can and can do. So I'll turn it over to you.
Awesome. Looking forward to it. Thanks, guys. All right. Thank you guys so much for joining us. Today, we're going to be talking about security ops automation, where AI helps and where it breaks. We've got a lot to cover and not a lot of time to cover it. So why don't we go ahead and get right into it? So first, a little bit about me. My name is Christian. I am the CEO and partner over at Indelible Security. I have about 20 plus years of industry and community experience. Don't let the baby face fool you. I am part of a number of different information security communities, DEF CON, Black Hat, B-Sides. I've been attending conferences all around the world, and I've also been fortunate enough to be an advisor to several large tech companies. I'm also a Japan Innovation Event Ambassador and a former SaaS instructor. So why this talk? So in the age of AI, I think there's a lot of popularity and everyone's trying to find a way to use it. And one of the problems that we still have is the signal to noise ratio. After years of automation, SOAR, XOR, we still see signal to noise ratios and alert fatigue as a problem that many companies still have and are still fighting with, especially in their security operations center. We have the AI hype cycle. AI represents a promising new way to accelerate parts of the workflow, but it's really important that we use it correctly. It also represents a high degree of risk, especially because we're looking for, in many cases, a deterministic outcome from a non-deterministic piece of software and machine state. Now, the goal here is really to leverage our new tools and be able to move from automate everything to automate the right things and automate them safely. So let's talk about where we're going to go today in this talk. So first, I want to do a little bit of level setting about AI. What is it? How do we use it? You guys have heard lots of different talks today already on the topic of AI in the various sessions, and I'm sure that many of you as attendees here are already interested and have done your own research into AI. But I do want to level set about what it is and what it isn't, especially in the context of this talk. Next, we're going to talk about triage boundaries. Where is the line between a good and a bad use case for AI related to triage and response, specifically in a security operations organization? But we'll also touch on topics outside of the organization as we talk about, what AI is and do our basic level set. Next, we're going to talk about the automation risk and the AI-induced blind spots. We're going to talk about some real-world risks of AI and AI automation in the context of security operations, what blind spots we should be worried about, and where we should use AI in our workflows. And then last but not least, let's talk about how to do it right, because we want to do it right, but it's all about the how we do it right. We'll talk a little bit about escalation validation, and I'm going to say it with every one of you now at home, right? Security industry hasn't changed much. We're still following that same mantra, trust but verify. And lastly, let's talk about safe containment workflows. When it comes to AI and when it comes to systems in general, you should always be designing for failure to avoid those blind spots. So let's level set a little bit about AI. AI is like an overeager, excitable intern. It's important to understand that AI is your intern. We all know that we've got one of those interns, and we've all been that intern at one point or another, especially when it comes to the hype cycle. It's really easy to get really excited about new technology and all the possibilities and things that it can do for us, but it's really important to stay realistic about what it can and can't do. It's not the magic fix-all solution, and there are good use cases and bad ones. First and foremost, AI is a tool. You need to treat it like a tool. You need to use it like a tool. You need to make sure that the people using the tool know how to use it and that we understand what the tool is actually doing under the hood. Now, this isn't any different from what we've said in the industry for years now. I can't tell you the number of tabletop exercises that I've been to and that I've had the pleasure of organizing and running, where I've had someone come in and the second you take away their fancy EDR, all of a sudden they don't know what to do anymore. All of a sudden, no longer is there a Splunk, and suddenly, how do I query that Windows log if I don't know how to get to it? I can't hit quarantine and contain. I can't hit remediate in my EDR. How do I actually get into the box on the command line, navigate over and close that hole, move that file, grab that sample? And the number of times I've been in a tabletop and people just don't understand what their tools are doing under the hood is growing more and more by the day. We've created an industry of tool jockeys instead of people who have true understanding. And AI is only making that worse. We'll talk a little bit later about some of the statistics and some of the different reports that are out there that have actually already started to do studies about how AI has impacted our cognitive capabilities and some of the pitfalls that that's led to. Next, we need to remember that it's important to optimize and not replace. AI is not a replacement for manual skill. It's not capable of replacing an operator or making some of the complex decisions that we need to make in our day-to-day jobs. But what it can do is it can enable and enhance us to make better choices, make more consistent choices, and also assist us in things like data gathering and information gathering to make these better choices in a more contracted timeline. And last but not least, it's important to remember there is a right tool for the right job, and choosing the approach is important. We have things like generic large language models, which are great for things like text summary and lazy web search. We also have cases where we might want to use platform-specific knowledge. We might use RAG. Environment-specific insights are going to be required. It's going to be important to make sure that we're preceding knowledge into our tools, and we're using things like dedicated MCP lookups. MCP servers are really, really awesome when it comes to these automation workflows, as we can add some concrete tools into our non-concrete and behavioral-based workflows. It's also important to talk about custom training or data enrichment opportunities. When and where is it the right time to create a dedicated automation or to create a custom-tuned model for your organization? In many cases, if you are just a standard organization, small, medium business, or enterprise, and you're not working at the MSSP level, you probably don't need to create a custom model or do any severe customization outside of maybe an internal use case that you've got that's unique to maybe a custom tool that you've built in-house, or a custom system that you have, or a very heavily customized environment that you don't see or find across other areas or industries. Otherwise, you're probably going to be focused on really using AI in one of the first two models, either the generic or the platform-specific knowledge. And last but not least, let's also remember not to abandon our existing knowledge repositories or procedures. We can reuse them even with our new tools. Many people have spent years curating their knowledge repositories and their knowledge bases with really concrete evidence, examples, samples, and step-by-step instructions on how to handle a given situation within the context of your organization. It's not a great idea to abandon those procedures in favor of whatever the current AI model spits out. But instead, let's use those as enrichment. Create custom MCP servers for our internal tools, create custom MCP servers for our internal knowledge bases, and let our tools have the ability to search and enrich themselves so that we're not losing out on that institutionalized knowledge that we spent all this time creating. So where do the boundaries exist, and where do we draw the line? It's really important to define what is the safe zone, where is our hard stop rule, and how do we balance that with human oversight? So when it comes to the hard handoff, right, versus the soft assist, we want to really define the threshold where an AI stops acting and a human starts investigating. I'm sure everyone is getting tired of hearing it. It's the new phrase of the week, human in the loop. It's the most important thing when working with AI and LLM systems, because it's the core of every activity, making sure that we maintain a certain degree of consistency and expectancy in all of our outcomes. It's also the core of triage boundaries when it comes to using AI in the SOC. The hard handoff is when we move to fully automated resolution. And this is great for low risk or high volume alerts, things that are known, right? So benign scanning, automated password resets. We'll talk a little bit more about some good and bad use cases in a later slide. And the soft assist. The soft assist is where an AI provides context enrichment. It gathers logs and maps to different frameworks. It might be MITRE, it might be MITRE ATT&CK, it could be an internal compliance framework that you've also got a customization for. And again, that's where that MCP server RAG-based approach becomes really important. And lastly, we want to be able to summarize the threat. This is another great example of a soft assist from AI. It stops short of taking any real action, and it leaves that final action statement of whether or not you want to go through with it to an analyst. We want to make sure that we're equipping an analyst with as much information as possible to make good choices, but we also want to maybe try to suggest what actions we think might make sense based on either the AI's understanding of our existing procedures that we have in our existing knowledge bases, or based on some situational ideas that it was able to come up with itself when it gathered the information. Now, when we talk about a hard handoff, we have a fully automated end-to-end resolution here. Now, great examples of this might be, as mentioned before, benign scanning. Maybe we want to check that domain or IP against any known TTPs, block lists, or other IOCs inside of our threat intelligence databases. Maybe we want to do an active lookup. We can look at domain information. We can look at how old the domain is. And we can allow our agent to kind of incorporate and gather that data on our behalf and incorporate it into an overall decision. Now, for low stakes things like this, where we might have a fail-safe list of our internal addresses that we never want to block, we may want to just allow that to be a fully automated end-to-end resolution. It's low stakes, it's easy to undo, and the value is rather high in terms of our level of confidence with the outcome. Now, soft assist is great for context enhancement. It's enrichment, it's data gathering, it's summarization. We don't want to take an action without approval, though. And so these are the most common good use cases for AI in the SOC. How can I take an alert, correlate it against other similar like alerts or events that might be relevant to a total attack story? How can I look at that into one holistic view all at once? And how can I pull in other data proactively before the analyst ever gets to looking at that initial triage to make a good decision right away? Now, that's not a replacement for doing a manual investigation. And of course, go back to one of our earlier comments, you always need to trust but validate, right? So we still don't want to take any approval without first checking the work, even if some of that information has been gathered for us. So the hard stop rule, it's where the AI is forbidden from making a final decision. And again, that's bringing that human in the loop back to reality here, especially when it comes to an impactful action. One of the biggest mistakes is expecting the tool to do all the work for you. Don't completely outsource your brain, and don't blindly trust your agent. Remember, human oversight and balancing is important. The right tool, the right job. Ask yourself, is the task known and repeatable? And are the inputs and outputs consistent in shape or variable? What's the impact of resulting action? And what is my confidence in the consistency of the result? Remember to check the work of automations and agent actions. Never, ever go ahead with just the defaults. Define a threshold and make sure that we have confidence intervals where we can kind of dictate whether or not we think this is going to be a good choice. Now, with each use case, we might set different confidence intervals as well, where we can already govern the automation. We do this today with traditional SOAR and XOR and the fidelity of alerts, but we can further enhance our workflows by adding agents into them as well to better equip ourselves for making good choices. Regularly automate those actions, and let's also make sure that we're regulating them and checking them against our benchmarks. Set KPIs and thresholds. We might say that, if we have a good alert, we have that 80%, 85% confidence interval on our automation. So we know that that's relatively reliable, as opposed to other automations where they may be a little bit less reliable. So what's the right tool and when and why? let's talk about fixed input versus fixed output. Fixed input and fixed output based automation is great for traditional automation. It's high speed, it's zero hallucination. It's the old school philosophy of if X happens, always do Y. It's great for structured data and great for predictable outcomes, repetitive workflows, wherever consistency is going to be of the highest priority. Whenever you have a vague input, but you have a goal-oriented output, these are great use cases for agents. This helps because we can handle ambiguity and unstructured data well in these use cases. And it works great with a philosophy like, here's the goal, let's find the best way to achieve it. Agents excel at dealing with unstructured data, multi-step reasoning, and adapting to gray area type scenarios. So if we pair this with our confidence scoring, we can help humans decide whether or not to complete the suggested action and create conditions that allow us to occasionally take an automated action if we have really high confidence thresholds. And last but not least, anything that's a high business or legal risk should be manual only. This is always going to require some manual interaction, and that's going to be because it has a high degree of required accountability or ethical nuance. The philosophy here is high stakes, low data, ethical complexity. These are boundaries that neither a script nor a model should ever really cross. Now, we've talked about 3 techniques here, but they don't exist in a standalone vacuum either. We can pair all these techniques together. They're not always going to be a binary operation, and we can combine them. We may have a AI-assisted information gathering step where we do a level of enrichment that exists on top of a traditional automation. We may have an AI that we allow to call a tool server to take an absolute action that's concrete based on behavioral or discrete analytics. And we may also have a phase where we combine all 3, where we have some level of automation that's input into an agent. The agent's allowed to conduct these prefab queries or searches that we've already constructed ahead of time for it using MCP servers. And then last but not least, bring it back to the human to make the final decision. Here's the suggested action. Should we correlate these 6 events together? Do they actually make sense? Do we want to take that remediative action? Do we want to quarantine that host? Do we want to pull that file? Do we want to take another step to analyze, or do we want to go ahead and block it? If it's an email or a phishing exercise, do we want to pull that email? Is this a known phishing exercise that we can cross-map against? And again, we want to make sure that we keep that feedback loop tight so that each time we make any of these decisions, we can tune the behavior so that we can regularly review our outcomes and make sure we're meeting all of our goals. So we've talked about choosing the right tool. We've talked about some level setting. Let's talk about some good and bad use cases. So what are good use cases? Some good use cases might be data gathering or initial incident investigation. This is great because we can use AI to automatically try to correlate like incidents or events into one combined incident. Have we seen the same behavior across a number of users, systems, devices? We can create a unified case and look at that as a whole, as opposed to investigating one by one and then trying later to correlate and look for total spread or pivot. We can also perform those lazy search type actions, right? Is that domain old? Is it new? Is that domain seen before? Have we seen that on a known threat actor list? Does the overall pattern match something that we've seen before or that we recognize either internally in our own knowledge base or externally in one of our CTI threat sources? Another really great use. AI is great right now based on its language basis to do summarization. So drafting notes and having better, higher quality incident notes or event notes is a great use of AI. We can use that to do cross-silo pivoting as well and orchestration. So we can present an attack story, again, against multiple detections in a unified fashion, making it easier and faster for an analyst to actually go through an automation or take an automation action based on a series of existing similar events and patterns that we've already analyzed and correlated together. And then last but not least, non-destructive remediation. We can automate quick and safe responses based on known consistent behavior patterns. This is a great example of combining an AI agent for combining cases and doing summarization with something like an automated rule. So we can do things like blocking known bad actors, finding known attack patterns, or doing regressive searches across an organization for things that we've already seen and classified earlier. It's also great for quarantining an asset for human review. So what happens if we have a lot of really high confidence signals that a host is in fact behaving in an unexpected fashion? We may have a use case that if it meets a certain threshold of criterion, we can quarantine via a non-destructive fashion. When I say non-destructive here, that might be putting it on its own VLAN. It might be isolating it from only talking to a designated investigation series of servers and asset points, but restricting it from accessing other corporate resources. We may want to put it in kind of a no man's land where it is largely cut off from the rest of the environment, but we can still access to investigate. And for appearance purposes, from the attacker perspective, it still looks like it's connected. So we can use it as almost a honeypot to further our investigation as well. And that kind of brings us to that point here about orchestrating temporary blocks across multiple layered bases based on behavior. Last but not least, we might want to do something simple like force a user to re-authenticate. With M365 in the modern world, as well as things like Google Workspaces, we have a lot more high detection capability on risky sign-ins that we can use as signals and patterns to incorporate into our decisions and make good choices about whether or not, hey, do we want to just revalidate that user session at any given time and prompt them to re-authenticate automatically? Or do we want to proactively try resetting their user credentials and forcing them to go talk to someone in IT or security help desk to get access again, based on, again, the level of criteria that we've defined ahead of time that they've met? What are some bad use cases? Automation to the extreme. We should never automate an agent to automatically determine whether or not something constitutes a breach, even if we've given it all of the context and into its system parameters about what our definition of a breach is. That's something we should really leave to the legal team and the legal definition and requirements, because of the ambiguity that might exist and the nuances that it really is impossible to get well into an AI system. Any real destructive actions, right? So you're going to see that this is listed here twice because it's that important. So direct wiping of production assets, allowing an agent to ever determine whether it's going to actually remove data, destroy data, or move systems in a way that we can't easily undo. If there's no undo button available or undo action that we can take, allowing an agent to take that behavior on its own, probably not the best idea. We also may want to make sure that we have cases that might occur where availability, especially in the cases of like industrial control systems or medical devices, availability may trump confidentiality. And in these cases, even if we have all of the right signals to want to block or quarantine, taking a destructive action on these privileged assets would be detrimental to the organization. So we don't want to use any of those actions. In those cases, we want that human in the loop decision-making capability to go do that final investigation. I worked on an incident a number of years ago. We were conducting a pen test, and it was a great example of good and bad scoping and pen testing, because we had a laser knife that was in scope and was remotely accessible. Our team was actually able to get onto this system, and when we did, we realized it was being used in live operations. These are really dangerous, of course, right? Because thankfully, we were able to understand that that machine was in real-time use in an operating procedure based on the things we saw and stop our activities there. But what if we didn't, right? What if we were an AI agent who didn't have that human context? That could have caused, irreparable harm to someone. And then last but not least on this list, we want to make sure that we're not creating echo chamber tuning. Allowing an agent to tune itself and to self-tune will put it in an echo chamber where inevitably it's going to create its own weights and balances and biases that may end up silencing detections or otherwise minimizing the severity of an alert inadvertently because of the volume of that. We've seen things like this where early on in AI use in code security scanning and bug fixes, we've seen AI accidentally or purposely delete entire code bases because it determined logically it couldn't possibly fix all the bugs, and the best course of remediation was just to delete and start over. This is also true of tuning in the SOC. Does turning an alert off actually mean the alert isn't relevant anymore? So let's talk briefly about some blind spots and agent automation risks. As of 2026, we have a number of studies that have shown that the overuse of AI creates a cognitive debt, meaning it's making us less intelligent. If you want for more reading, there's a great paper called Your Brain on ChatGPT, Accumulation of Cognitive Debt when Using an AI Assistant for Essay Writing. Or you can also look at the Purple Book, which just released its 2026 State of AI Risk Management report, which also has a ton of data around how things are being used. In that one, and in that report, we actually found a study that showed a confidence gap where 92% of leaders trusted their AI detections, but over 70% of the organizations have found vulnerabilities or significant deficiencies in their AI-generated production content. We also have to worry about hallucination risks. They're ever present, and anyone in the space is no stranger to seeing fabricated content from an agent. We also have AI shadow governance, when the agent makes a consequential triage decision based on any of these default conditions that might be vendor built or weighted in the model outside of the control of us as the active users. And last but not least, we have agents that are non-deterministic in nature. And while it's their biggest strength, it's also their biggest weakness. In identical conditions, on each iteration, the agent may behave differently and follow a different process and have a different outcome. So even with testing and tuning, there are many cases where it still may act unexpectedly or provide a different outcome, even when presented with the same cases. And so with that, I will leave you with our last topic here, which is the risk matrix. When we're looking at the operational, behavioral, adversarial, and compliance risk types, we can see that AI is running at 99% accuracy is what we think we see, but the model drift means that it's probably not accurate today and it's looking at something old. We've also seen that analysts feel that they're faster than ever, but there's an automation bias. They are faster because they stopped verifying the content, and now we're seeing more false positives or we're trusting blindly. Our firewall blocks malicious IPs, but adversarial AI attackers are using prompt injection to bypass this triage. We have an AI policy in place, but yet 60% of our employees are using unimproved tools. So how do we do it right? Well, we have multi-model checks. We can use a check and balance system and employ multiple models all at once to look for inconsistencies. We can always require the models in the cases we use them to show their work, and also make sure we have sufficient logging so that we can trace back and triage later. And remember, don't take any automated action that you can't easily undo in a tangible way. Truly destructive actions are never going to be safe. Make sure human in the loop. You're going to be sick of it the longer you spend in the AI space of hearing it. It's the new buzzword, human in the loop. Designing for human in the loop will allow you for soft versus hard containment and will allow you to prioritize non-destructive responses where you can do things that you can automate safely. And last but not least, the undo button for graceful degradation. Always have the ability to take every automated action and undo it via a programmatic rollback. This will make sure that you don't create any pitfalls that we've seen in the industry already with destructive actions that we can't easily undo. Now, this doesn't mean that you should stop using your auto-scaling containers or self-destroy containers, but it does mean that you shouldn't destroy the data those containers are attached to. And last but not least, make sure that you plan for failure, because what happens when your AI is inaccessible or it goes down? Many companies are leveraging largely these third-party models that they're accessing over the internet. So what happens when you don't have a high priority connection? What happens when you run out of tokens? What happens if that model or service goes down? Make sure that you have a tested manual workflow. So even if you're using AI in your workflow productively, you do have a backfall plan anytime there's downtime or issues. And with that, thank you so much for coming on this journey with me. I know that that was super dense. I did try to cram a lot into a short period of time, but I really am glad that you've all come on this ride for me. Please feel free to ask any questions that you have later on, and I'll turn it back over to Bryson.
You're not turning it back over yet. One, don't check Signal while you're on your talk, which you already learned while I'm texting you. And two, from Josh, this is such a good talk. Like, can't express how good this is. Where can we find more from Christian?
Oh, thank you so much, Josh. I really appreciate it. So I have a couple of different talks on YouTube. One of my favorite talks is actually I presented at JohnCon every year. And one of the reasons it's my favorite talk to give is it's a panel where I stack a bunch of my friends onto the panel who are all your industry faves. And we draw topics that we get as audience submissions out of the bag. We let everyone submit them at the conference front desk, and we do this towards the end of the conference so everyone has a chance to submit. And you can actually see a couple of those recordings online. If you Google on YouTube, you can find it under my name at JawnCons, JAWNCON. It's run by Russ Handorf and his wonderful team of volunteers out in Philadelphia. And that's one of our annual events there now.
So I've got a question. We had a discussion in the chat earlier on UniCon, and we were talking about the challenge with the fact that there's all of this discussion around artificial intelligence, right? Everybody's kind of wondering, like, am I going to have a job? How do I use it? And there's a lot of research that's being published. But as always, research is well ahead of the curve of adoption. Enterprises are not at the cutting edge of where adoption is going to happen for third-party risk management, and a lot of different challenges. The way I summarize that for folks is, remember how bringing the cloud in was a thing? Well, now imagine the cloud coming in and being able to do something to you. So how do we help drive that to work, that we're not creating more issues for ourselves? And where should these executives be looking for that kind of information?
Yeah, I think those are really great questions. I think looking at a lot of the research papers that are coming out, and again, as I mentioned early on in the talk, emphasizing that it is a tool, and it's also in many cases a tool we don't have control over. A really good example of something that went wrong was recently there was an issue that was actually opened on Anthropic's official repository on GitHub, where someone had incredibly well documented the degradation in their own use case with tangible data. It was quite a long issue, and it was really well done. Talking about how over the last 3 months, they went from almost a 100% acceptance rate from their output in the workflow to a 0% output over the course of 3 months with changes made by the model. So remembering that a tool is a tool, and it's also a tool we're purchasing and consuming from a vendor who's changing it in real time. Those are the kinds of signals and things we need to look at, and we need to make sure that we're incorporating those into our own internal risk models when we're making decisions on how we want to use these tools in-house. Sometimes it might be a better case, if you're really relying on a specific tool in-house, to consider whether or not running a local model internally is the right decision for you, if you're the right type of organization to use that in your workflow. That way you have a higher degree of control and customization with it.
Awesome. Well, that was a great talk, Christian. I really appreciate you joining from Japan. Like you probably are the furthest one presenting. If you've got anything else, let us know, and we'll make sure that we get your recording over to the UniCon playlist, most likely tomorrow.
Awesome. Thank you guys so much for having me. It's been an absolute pleasure.
Yeah, thank you. All right, with that, I'd like to welcome Scott Hamilton and Ed Lowlevel, who are going to be talking about an executive view around purple teaming.
So if Christian wins the award for the furthest away, Scott wins the award for the most broken knees.
The most broken knees? Why is that?
That was a military reference.
Yeah, all the years of running up and down Ardennes Boulevard there on good old Fort Bragg. Yeah, absolutely.
There you go.
Thanks for that, Bryson. Hey, Ed, good to have you on here too. So kind of, what I want to talk about today is, the executive kind of view of like what purple teaming is, and like what are some of the recent events that have happened, across the globe that have really kind of started to, cause some issues, in the world. So I know not everybody knows what purple teaming is. So I kind of wanted to give just a quick little highlight as to what, Scott's definition is of kind of like, what is a purple team. And in my words, right, it's the execution and discipline of converting fast-moving threat events into rehearsed decisions and observable controls. And so how does an organization observe controls and observe things that happen that matter? And when you do purple team exercises, it matters to environments because you need to have red teams and offensive people come in. But you also don't want to bring down environments, especially if you don't have a test environment, which a lot of organizations don't always have a test environment. They only have production. But if you try to red team your production instances, you might have some downtime, depending on what type of exploits or other things that you throw. So keeping the safety of those environments and just kind of trusting the purple team process, and then having the evidence that you need to make sound decisions as defenders, kind of for some of those things. So with that, right, so the AI has been really kind of changing the threat landscape, for organizations. And And I say this because now, like, we've seen a huge uptick from attackers. The phishing campaigns, the social engineering campaigns are happening much faster in much faster scales. The vulnerabilities that are getting developed is insane. I think you just recorded a video not too long ago about a rot chain being developed, by one of the AI models, and it actually, worked. And so now the barrier of entry for exploitation is getting lower and lower, and people who aren't even really comfortable in the field, that would have no idea how to even make a rot chain, now can, right? And so the ability to be an attacker for like nation states is becoming easier, which is also harder because now the defenders have to get better at defending.
It's the old adage, right? It's like defenders have to be right every time. Offenders only have to be right once. The barrier to entry for
I'm gonna jump in here. One of you needs to mute your mic while the other is speaking.
Okay.
Margot can't hear you even with your dog hearing.
Okay.
Might be you, Scott. There we go. Okay. So I mean, defenders have to be right every time. Offenders have to be right only one time. And for a long time, the barrier to entry to offense was talent and speed, right? Like, how much talent does your organization have, and how quickly are your policies and bureaucracy going to allow you to do that, right? And with AI now, the defenders can act faster, obviously, on the defense, but the attackers can act faster too. And so all they have to do is get into your organization one time, and that's kind of where the explosion happens, right? So yeah, AI is making things very, very complicated. Give it to you.
Yeah. And so, with that, right, like, how do we now as defenders start, utilizing kind of the same tooling to help, defend our own organizations against our own assets? And that's where, there's lots of organizations, lots of companies that are, utilizing things like AI and LLMs to help compress the timelines that it would take to do analysis of, say, log events, or do analysis of, other types of things that are going on in the environment. In this way, we can hopefully cut through some of the noise and the fluff, and then actually get to, like, okay, I see this now kind of like true incident that happened in my environment. How do I now go, put my, my actual defenders on these things to confirm some of that? But with that, like, I'd like to kind of talk about some of the events that have happened just this year. And whew, man, it's already been kind of a spicy year. I mean, we can look back from like the XZ utils, that happened. That was also, software supply chain kind of, incidents. And then, there's, the 2025 with Lang Chain and Lang Graph. Even here recently, right, in March 2026, the crack armor exploit that was there for the Ubuntu systems, right? Like, that's kind of a big deal because Ubuntu is a very, common operating system that's used throughout, both home labs for local users, developers, as well as organizations. And then now, they had a flaw in the system that's supposed to be protecting it. And so, like, those are huge, huge problems. And of course, I think, one that's really been scary here recently is the Tree and the Light LLM supply chain attack. And this has really compromised a whole lot of environments that people weren't, really expecting to even have compromised. So now, thinking about some of these as a purple team, how do we then kind of mimic some of these types of attacks that have happened, and then how do we start trying to like control? How do we measure the blast radius of these types of events? What is the blast radius?
Yeah.
What is the speed that we can kind of detect? For some of those, I'd love to hear some of your thoughts on that too.
Yeah. I mean, I think for a long time, purple teaming was not only like the response to an intrusion, but also how hard is it to intrude, right? How hard is it to get in? And then what is the blue team observing? What metrics are we creating so that we know we're about to be accessed, right? And I think all of these events kind of show that the trend, at least in purple teaming, is shifting more to the right, where it's like, hey, man, you kind of need to assume a compromise. And then the question is, what do you do from there? How do you reduce the blast radius? And I think a good exercise for purple teamers in this realm are like, hey, give your red team a credential to the cloud that your devs use, for example, right? How quickly can you identify and remediate that, right? What is the flash to bang on reducing the attacker's access, right? Because that's the nature of all these attacks. You have some supply chain compromise that your organization basically had no control over. How do you remediate, right? That's kind of the nature of the game as the supply chain game becomes more prevalent, unfortunately.
Yeah. So I guess, kind of want to get some of your thoughts also, like, so based off of like the trivia type event, the light LLM, and like the NPM one for, the Axios, I think I'm saying that correctly. Which one of these scare you the most? And, which one of these should we be looking out for going in the future?
Yeah, I mean, I think honestly, it was a combination of light LLM and Axios, just because of how pervasive those libraries are, right? Like in my personal time, I have a website that I maintain, and it uses Axios, man. And like, you could argue that I'm a bad sysadmin for not updating my packages, but at the same time, me not updating packages is what prevented me from getting compromised by Axios, right? So it's almost like flipping the pin on its head. It's a kind of reversing all of the procedures we had as sysadmins, as people maintaining systems. Like, oh, stay up to date. Obviously, that's how you keep a system healthy. And it's like, well, no, you could make an argument that the latest commit, the latest tag on any given npm package is a team PCP package that's going to get you pwned. And it's like, okay, so how do we deal with that as an organization? I think you have a slide on this going ahead. I won't get too ahead of myself, but generally, it's basically any one of these packages where, because for a long time it was like, how do you hack a package, or how do you get hacked by these packages? Oh, well, someone in engineering downloaded a VS Code extension with 2 stars, but Axios has 100 million weekly downloads. That's a very different conversation.
Yeah, no, absolutely. And you're right. Like the leading in like to the next slide, right? Like it's the difference of like the purple team and also like the operational team. From the outside, you have this patching paradox. If you wait too long to patch, then obviously there's vulnerabilities that are published, and then you're vulnerable to those those vulnerabilities because you waited too long to patch. But then, like you just as you mentioned, if you patch too early, you can be the victim because there's that supply chain kind of piece, and we've seen that recently. And so now, as an organization, how do we put the proper processes in place to defend against potentially these compromised packages? Do you update all the time? How do you test these types of things? What is your internal procedures for these patches? Because I know like certain organizations, they wait at least a few cycles before they update. They don't always update right away because they want to they have like a dev test and prod. So like they'll do some updates in their development environment. They'll do some updates in kind of like their test environment, and then eventually they'll run them into production in a perfect world. But not every organization has resources, to be able to also afford, that, those things also cost time and money. So, but how do you put, those types of checks in place? So this way you're not just updating blindly and now kind of becoming the victim, because like I said, from the attacker side, it looks like they're going after this type of vector, the attack vector, more often. Because I haven't seen supply chain attacks, really up until like the last year or two, where they've just been now flooding, compared to other types of attacks.
Yeah, it's interesting, right? I think what organizations can do, and this is like, it's going to turn into an arms race where, you have the way that you handle updates. Attackers will observe that and they'll change your TTPs, right? But what you could do is just have an environment that's very minimal, call it a Docker container or some kind of Kubernetes instance. And it's like, hey, we test updates over here. And like, we go and observe these updates. Why is the update making a weird call out to some URL on port 8081? Okay, maybe we deal with that. And obviously, the maintenance of that and the execution of that pipeline takes personnel, and that's not a free thing to do. But I think that's a very low lift kind of way to create a very lightweight environment where you could test these things. Because ultimately, at this point, I think the answer is you have to be observing updates if you want to be one of those first people to update, right? But if you can't afford to do that, I think honestly, I have to recommend like maybe you wait a few days on updates, because we are luckily as an organization or as an industry catching these malicious updates. It seems on the order of hours. I think the Team PCP Axios compromise only lasted 3 hours. Too long to happen at all, but better than 3 weeks, right?
Yeah. So looking back, right? So like the SolarWinds compromise that happened way back when. How long did that take to detect versus how long did it take for this one to take to detect? So like I do agree, like these are happening faster from like the detection side, but as you said, even 3 hours is still too much, and there were still measurable effects that have happened across organizations, and I'm sure we'll hear about it for the years to come. That's the actual damage that it did. Right. But with some of that, right, I kind of want to move into like the next slide, into like talking about, how do we, detect some of these pieces? Do we detect at install and then we're like build execution for some of these? Do we, how do we enumerate the blast radius, from these types of events? How do we patch, as an organization coming up with like that policy mindset? How do I, as the CISO or all my security operations folks, how do I patch not knowing that if I can trust security of this kind of patches that happen in our various products? So like every organization, right, is comprised of tons and tons of different software products from, potentially across the globe. So how do I reduce my risk as an organization where if I do have a bad patch, what is it affecting? And then measuring like what kind of outcome is it going to have on my day-to-day operations? Because in particular industries, right, the finance industry, the healthcare industry, government, right, those are a lot of systems that just can't fail, right? Because if they, if those kind of systems fail, then it's causing catastrophic effects. So what are the plans that we're coming up with to kind of patch these things? And then also, right, everyone's using a lot of the AI enhanced tools these days. So how do I kind of constrain my various AI applications to ensure that, if it goes rogue in my organization, that it's a limited blast radius. And so I think these are, the kind of things, right, like as a purple team environment, we need to start thinking about planning for and ensuring that leadership from all levels in the organization start to understand, like, these are the things that we should be thinking about and coming up with solutions for.
Yeah, 100%. I mean, I think what's really cool is like the industry is moving faster than ever in terms of seeing a new type of attack come up and then coming up with the tooling to deal with it, right? I'm seeing so many new products on the market for like easy to use workstation canary systems, right? It'll install AWS token, SSH key, and some kind of other OAuth token on your system. That if one of these, a lot of these attacks at the end of the day, they're just picking up your AWS tokens, your SSH keys, and whatever other credentials you have on your machine, right? It's a really good defense at like kind of that the default thing that all these attacks are doing. And then, yeah, I mean, how can we identify these kind of during execution? A lot of the times you'll see a post-install script fork a new process and it's surveying your machine, right? If you can come up with a good signature for those kinds of things spawning out of node, right? I think that'll catch a lot of the things. It's just being aware, threat intelligence does this, being aware of what are attackers giving right now and how can we integrate those TTPs into our detection systems? A very classic answer, I think, but at the end of the day, those methods will continue to work, fortunately.
Right. No, I definitely completely agree. And so, with that, right, like, can we, talk through some other type of, scenarios of like, like what are things like, a purple team can do, to help posture their organization in a better way. So like one of the scenarios I thought about was like, hey, if we poison the package on a developer machine or potentially in our CI system, how quickly can we detect that? How quickly can we test it? Can we install, we execute, it reaching out and doing things, and then how do we respond, right? And I think these are the types of scenarios that organizations, need to start, planning for, because these attacks are, as we've seen over the last few months, they're happening faster and faster. So in this scenario, right, like, can you walk me through, like, because obviously we both have the attacker mindset as well as the defender mindset.
Right.
So how would you, go and do this on both sides?
Yeah, well, I mean, on the red side, it's pretty straightforward, right? Like it's, I have access to somebody's credentials. I've compromised some system. I'm able to push a malicious update to a thing, which gives me RCE. And again, I go to NPM because it's so popular right now and it's easy to understand. I add a post-install script that pulls down a repo that runs, right? And then how do you mediate that as a blue teamer? It's kind of what I said before. I think, if you are actively watching your network, or at least maybe you have this test environment where you run these updates in Docker images before they go out in that Docker container, that Docker environment is well observed. If that workstation is making HTTP requests related to the node process, you have an issue, right? And I think from a purple team perspective, this could be an interesting, exercise for your red team and blue team to run, where maybe on your local NPM mirror or some other package manager that you maintain, it's like, hey, literally just make a backdoor package, have your engineer unwittingly like install it on their machine and go, just see what happens. You know, how fast can your organization respond to that kind of incident? It'd be a really good way to see like, hey man, if this were to get compromised, how quickly can we respond, and how fast, and how big is that blast radius?
Well, I mean, and to talk more through that, right? Where and how are you detecting it? Are you detecting it potentially at your EDR level? If you have, say, like an endpoint detection, whether that be like Sentinel or CrowdStrike or any of the other EDR kind of tools that are out there, are you detecting it there? Or are you detecting it, kind of once it goes through your potential theme systems and it hits, your actual security logs, where it's all, kind of correlated there? Or are you even detecting potentially any of those things? Like, how are you doing change management for your potential developer workstations, right? And that's where I think it's important to think about as security. Like, we need to have these processes, kind of in place. And this is where, like, what about another kind of scenario, right? Like, what if we have a CI/CD system to where you have mutable tags? What kind of things can you do with mutable tags there, Mr. Attacker?
Yeah, I mean, we saw this in the what was it? I think it was the Axios compromise. Yeah, so Axios maintained no. One of these attacks basically maintained a version of Trivy, I believe, and Trivy got compromised so that people that maintained a particular tag, and get version control, you can tag a certain commit to point to each other, so that instead of using the SHA commit, you can use like a word like release or RC1 or RC2. But the problem is these tags are mutable. So if you compromise Trivy, you can point RC1, which everyone depends on, to other malicious commit, and then therefore you've compromised Trivy and all the dependers on Trivy. And so therefore, if you depend now on Trivy in your CI/CD, where you're doing security scans during builds, which is a good thing, by the way. The fact that someone got hacked for this is so sad. Now you've compromised your package in the process, unfortunately. Yeah, and so how do you defend against that is really the question. I don't know the answer to this one because it's so difficult. It's like the maintainer of this project scanned their code with Trivy, and then like LLM got hacked. Like, that's the story. Like, it's so unfortunate.
Oh, yeah, 100%. And it's just, and like the attackers are becoming, smarter and smarter and finding new and innovative ways. And so, like, we as defenders continue to have to find ways to detect them and then emulate and re-emulate their types of attacks. So this way we can have those proper protections in the future. And so let's look at kind of scenario number 3. There's potentially some secrets, some files, and some data exposure that happens potentially with your AI and like LLM systems, because LLMs are really great, and they would never reveal any types of secrets whatsoever. But now how do we prove this as the attackers, right? Because I want to prove to my organization that we potentially have an application or a system that's vulnerable, and then from the defender side, how can we put measures in place to stop some of these things from happening? Like, what are some of those defense mechanisms that exist for like the AI frameworks that are out there? I think we lost it there for a little bit. That's okay. We can come back to that one. And then there's the fourth scenario that we kind of talked about before with the urgent patch, the urgent upstream trust of verifying your sources that you have from where you're getting your updates, and then are you blindly trusting random internet packages as an enterprise organization? If you are, right, that's a definite risk that's there. See you back there. I don't know if you want to come back to scenario number 3.
Yeah, sorry, my son just got here. He's not very happy. Okay, yeah. So there are tools, luckily, I think, in the industry that are picking up on this issue, and that are actually acting as like a middleware gateway. Basically, AI observability is becoming a thing that is really, really nice. Kids can be the threat, dude. Don't get me started. AI observability tools are becoming really, really powerful in allowing your organization, your CISO, your defenders to have insight into not only what AIs are being used, but how AI is being used, right? That's a really important kind of visibility that we have not had for a long time, that we've had in every other aspect of the network, right? We have the network visibility, your EDR, your host visibility. We have no AI visibility. I think as that improves, we'll have better indicators of compromise, if you will, right? What does a prompt injection look like? We kind of already know the telltale signs, but how do you, in an automated fashion, detect that and react to that? That's a problem we haven't really solved yet, unfortunately.
Right, and then like I said, I was going back to the urgent patch piece. And this is where how do we build plans as organizations to go through these? We're going to get attacked. We're going to have a bad update, and then now, like going back to how quickly. Oh, there's a second one. Great. How quickly can we measure the blast rate, and then going back to the paradox. When as an organization do we have the policy to execute our update cycles appropriately? Do we go to we're going to update all the time because we want to have no vulnerabilities or hopefully least vulnerabilities, or do we put up a practice and a policy to where we're going to do kind of the dev test prod? We're gonna do some patching, some updates. We're gonna test those those patches and those updates, and then after we can confirm that nothing malicious is now happening in our environment, then we'll roll out those updates kind of to our production systems. So my question to you is the attacker kind of mindset. If we did this as organizations, do you think that would stop an attacker's thought process, and would they shift now to other types of attacks? Meaning, because if everyone's waiting to kind of not patch right away, then that kind of ruins their supply chain attack function.
Yeah, I mean, I think so. As far as updating goes, everything you do is a risk, right? And risk is a function of what happens if we do, what happens if we don't, and what is the effect if something goes poorly, right? So when you're updating, it's like, okay, this is a minor feature update that doesn't affect an API that we care about. Maybe we don't update, okay? Versus this is an RCE vulnerability in a major component that's network facing. Okay, maybe we do update. And then as far as the attacker goes, I'm not sure if it would deter the attacker as much as it would make their thought process more complicated and definitely reduce the amount of impact that they have, right? Because again, if we're catching these supply chain attacks on the order of minutes to hours, maybe even days, minimum, like ideally less, but if we're reducing how often that we're updating, and then these attacks only occur on the order of hours, then we are just significantly, I guess, reducing the impact that they have and therefore the payoff, right? And so maybe it would push attackers to other vectors. But I would argue that the reason supply chain has gotten so hot is because memory corruption has gotten so difficult, right? Like the ability to throw a 0-day at Windows and just get in is like, it's not a thing anymore. It's not 2012. Yeah, so it's an interesting transition, I think, to just kind of the new world of attacking.
Yeah, no, absolutely. And so I think kind of like the last thoughts. I think we're kind of running up on time here. Is how do organizations measure their defenses? And I think the big thing for most organizations in both teams, right, the red teams and the blue teams, is it shouldn't just be measured if the red team got in. If they got in, that's fine. Like that's kind of some of their goals. But how did they get in? Did we see them come in? And what are we doing to now detect them? Do we have all the proper detections in place? What are all the types of scenarios that we need to be ready for as an organization? Do we need to build and have release trusts for the software that either we're consuming or that we're building on our own? Because some organizations do both. What types of detections do we have in our environment? Which ones are we lacking? How do we get those proper detections from the defender side, and then how do we contain some of those? And then, of course, how do we validate all of these? Like, are we doing any type of, either hopefully, daily or weekly or monthly, quarterly type of, defense cycles to validate that we're actually doing these things? And then, what guardrails are we putting in place now for, kind of the future of as AI is getting implemented everywhere? So to me, like this is kind of like that, that thought exercise. I leave to the audience here. How are we doing this? What are you doing in your organization to help do all these kind of pieces? And with that, we'll probably invite Bryson and Mark back on here to have some closing thoughts.
Well, first of all, a lot of Scott, I think it's on your end. You're Scott. You are the problem.
I am.
Common theme. I'm just kidding.
Ed, I really appreciate you using kids to demonstrate what an insider threat looks like.
Got it. It happens a lot here at my house, so I'm happy to demonstrate. No issues.
So we do have a question from the audience. Should we look closer at N-1 policies with exceptions to critical vulnerabilities, given what's being said here?
I'll start with that. I mean, I think that's a fair policy, right? Like I said before, everything you do is a risk function. And what is risk? It's, what happens if we do, what happens if we don't, and what is the worst case scenario? And so, yeah, if the patch is RCE in your application's a meaningful attack surface, probably patch. But if it doesn't matter to your organization, it may be, depending on what ecosystem we're talking about, worth holding off that update, right? Just because, supply chain is such a hot topic right now. And, my thoughts on that might change in the future as supply chain kind of fades off. But I'm not sure if that's going to happen.
That's not going to happen. And I think it's funny you called it a hot topic now. I feel like that just ignores the last half a decade of it being the thing that has undone everything.
Sorry, hot topic relatively in the last couple of months, but I agree.
One of the other things I appreciated about this is I'm sure other people kind of went, all right, purple teaming, yet another purple teaming talk. And I can empathize with that as one of the original folks pushing purple teaming in the industry a decade ago. But what I loved about what you did is you didn't just do, here's this high level process. You really got down into the CI/CD pipeline, because one of the biggest introductions besides the supply chain of risk is actually the self-inflicted wound, where we're pushing our own applications into our environment. We're pushing our own code into the environment. Why aren't we looking at that? So what sparked that? What was the catalyst behind deciding to bring that view into this conversation?
Yeah, I mean, from our side, right, it's just based off of all the recent attacks that have kind of happened, right? It's, we have to start looking, because, a lot of our CI/CD systems are vulnerable. And I don't think a lot of organizations are putting enough eyes and proper defenses around those pieces. And so a lot of it, right, is I just want to help bring awareness that these are other attack vectors, and that we need to start having the plans and protections in place for these types of potential compromises. Like everything else, it's not a matter of if, it will happen, but how quickly can we react and repair from those types of incidents.
Well, thank you, gentlemen. And Scott, we're going to be doing a GoFundMe to get you a microphone.
All right, thanks.
Yeah, thank you, guys. Appreciate it.
Thank you.
All righty. Well, Bryson, we're at the end. We're at the close.
Yeah. So for those of you at home, you've seen rants that I've done with John going back to 2022. I threw one from UniCon 2023 where John and I did a rant for the opening keynote. If you have questions for me, I will answer anything across the board. You can almost play stump the chump. So throw your questions into the chat and I will get to them. To start with, I mean, let's begin by thanking everybody for giving their time today. I make the joke about I look, I'm as smart as I look. The blank look is not fake. Well, one of the other ones, as you can see by the way I dress, I am a startup founder and don't have a lot of money. So all of these folks are doing it for free. This is a voluntold, community-led event. So these folks donated their time and their content, sharing, what is worth is from what works in the real world, and that's priceless. So I want to just give a shout out and a thank you to all of the folks who continue to do this. And by the way, that can include you at home. We continue to do these things. We do events weekly, monthly, and of course, the annual UniCon that we're going to be doing on April 9th every year, because that's National Unicorn Day. Unless it's a weekend, then we'll shift, right? But you got ideas, throw them into us. info@scythe.io. We're happy to do that. So thank you for the folks also giving all this. I'm gonna just run through some of these, right? So with that, what questions do you have for me? What would you like me to get spicy about?
So Bryson, I'll kick it off because one of the things I think that came out of this session is AI's impact. And I'd like to get your thoughts on how AI will shape some of the offensive capabilities going forward. We play in this space all the time, but it'd be great to get your viewpoint here.
Yeah. All right. So artificial intelligence in offense. What have we seen so far? Some of these have been referenced throughout the day. The first is in phishing. That's AI against AI. How do I use AI to craft a phish to effectively SEO through your AI that is anti-phishing? The other thing that we've seen is the ability to spear phish at scale. So where can I correlate multiple data sets to be able to then craft what would typically have been a custom spear phish for each person? I can now do that across N population all at the same time. The second is AI is used to manage infrastructure. Turns out, right, the world is in three colors: red, bad guys; blue, good guys; gray is that middle that gets from the red to the blue to do what they're doing. That whole middle ground has to not look like red. And so being able to have the tradecraft to hide that, to continually to shift it, because that's where you see the indicators of compromise, right? That's a bad IP. That's a bad domain. Cool. They've already moved on. Their campaign is working just fine. And so being able to shift that quickly is another one. Then, right, the same way that you're vibe coding and prompt engineering to drive things is the same way that the adversary has been seen doing that as well. That, I think, has had about the same level of success. We still don't have the ability to drive a code output, i.e. real malware from AI that doesn't require an experienced operator. Just like in the real world, it requires an experienced developer to be able to check these things. So we're still seeing that. One of the things that I've been excited for, so if you've been following what we've been doing in our press releases here at Scythe, over a year ago, we started an artificial intelligence research and development project with the Defense Innovation Unit and the Persistent Cyber Training Environment, which is the DoD's cyber range for everything. And some of those things have been, how do we use artificial intelligence to consume threat intelligence and turn that automatically into attack campaigns? One of the things that I'm really excited about is, if you go back in the time capsule, I gave a talk at ShmooCon in 2018. And what I talked about was the idea that, and you've heard me say it, and you'll hear people say it, right? Cybersecurity is unsolvable. It's unsolvable because it's this mix of the personnel and the technical. And we can't change the human element. And then the problem is, well, a lot of the defenses that we're doing are technical, so it's not solving the problem. And from back in my time when I used to run an APT, we always won. I continue to think, well, why did we always win when I went into the commercial side and looked at how red teaming worked? And it's because when we look at the entire attack chain, it's infinite between those people and those technical pieces. But is that case for all of it? And for those of you who've heard me talk about the Bryson attack model, the BAM model, that's where I simplified and realized that starting in the post-access space, that's where it's not necessarily infinite and completely unconstrained. And a hacker can only hack your computers. Those computers can only do certain operations, so I need their computational capacity. And then, like I was talking about in the detection engineering, you have to marry host and network detections together, and they have to speak your protocols. So those are all things that we can control, and that's the opportunity in the surface area of what we can control. And so it's interesting, with the advent of artificial intelligence, we now could potentially orchestrate all of the probabilistic attack chains to completely quantify cybersecurity in that space for the first time ever. So that is the big, hairy, audacious goal. That is our research project here at Scythe, where we're working to be able to exhaustively be able to prove that, because there's literally nowhere else an attacker can go. Up to this point, I've been preaching that if you focus on detection engineering, you're going to start connecting attack collisions, which means this attack campaign by this threat actor versus this, I'm trying to do it with two hands, versus these. Well, this one at number 4 and this one at number 7 use the same command, and this one and so forth. That's where you've been able to find it before. Well, now imagine being able to take all of those away. Anybody who promises they can stop O-Day is lying. Somebody who promises that they can start to help you narrow that path in a post-access environment, there's a hint of truth there. And I think with artificial intelligence, there's the potential for the first time we might be able to quantify that definitively.
Hey, Bryson, there's a couple of questions. There's one about just, what do people do that are in small organizations?
Right. So this is where I continue to bring this up over and over because I'm tired of all the talking heads and we find all of these ridiculous little edge cases around a problem when the reality is 99.999% of organizations don't even have accessible to basic cybersecurity, right? It's like saying, you know what? I don't really like my Evian when most of the world doesn't have drinking water. It's crazy. So and here's the thing, even if you've built an organization that has great cybersecurity, whatever that might mean, what do you think a supply chain means? What do you think all of those less insecure components mean? They're all trusted access and relationships back into you. That's one of the things I liked about Carolyn's talk is she was talking about how the trust model is moving just as quickly. Well, that's supply chain. And so you having a stronger cybersecurity doesn't mean a hill of beans if you're connected to all these other smaller companies who don't have a chance with it. And by the way, compliance isn't security, right? So pushing the questionnaire of this level of compliance and all of the garbage approach at third-party risk management doesn't solve that problem either. So when I look at what can you do as a small, one, this is why I like Atomic Red Team. Anybody who is not a red team operator can drive Atomic Red Team. I often say, right, in purple teaming, you don't actually need a red team. You need a red signal. Atomic Red Team is your red signal to get started. Second, okay, great. Going back to the comment I made earlier. So you found the problems. I'm too small to understand how to fix them or what to do next. Well, that's where Tyler posted the free GitHub that we share here at Scythe on the Sigma engineering. Sigma is the answer to how to approach detection engineering. Now, the qualifications to that is there are no silver bullets. So our Sigma repo doesn't necessarily apply to everybody equally, and you're going to have to just be careful to make sure it works for you. But that is a great place to start with what I always say is the best price, which is free. That's a lot.
It is.
This is talking about earlier what I was saying. IAM, identity management, is going to be, I think, the hottest topic this year and probably going forward. I'm building a zero trust system for critical infrastructure where AI agents can only act after a hardware-bound human identity gives scooped cryptographic clearance, a cryptographic passport. What do you see as the biggest shift in IAM where we move from traditional user logons to these agents to human-in-the-loop setups? So nice timing because I just spoke at DOW's Zero Trust Conference yesterday, day before, I don't know, what's today? Sometime this week, I just spoke on this concept of zero trust and how to approach it. Also just want to throw this in here, because if you're looking at how to get involved with our experts and talk about this stuff beyond just every April 9th Unicorn Day, Ramses Nicholson, who leads our customer support, we have our own Discord server where we're sharing and talking about this stuff all the time. So back to the IAM question. The biggest shift is going to be, I mean, literally what you described, right? So it's the fact that we have non-human identities, NIH. We're still struggling around the human identity problem. I mean, again, what does an attacker do? An attacker masquerades as an actual user with those credentials. I look just like everything else. The only thing that's distinguishing me is my network traffic and my user behaviors. With an agent, well, how are we doing that? So this is where I was, I posted about this, I think the other week. We didn't quite get into it as much as I would have liked on the Unicorn Dispatch Live, but I had Tom Quinn from T. Rowe Price. He and I sat down for one-on-one out at RSA conference in San Francisco. And we had a really detailed conversation on how to approach agentic security. So this is the CISO of T. Rowe Price, one of the major financials in the world, going, what in my views of agentic security? The first point is they don't currently have agents in their environment. This is part of where I was trying to drive the conversation earlier is organizations' risk levels mean that they are going to be slower to these adoptions. So they are looking right further out to when they're going to be bringing that agentic AI in. Two, this is a lesson we've learned here at Scythe. As we have incorporated artificial intelligence in our own platform, we have run into the regulatory and the third-party risk frameworks going, well, wait a second, hold on. Just because we love you and trust you and all the things you described to us, you're going to really have to go an extra effort and let us do our own review on how you've implemented artificial intelligence inside of the trusted platform of Scythe before we can adopt that. So this is going to go to when this future happens. And I think 2027 is the year that agentic AI starts to really be a thing. And organizations then have to move from all of this discussion about it to doing it. And so here's going to be the things, right? So going back to the question, non-human identity, how do we centrally manage that? Which is going to lead to the following. How do I have visibility on my agents? How do I have visibility on my agents? What does an agent look like? What is the fingerprints of an agent for me to be able to do discovery, right? We have the same problems of shadow network, shadow assets, shadow IT. Well, shadow agents are going to be a thing because it's so easy to deploy. So that's going to be a significant part of the identity, the discovery, and the management of them. For the security of them, I think every agent is going to need some kind of shim that functions almost like a software firewall to ensure the authentication and the identity of everything it's doing. And I think that that firewall is going to also have what I'm going to metaphorically call verbs. And essentially, we're going to codify almost like an RBAC to identity of how and what exactly is allowed to be done through and around that agent through that shim.
Yeah, I mean, Bryson, one of the interesting things with the agent is sub-agents, right? You got to know where that agent, where its origins are, right? What's the intent of it? There's a lot of other things just beyond identity that will affect security. So I think those were all the questions I saw in the lineup right now. So I'm not sure if anybody else has anything else. I know we've got about 10 minutes left, but we can certainly give you guys back a little time. It's been a great day of talks. Any last questions for Bryson or myself?
If you love what we do and you love saving endangered rhinos or endangered species, or you love, if your questions are spicy, you can still ask them. Bring it, Noah. Swag.scythe.io, all of the proceeds go to a conservation fund. So you get to look cool in unicorn gear. Sorry, the custom hoodies are in fact custom tailored hoodies. I don't even share who the tailor is. I will tell you they're not in the United States. And when I first approached her, she's like, what are you trying to do? And it took a lot of back and forth in another language for me to get those hoodies. So I apologize. Those are not available on it, but a whole bunch of other great things are.
Well, I think we're at the end. Great session. Thanks everybody for joining us. I think this has been a great day. As Bryson mentioned earlier, we're always looking for feedback. You guys have ideas that you'd like to see us, speak about or bring in, and we've got a lot of great formats. We've got Bryson's UDL. We have our Threat Thursdays, and certainly have UniCon, the UniCon conferences as well. So with that, I think we can wrap it up, Bryson.
For those of you asking for more dog, unfortunately, I'm live, so I can't go get her. But appreciate it. Margot sends her love to all of you, and look forward to catching her randomly at a few more things.
Yes. All right, everybody. Thanks very much. Cheers, everybody.